everybody, and welcome to Percona Live Online. My name is Bronwyn, and before we get started today, there are a couple of important things that we would like to share. First of all, this is live and we are going to be live streaming. So in the case of any stream interruptions, please stay tuned to our Slack channel and to our social channels for updates on how to access the stream again should anything go wrong. All of the sessions from today's conference will be recorded and those will be made available shortly after the event concludes. Slack is the official chat channel of the conference, so this is where all of the important updates will be shared. You can access the Slack channel using the link on screen now, or if you would like to ask any questions of the speakers and also engage with other conference attendees, you can do so in the Slack channel. There are also predefined groups set up so you can engage on different technologies or in different languages or however you see fit. So we would encourage you to join the Slack if you can and be part of the community who are viewing it virtually. We would also like to encourage you to rate the talk. So after the speaker has concluded, we would encourage you to go onto the Percona Live agenda, and on that specific talk, you can scroll to the end and let us know what you think. Our conference has a code of conduct and this will be enforced. We would encourage everybody to familiarize themselves with the code of conduct. You can access this on the Percona Live website under the attend button, so please take a note of that. Without further ado, I'm going to introduce you to our hosts, and after that, Rick Vasquez will be taking over and Rick will be hosting the keynotes. We thank you for tuning into Percona Live Online and we hope that you enjoy the event.
Hello, Percona Live Online. My name is Ali and I'm a product designer at Percona. I'm based all the way in Johannesburg, South Africa, and I will be hosting you between 7:30 and 8:30.
Hi, Percona Online. My name is Alex Smith. I'm the Professional Services Manager at Percona, based in the UK, and I'll be hosting the first three speeches between 12:30 and 2 o'clock Eastern Time. Look forward to seeing you. Thank you.
Hello, Bronwyn Cabell here. I am the Global Event Manager at Percona. I'm based in Oldcastle, County Meath, and I will be directing the conference for the next 28 hours along with my team. I look forward to having you all here.
Hello, Percona Live Online. My name is Philip. I'm the DBA Team Manager in the Managed Services Department at Percona. I'm located in Poland, and from 3 to 4 a.m. Eastern American Time, I'm going to be hosting the Percona Live Online event for you. I invite everyone. It's going to be great.
Hey everybody, my name is Kimberly Wilkins and I am the MongoDB Technical Lead here at Percona. I'll be hosting from 9:30 in the morning until 11. See you there.
Hello Percona Live Online. My name is Mukesh Kumar and I am the MongoDB DBA at Percona. I am based in Pune, India and will be hosting on 20th October, 23:30 hours to Wednesday, 21st October at 02 hours EDT time.
Hi, Percona Live Online. My name is Tim Sharp and I'm the Product Manager for Global Services at Percona. I am based on Vancouver Island, Canada, and I'll be hosting on October 20th from 6:30 p.m. to 8 p.m. I look forward to seeing you all then.
Hi, I'm Ian Schlemmer from Hood River, Oregon in the United States. General Manager at Percona, looking forward to seeing you at Percona Live.
Hello, Percona Live Online. My name is Camila Rosena. I am HR Assistant in Percona. I am located in Uruguay and I'll be hosting during 2 to 3:30 p.m. EDT time zone. Welcome and enjoy.
Hello, Percona Live Online. I'm Dimitri van Overbeke and I'm a Senior Solution Engineer at Percona. I'm based in Bruges, Belgium, and I'll be hosting you in between 6 and 7:30 a.m. Eastern Daytime.
Hello, Percona Live Online. My name is Evgeny and I'm the Senior Build Release Engineer at Percona. I'm located in Ukraine and will be hosting from 2 till 3 a.m. EDT.
Hey, how it's going? My name is Gonzalo. I'm the Digital Marketing at Percona. I'm based in Buenos Aires, Argentina. I hope I will see you at Percona Live Online.
Hello, Percona Live. My name is Marcos Albe. I am from Uruguay. I work as a principal support engineer in our support team, of course. and I will be your host on October 21st between 8:30 a.m. to 9:30 a.m. Eastern. Hope to see you there. Goodbye.
Hi, Percona Live Online. I'm Martin James. I'm the Vice President of Sales at Percona for the EMEA and APAC region. I'm based here in Windsor. You can see the castle where the Queen lives. I'll be hosting Percona Live Online from 5 a.m. to 6 a.m. Eastern Daylight Time. I look forward to seeing you then. Take care.
Hey there, Percona Live Online. Guess who has 2 thumbs and is going to be your host from 1530 to 1700? That's right, this guy. Hi, my name is Matthew. I'm a senior architect here at Percona. I'm also the senior instructor. If there's anything training related that you need with regards to MySQL, be sure and give me a holler. I'm looking forward to having fun with you guys over the next hour and a half. Thanks a lot.
Hello, Percona Live Online. I'm Michael Coburn, a principal architect for MySQL here at Percona, and I'm based in Mexico. I'll be hosting between 5:30 and 6:30 p.m. Eastern. Hope to see you there.
Hello, Percona Live Online. My name is Michał Nosek and I'm a Senior Solutions Engineer here at Percona. I'm based in Gdańsk, Poland, and I will be hosting from 4 to 5 a.m. Eastern Time.
Hello, Percona Live Online. My name is Mike Grayson. I'm a MongoDB DBA here at Percona, and I live in the Rochester, New York area. I'm going to be your host from 8 to 9 p.m. for Percona Live Online, and I look forward to seeing you there.
Hey, what's up, Percona Live Online? I am Travis. I am Percona's in-house attorney and compliance manager, and I am coming to you from outside of Boise, Idaho in the United States. I will be hosting a talk this year on Wednesday, the 21st at 9 a.m. EDT, and look forward to seeing you there. Talk to you soon.
Hey, I'm Val. I'm based in Italy. I work in the events team, and I'm super happy to be sharing the next 28 hours with you.
Over to you, Rick.
Hi, everybody. I'm Rick Vasquez. I'm the Chief of Staff to the Chief Experience Officer here at Percona. Really excited to have everybody here for Percona Live Online. We've got a great set of keynotes ahead of us, starting off with the CEO of Percona, Peter Zaitsev. And we're going to be talking about why public database as a service is prime for open source disruption. I'm going to hand it over to Peter, and I'm going to be your spirit guide through these keynotes. Please ask any questions that you have in our Slack or on your platform of choice. I just want to remind you that we are going to be monitoring those, and we'll get those answered. Even if we can't in the talks, we'll get you those answers later on. Over to you, Peter.
Eric, thank you. Thank you for a warm intro and handoff. Let me dive straight into it. I'll talk to you about why public database as a service is prime for open source disruption. But you guys have guessed that already. All right. And 3 things I want you to take away from this talk is A, what the database as a service has won as a way to consume the databases. That really because it offers unparalleled convenience of using the database. And let's face it, we are all suckers for convenience. The second thing is what software vendor lock-in sucks and should be avoided if you can. And third is what, as usually, there is an open source to come to the rescue. But let me take you a bit to the early days of modern open source. And I'm not sure about you, but I got involved with open source in late 90s. And at that time, the open source had a lot more rough corners than it is now. And I remember how installation working with open source was at that time. You had to download the sources, probably find some patch to make it work with your particular compiler or Linux version, right? And compile it. Hopefully you have all the binaries and headers and wherever you need to compile it ready and so on and so forth. That took some time, skill, and effort. when had a good progress in simplicity. We got targz binaries and the install script, which made it easier. Then we from that moved on to packages, which would track dependencies, then to repositories, which will install all the dependencies for you, all the way to those new ways of Docker and Snap, which provide you the self-contained application, right? Where you don't even have to think about what you have to do if you have two different packages which need the same file, but they need it in a different version, right? And stuff like that. As you can see from this trend is what we are moving forwards, making things easier and easier in open source and reducing barrier to entry. To the point that if you look at the modern open source now, what most developers will not be able to build from scratch all the tools they use, right? I don't think many of you working with Linux, for example, build the Linux distribution from scratch and in a long time. And I would say even the open source databases, those days, installing them on Linux use some of the provided binaries instead of building them on their own. And I think that is great because that really allows us to use more complicated and more valuable software. And that allows us to get more people to be involved with open source, being open source developers, or at least the users of the open source. With that, though, comes the dark side, at least for open source, that is. And this is what if the next round of a simplification typically goes with deploying this open source software in the cloud, which comes with a vendor lock-in in the cloud, right? So that is your current state. If you're looking at the open source databases, in particular, you want to deploy them in the fastest and most convenient way possible, you have to do it in the cloud using proprietary API, right? Now, of course, there is an other choice to deploy the database in the cloud. You can build your own database platform using the building blocks of the cloud provides, such as compute, storage, and so on and so forth, right? But that will not be as simple and convenient as you get if you use database as a service. Database as a service indeed provide a lot of value, especially for the teams which don't have skilled and dedicated DBA, as many folks, many teams are at this point in time, right? They can help you to manage and have ability, database patching, backups, security. They provide some easy ways to scalability by scaling instance size, and so on and so forth. One thing what that gives is a more power to developers to build the better apps faster. Because as developer, you don't no more need DBA help, or in many cases even permission to deploy the database, right? You can just pick the database that you like, deploy it, charge it on your credit card, and your manager may not even discover that. And then by the time he does, it will be too late. The application will be already shipped and maybe even in production. And you can rely a lot on the cloud vendor to keep it up and running. And you should not worry. The database as a service and the cloud vendor are open source compatible, at least in the concept of a Hotel California defined compatibility. And what I mean by that is they make it very easy for you to move in, but typically it's a lot harder to go back to the open source because you are going to be relying on some additional features which only those technologies provide. Another thing which we see, especially recently along many of our customers and community members, is what fully managed database as a service tend to be over marketed, right? Same as a burger displayed here, it does provide some value and it can satisfy your hunger, but it's not nearly as fully managed as it may look. You still often need somebody to understand the databases, for example, to decide on a schema, help with some queries, design sane security practices, and stuff like that. What we also found is what in database as a service world, there is increased number of incidents, being that security, downtime, excessive expenses, because developers choose to use those databases without working with database professionals, right? And well, that comes with consequences. Let me share some database as a service stats with you. As I mentioned, the database as a service has won, and it's actually continues to grow. Right now, according to Percona survey, not everybody runs a database as a service yet, but that number is continues to grow, right? The significant number of folks, which is actually high among the folks who run a database as a service, find the cloud hosting to be more expensive than they thought. And the large number of people still concerned with performance and availability problems wherever you run a database as a service environment or you don't. Another interesting thing with database as a service is what you can see what a premium which you charge for a privilege of running that database as a service software versus just infrastructure in the cloud is growing. And as you can see from this trend, which changed from relatively modest 30% to paying essentially as much for the software as you pay for the infrastructure, right? Which ends up to thousands of dollars every year for instance of a decent size. And maybe that is not quite Oracle prices, maybe at least not yet, right? You may see for your infrastructure size, what the database vendor login is not as painful now. But believe me, it's going to be more painful in the future as cloud evolves and also as your infrastructure grows. And there is a history lesson I can use to illustrate that, right? If you see that guy on the left, that is young Larry Ellison. He didn't have that large of a boat at that time. And actually what he was doing is he was saving the customers from big, nasty, big blue, IBM, which really had horrendous hardware lock-in with their mainframe computers and the DB2 database, right? Well, folks have been saved, but how many of you running Oracle feel saved from a vendor lock-in right now, right? As the time goes and companies tend to acquire more dominance, they have a more of a flexibility to exercise the lock-in, of course. So with all of that, the question you should be asking, can we get that public cloud database as a service like simplicity, but as open source solution? Wouldn't be that be great? And I have unfortunately bad news for you. We are not there yet, but we are going there. I think in this regard, Kubernetes is truly fantastic and transformational technology, which empowers a lot of this change. Kubernetes is essentially the operating system, but for clusters rather than individual hosts. It has a lot of momentum and community support. And to the point, what it is universally supported in public, private, and a hybrid cloud. Many companies who used to have their own solutions, right, are either embracing Kubernetes entirely or at least adding that as a support. You know, think about Amazon with its container storage, right? Or Mesosphere with messes, or VMware recently going full on with Kubernetes, right? So that is a foundation which allows us now to build the open source based database as a service solution, which actually can run across a variety of a cloud much easier than supporting each and every cloud directly. The next question you should ask, well, Percona, that is a fantastic problem statement, but what are you folks doing about that? Well, at this point, we have released the operators for the Kubernetes for MySQL and MongoDB, and also we've been working now for years on Percona monitoring and management to be the open source solution to simplify monitoring and in the future managing databases in and out of a cloud. We have now our Kubernetes operator available on the operator hub, for example, and we are really looking towards having the Percona operators available on a variety of on the platform in the near future. One thing you note, though, is what the Kubernetes operators, all right, even if they're deploying on the OpenShift, they are not enough. They don't provide quite the same level of convenience as I can get with Amazon RDS, where I can deploy the data with a couple of clicks of a single API calls. And of course, you are right. With that, our vision is to make sure what we provide Amazon RDS-like experience in public and private cloud with open source software, and as such, with no software vendor lock-in. And that is what we see as one of the functions of what we call Percona Enterprise Platform. Now, don't be mistaken by this word enterprise, right, in the name. While many other companies which use open core model call the enterprise the proprietary software, their community software is open source. Percona Enterprise Platform is open source while offering you advantages comparable to what would be Enterprise Edition, proprietary Enterprise Edition you would see from other vendors. We're not quite there yet. We are working on the Better for Enterprise platform, which is launching later this year. And I would very much encourage you to participate, to sign up for a Better program. So then we are ready. We will talk to you and your experience evaluation and so on and so forth. And of course, addition to that, we'll have the source of this available as well. So if you can choose to play it this way, you can do it as well. So let me leave with what I have started. As I mentioned, the database as a service have won because of the unparalleled convenience of using a database it has. Software vendor lock-in sucks, and the open source is coming to the rescue, and we are at Percona working well to be part of that open source movement, and we hope you will join us too. With that, thank you. That's all I had to say.
Thanks, Peter, for getting us all caught up on why database as a service is prime for open source disruption. And I think we're on to something. I obviously have bought in pretty heavily to the idea that you just put out there. And I do want to encourage everybody that is interested in the platform to sign up for the beta that was shared out by Peter. So we do have our next speaker coming on deck to talk a little bit about the democratization of databases, and specifically in the Postgres space. So we're going to get our speaker queued up there. In the meantime, Peter, did you already go away, or can we ask you some questions?
Oh, of course you can. Of course you can.
So you talked a little bit about the Percona Enterprise platform, and you introduced it. Is there anything that you can tell us more than just that little nugget of information? Is there anything that people can get excited about around that?
I think it's pretty much just what I said. What we're really looking to have a platform, folks, which allow you to really have a database as a service experience in public and private cloud, right? So far, what we see on the market, we see that as a very unique solution to be available in the open source space, and also allowing you not to just focus on the single open source database, but a variety of most popular open source database that Percona supports.
Great. Thank you so much, Peter, for kicking off the conference strong and giving everybody something to get excited about. Okay, it looks like Bruce has joined us. Bruce, I'll let you introduce yourself and then hand over the keynotes to you. You may still be on mute.
Hello, everyone.
There you go.
Wonderful to be here with you. This is my second opportunity to speak to you at the Percona Live conference. I was very inspired by the last one and the sort of 24-hour plus format that you used. And I even blogged about it. I said how great it was. That it was an example that other conferences could use to see what can be done during these difficult times with the pandemic and a lot of lock-ins. So again, great to be back. I am excited about this talk. My name is Bruce Momjian. I am one of the Postgres core team members. I have been working with Postgres for 24 years. I've been involved with open source for 29 years. And this talk is a very unusual one. About the democratization of databases, which you probably never thought you'd hear before, but I hope you will find it interesting. The slides that you're looking at are available on my website. If you look at the bottom left here, this URL, there are probably 20 or 30 presentations there, 640 blog entries, a lot of interesting information, hopefully, if you're into databases, if you're into open source. If you're into sort of hardware and stuff, feel free to check it out. But these slides are available right now at that URL. What we're going to be talking about today is a very, as I said, unusual topic. I started to think about this when people ask me, how does open source work? Why does it work? How are you able to produce software as good as commercial companies, large billion-dollar commercial companies with no money? How are you able to guarantee, reliability and feature set and interoperability and so forth? And I started to kind of think a little more broadly. I'm a history major, so I have a tendency to think in historical terms and in broad terms. So that's when I got to think about the parallel between different governmental structures and open source. This is not a topic you hear very often, But I think you'll find this quite interesting. So what I'm going to start with is talk about the history of governance structures. There's actually some interesting information I didn't even know about before I started. Then we're going to talk about the strengths of each structure and also the downsides, the efficiency, as well as the messiness of democracy. You might think I'm just going to say democracy is always great. No, I'm not going to say that. There are some downsides to it, and I'm going to highlight that. We're going to talk about the ultimate success of democracy, and then we're going to talk about software governance in terms of history. So, what is the history of software governance? How does it relate to federal governance or provincial governance? Um, how does that impact Postgres? Which is what I do. I'm an Enterprise DB employee and obviously core team member, so I have a real interest in Postgres. And then we'll talk about democracy in action. What does this actually look like? So let's talk about the history of governance structures. I knew that democracy started in Greece from my studies, but what I didn't know is that democracy in Greece started at a specific place in Greece. It actually started on Pink's Hill, which I had never heard of before. But that actually is the place where democracy started, where the first sort of democratic meetings of the Greeks happened, obviously thousands of years ago. But I thought it was interesting. But the real original governance structure is not democracy, obviously. The original governance structure is autocracy. You can think of it as the chief of a tribe or a king or an emperor or pharaoh or something like that. Usually it's a single person or small group of people who were in power. So it could be a dictatorship, it could be a monarchy, it could be communism, which sort of morphed into sort of an autocratic structure, even though the original goal was certainly not to do that. But this is certainly the first governing structure that you have, and as I said before, in Greece was the first sort of non-autocratic structure, and that non-autocratic structure kind of came and went as history moved forward. Again, representative democracy first established in ancient Athens, and it wasn't completely democratic the way we think of it today. It was really only a small group of the population who could vote, landowners, and they elected representatives to vote on issues. So it wasn't sort of a plurality of everybody. It was a small section of society, but it was the first kind of democratic representation. So having talked about those two structures, let's talk about the strengths of each structure. And you'll notice here we have kind of a curved castle wall. It was kind of interesting. So autocratic strengths. Again, I wasn't going to say democracy is fantastic. There are some strengths to autocracy. It's good for focusing a fixed amount of resources on a clear goal. They do that very well. For example, space exploration or the military are traditionally autocratic. In the military, you don't take votes, right? It's a very top-down structure because of the goal of what needs to be accomplished, because of the seriousness, I guess, of what's going on. It's a strong, it has a tendency to certainly be an autocratic structure. In fact, some have complained that, we have democracies protected militarily by autocratic structures. It's kind of interesting. The other interesting thing is that the USSR, their strengths, if you think of it, were certainly military and space exploration. Those are areas they did really well. Democracy has different strengths. It allows rapid adjustment for unclear goals because it isn't a top-down structure. It isn't a structure that where you have kind of one person or one group kind of passing information all the way down. You're emboldening people to act near the problem. So in a lot of ways, it's a structure that enables people who are close to the problem to solve it instead of having to call up the chain to get an answer. and then, wait for that answer to come down. And the decisions may be made by people who are thousands of miles away. Democratic strength certainly expand the talent pool. Things like consumer goods and software, where you don't have unclear goals, where you want to basically, marshal a lot of talent to the problem. Democratic obviously works very, very well in those situations. But it isn't always great for democracy. This is a you know a rally in Wisconsin from a year or two ago. It certainly looks kind of messy, but you get the idea. A lot of people were engaged here. So um, efficiency of democracy, it unleashes a flurry of power, um, of activity based on personal power, and it works very well with fluidity of solutions, right? But it's very hard to predict democratic behavior. It's not like you can have a 5-year plan and say we're going to produce X steel during this 5-year plan. It's kind of fluid, right? Problems can get stuck. And I think of the United States, and even in Europe, I know that they've got some problems that just kind of get stuck that we can't solve. And it's very frustrating. And certainly if we had an autocracy, it would get unstuck before good or bad. Somebody come in and say, okay, we're going to take care of this problem. I don't want to mention any problems, but you get the idea. It has difficulty with large projects that span multiple elections. So if it's something that's going to take 12 years to do, is the government that's elected during those 12 years going to remain engaged and wanting that project for the entire 12-year span? And that's why a lot of times things get stuck. I'm thinking particularly of a tunnel, a railroad tunnel that was built between New Jersey and New York by the Pennsylvania Railroad in 1910. It's still being used 110 years later. They want to put in 2 new tunnels. New Jersey, New York, and the federal government can't agree on who's going to pay for it. So we built, one railroad company built 2 tunnels in 1910, and we can't figure out how to build 2 more tunnels 110 years later. That's dysfunction. That's stuck, right? But it's a multi-billion-dollar project. It has a history of cost overruns. It's just very hard for those governments to get together to solve that problem. I'm just saying, I'm not saying democracy is bad. I'm saying it has negatives. But there is ultimate success of democracy. This actually is a protest in Moscow. I believe it's for Alexei Navalny. But anyway, it's example of sort of democratic forces that ultimately, it seems like that's the way things are progressing if you look back through history. So you have but again, it's a checkered past. It's not like it happens and then it goes away, right? So you have your first democracy in Athens, but then it's suspended during the I believe the Peloponnesian Wars. So yeah, democracy in Athens, and then it gets suspended because you're in war. Then you have Roman democracy, and it ends in dictatorship with the Caesars and the emperor, right? Kind of a good example. You have the Middle Ages, and you have the Magna Carta and the Renaissance, but again, kind of back and forth. You have the American Revolution, which wanted to give voting rights to everyone, but everyone was not everyone, of course. Black people didn't have votes. Women didn't have votes until the early part of the 20th century. Okay. So again, not like the United States, just everyone votes and we're done, right? French Revolution, it eventually leads to riots and anarchy, and then you have the monarchy after that with Napoleon, right? So, or Napoleons, right? So it's not like a one-way street. Democracy makes inroads, but then it goes backward at the same time. Then it makes some inroads and goes backward. It continues to make steady progress, but again, there are still setbacks. This is a great graph. Again, down here at the bottom right is a link to the actual report. but this is the number of people under different types of government structures. The green is democracy. The red, I believe, the red is autocracy. So you can see that autocratic number of people is probably pretty steady. The democratic number of people since 1916 has continued to dramatically increase. Here's a better picture or a different picture, more looking at land masses and countries versus population. At the bottom, in blue is the democracy. The sort of mustard color is autocracy. And at the top, 2017, you can see there's a lot more blue there. So again, it is a slow progress as society sort of haltingly embrace democracy with some setbacks. So what does this have to do with software? You might recognize this. This is the Oracle towers from Redwood City. You might notice that it looks a little like the castle towers that we had in an earlier slide. So it's just, I thought that was kind of funny. So what does this have to do with software? I think it has quite a bit to do with software. Because historically, when software was created, it was autocratic. When you think of IBM, Sun, Digital, Oracle, all of the HP, all of the sort of big autocratic, we're going to produce the software, we're going to give it to you, kind of autocratic software development systems. It's, that was pretty universal, at least when I started in computers in the mid 80s. And in fact, even back to the 70s, super autocratic. And in those autocratic systems, executives make decisions. So the information comes up from the organization. It comes primarily from sales and marketing. Now, if you've ever been in a company, a proprietary software company, most of the decisions and most of the input that executives get to make those decisions come from the sales and marketing departments. There's some from engineering, but engineering's responsibility a lot of times is just to say no of what is not possible. But in terms of what direction to go in, it's normally coming from sales and marketing. And then you have engineering basically saying, no, that's not possible. And then maybe changing course based on that. There is indirect input from customers, but again, it's indirect. It's not direct. It's got to go through your salesperson. It's got to go through some kind of marketing, process. And the decision matrix that these executives go through when they're making, the decision on the software, is pretty unusual. Like, for example, the first sentence, if we do this, what percentage of customers will we gain? If we don't, what percentage of customers will we lose? And these are really sort of the fundamental decisions that those people are making. The gains are more sensitive to the decision than losses are. You have a tendency to as executives to favor things that are going to gain you market share, and you don't normally are as concerned about losing market share, partially because you assume that most of your customers are hostage or have very high barriers to exit, and therefore you have a tendency to favor gains. Also, this is why how a lot of companies destroy themselves, because they don't realize that they're losing market share because they're not focused on that. They're not focused on some of these things. And then the question they have is, if I'm going to make a decision, do gains or avoided losses justify the implementation costs? That's usually the way they're going to make that decision, right? So what is open source democracy? Well, it's kind of a mix between democracy and meritocracy, because again, democracy technically is everyone has an equal vote. Although everyone has an equal voice, ultimately it's the people who are doing the work that have the vote. And typically that is specified by meritocracy. Voting can be problematic in open source because you don't know who can vote. How do you do the voting? There are some cases where people vote on stuff. But in a lot of cases, it's really the people who are doing the work who are going to make the decisions. Sometimes you get too much feedback. The term bike shedding, if you've heard, is a case where you just get so much input that you can't make a decision or nobody can kind of solve it. The nice thing about open source is that bad decisions can be quickly corrected because it's software, right? So if you do something you don't like it, you revert it. And that usually works really well. But you don't have a roadmap because there is no autocratic leader or autocratic structure that in many cases is setting a roadmap of where you're going. It's a lot of independent actors all kind of moving together like an anthill, kind of where's the food? Do we need to fix this part of the anthill kind of problem? And sometimes it even looks like that. The internet is really a requirement, I think, for open source. It allows the sort of very low friction sharing of ideas. It allows you to iterate through new solutions. And obviously, it allows for rapid global communication. So just to give you a visual of this is the autocratic structure. So the autocratic structure of software has all the company on the left, has the users on the right. And as you can see, there's a very defined flow of how you get from one part, how the software gets from the left part to the right part, and how feedback gets from the right part back up to the left part. This is incredibly inefficient. This is the way open source democratic development works. The important point here is the users can and often do become involved at every stage of the process, whether it's features, patches, testing, releases, or bugs. You have a very engaged user community who are working with the developers at all of these stages. This is why an open source community with no money can produce software as good or better than billion-dollar companies. This is why Linux and FreeBSD are popular and why nobody's installing HPUX or Solaris brand new anymore. Okay. Let alone like AIX or, some of the other ones. So again, when I started, HPUX was a huge player. Solaris was obviously huge. But over this 20 years that I've been involved, 20, 30 years, open source, because of this efficiency, has really taken over. There is a hybrid open source model, which I'm just going to touch on really quickly. It's what I call the single company software open source development model. It's a combination of open source distribution, but autocratic development. Okay. You still have the autocratic decision matrix involved, but you have open source distribution. It doesn't have the same democratic feedback loop as you typically have, but it is more comfortable for users who are transitioning from proprietary, since there is a single company to contact. And there's a roadmap because the roadmap is defined by the autocratic structure. MySQL, MongoDB, MariaDB, I think are all fall into this rough category. There's a whole bunch of them. I'm just giving you the database ones here. But you get the idea. It's kind of a mixture of the two. It's not all the way open source. It's not all the way autocratic. So where does this leave Postgres? This is actually a conference picture here. Postgres wins because democracy wins ultimately. Okay. Postgres uses democracy to attract talent. Our talent pool of who we have currently working on Postgres can easily compete with proprietary staff. When I kind of sit back and think about how much we've accomplished in the Postgres world in the 24 years I've been involved, I kind of realized that the Oracle or the other database companies have billion-dollar, companies, but their development staffs are relatively small, or even if they're big, they're so inefficient that and we are so good at taking all of the skills from all the people all over the world that we're actually able to create a more effective development process than that. We have a superior feedback and decision matrix. We don't have that decision matrix that talks about how many customers will we win, how many customers will we lose, is it worth investing in this thing? That doesn't really, can't invest in anything. So there is no investment, right? Um, this can be this kind of can be a challenge for niche software. Again, you've got to be able to attract people to it. And setbacks are still possible, right? You still have sometimes intractable problems that are really hard to fix. But my experience over the time I've been with Postgres is that when we started, we were at the bottom of this red line. But the important part was not that we were below the closed source options. The important point is that our curve of improvement, whether it's features, performance, reliability, user base, was steeper. So if your curve of adoption is steeper, it doesn't matter how far you start from away from the bottom. No matter how far you have to go, you're eventually going to cross and exceed what another product has that does not have the same adoption curve. And of course, now we see some of the databases actually, dramatically sometimes having fairly steep negative adoption curves where they're losing losing users very quickly. But again, that angle of curve to me was always fundamentally important. So what does it look like in action? This is Slonik, our mascot. I can't tell you who's in the suit. I have an idea who it is. But again, this is, I think this might have been in Brussels. I'm not sure. But again, yeah, it is. It's probably a Brussels conference. So Postgres, when it was originally developed, was developed to be extensible. This is back in the Michael Stonebreaker period in the mid 80s at University of California, Berkeley. And that extensibility has actually benefited Postgres dramatically. Another interesting thing, and I love this slide, is that normally when companies improve their software, they improve in one axis. So you say, this is going to be our cloud release. This is going to be our usability release. This is going to be our tooling release, right? With Postgres, we're improving in all directions at all times. So we have a yearly release, major release cycle. We typically have 170, 180 features in every release. And we're improving all angles, whether it's big data, performance, enterprise, ease of use, ease of deployment. We're improving in all directions at the same time because we don't have an autocratic structure. We have all these groups that are all doing independent things, and they come together in a final release to basically give us this amorphous growth in capabilities in multiple directions. We have foreign data wrappers, which allow us to interact very easily with other databases. Over 100 of them. Certainly, interoperability is a huge benefit for Postgres. We have an extension network, which allows us to effectively have extensions that you can download real easily and install in Postgres. So again, extensions typically in a database are a bad thing. They're kind of awkward. But in Postgres, extensions are a natural part of the system. You can add things to Postgres and they look like they've always been part of the database. And I think that's kind of one of the secrets of why Postgres has become so successful. Michael Stonebreaker, again, when he developed Postgres as post-ingress, ingress being an older database, post-ingress, decided it was going to be the next generation of relational system, developed it starting in 86. This whole extensibility didn't really become popular for 20 years or 15 years. But now it's a major feature of Postgres, allowing us to do things like full text search, GIS, its complex indexing methods, JSON, whatever the needs are of the market, Postgres has the extensibility to make that possible. PostGIS, I mentioned, a geographic information system. It is developed as an extension, which is effectively loaded into Postgres, into a generic Postgres database, and now Postgres becomes a GIS relational database. Incredibly popular, but an independent team, not really affiliated with the core project. They develop it on their own. All the hooks are there for their extensions to work properly. And we have a number of people from that community actually working for some of our Postgres support companies, which I think is super exciting. This is one of our first conferences. This is in Toronto. The reason I love this photo, and this is 14 years ago, is that 85% of these people are still involved with the community. You'll notice I'm right here over here in the blue. Oliver Herrera is next to me. Tatsuo Ishii's next to me on the other side. Oleg is back here. Anyway, a lot of these people are still majorly involved in the community, and that's a great testament to a community where people feel valued and they feel like they're making a difference and their contribution is important. And with a database system as complex as Postgres, you need to keep those people because you need that skill long term. And I think that's one of the great secret star success. In fact, this sign right here, I actually have that sign right in my office that I'm looking at. It's kind of funny. But effectively, this is I think, a great testament to how important your community is to the success of an open source project. I get around a lot when COVID's not sort of hampering my style. I typically go to 40 events a year, travel about 90 days a year. And again, you can see a great spread. One of the areas I think we're missing, really, I would love to see more growth, is Africa and Middle East. You can see those are two areas that not only I haven't visited, but we don't have as much activity and contributions and adoption in those areas. And that's certainly an area I'd like to see grow. Just to kind of finish up, how do we do things like voting in Postgres? I mentioned earlier that there's a problem of how do you vote in a project that doesn't have, like, how do you figure out who a member is, right? We've kind of worked around this. Committers, for example, nominate new committers. So your committer team nominates the new committers. The core team nominates new core team members. So that, again, a similar process. Development is open to all, even occasional visitors. So there's a very low barrier to entry. We really have a feeling, let the best idea win. We don't we don't have a limited number of people who can give input. Sometimes I'm working on a project and I'll get an idea from somebody, and the first thought in my mind is, where did that guy come from? Like, where did that gal come from? Like, I've never seen them before. That's a great idea, right? So that's, again, one of the things I talked about at the beginning, the idea of democracy, enabling people to feel like they can make a difference, that they can get involved, that they can help move this process forward. That's what democracy is good for, and I think that's what open source development also is good for. Just as an illustration, I think of our process as creating a lens. We focus talent like a lens on every task. And when I go through some of the emails, some of the features that we add, the idea of taking all those capabilities, focusing them on a single process, and the result that you see in the major release is the best of all of the ideas and all the people who have effectively contributed to this idea. We don't have a roadmap. As I said, democracies typically don't. Individuals and political parties have roadmaps, but democracies typically don't. Developers and companies in the enterprise DB space, developers and companies in the Postgres space have roadmaps. I believe Enterprise DB has one. I know Postgres Professional has one. I believe Crunchy, NTT I know has. So we have a lot of companies. They all have their own roadmaps, but again, those are the roadmaps of individuals or of companies, and their only interface to the project is how much their roadmap matches what the overall community wants to do with the process. So again, there is not an official Postgres roadmap, and there probably will never be one. Last slide. If you're curious about what the Postgres community is doing, there is a website on my that I maintain. Down there at the bottom right is the URL, and it effectively shows you the current IRC chat that's going on, the most recent blog, the most recent news article, the most recent commit, the most recent hacker posting, the most recent general question. And this is how I actually look at the community, and I make sure that community, when I'm sort of traveling or I'm just sort of wondering what's going on, this shows me that democracy is working, and that democracy is working effectively. So thank you very much.
Thank you, Bruce. That was a really interesting talk. It's really fascinating how you framed everything from a historical context into kind of the tech world. and how the Postgres project has had many successes over the years in implementing this in a very democratic way. And we're excited, I think I speak for everyone at the conference, to see where the Postgres project is going to go in the future, because it's already caught up and exceeded some of the functionality, like you've said. And, you know, there's many more great things to come that are going to be, you know, brilliant new ideas, as you were talking about, attracting talent to a project that where anything is really possible, as long as it, you know, moves the world forward. Great. We are at the top of the hour, and we've got our next speaker who's going to talk about something that has affected all of us in a pretty deep way. And fundamentally, it's changed the world a bit. So with that, I would love to introduce Karen Ambrose to speak a little bit about the technology response to a global pandemic. Karen, over to you.
Oh, well, thank you very much, Rick, and thank you for introducing me. I will just share my screen. Wait a minute. Okay. Can you see that? Is that all right?
We are good.
Brilliant. Okay, so I will kick off now. Just give me a minute. Okay, so hello everyone. I am going to present today about our technological response and to, as you said, the global pandemic. So today I'm going to present how us as the Francis Crick Institute was repurposed to become a diagnostic testing facility using the technology that we have available to us, and in collaboration with partner hospitals and an established diagnostic laboratory. So I'm just going to go over our sort of journey into that area. So just to introduce myself, I am Karen Ambrose. I'm the Research Data Services Database Team Lead here at the Francis Crick Institute. So for those of you who may not be familiar with the Francis Crick Institute, it's a biomedical discovery institute dedicated to understanding the fundamental biology underlying health and disease. It's located in central London, in the heart of King's Cross, and is a purpose-built building for scientific research. To date, as far as I'm aware, it's the largest biomedical research facility under a single roof. And I think that record still stands at the moment. So under the hood, there are 1,500 scientists and support staff working collaboratively across the STEM disciplines. Our work is mainly to help us understand why disease develops and translate discoveries into new ways to prevent and diagnose and treat illnesses, such as things like cancer, heart disease, stroke, infections, and neurodegenerative disease. So as you can see, lots of areas of research are taking place. So just to provide you with a few stats about the Crick, and I'll probably refer to it as the Crick because generally we kind of shorten its name, although officially it is the Francis Crick Institute. So out of 1,500 staff, there are about 1,250 scientists, which make up over about 120 research groups. And then there's scientific platforms along with 250 members of support staff that attend to sort of the infrastructure and operations that support the running of the Institute. Within the Institute itself, there are about 30,000 pieces of scientific equipment, and the building itself is, in terms of stats, is about 170 meters long, and it's split into about 4 quadrants. So there's a north, south, east, and west section of the building. In size, it's about equivalent to 17 football fields, so as you can quite appreciate, quite large. In terms of height, it's 12 floors, which are 8 floors above ground and 4 below. And within the building, there's about 1,553 rooms. The main ethos of the building is to encourage collaboration. So as you can see from these lovely pictures of the inside of the building, there's lots of areas for groups of scientists, groups of operations staff to sit, collaborate on different projects, discuss different issues, and help each other out where required. In terms of our power, we are connected to the main grid, but we also try and generate our own electricity because we've got solar panels on the top of the roof as well. So we try to be as sustainable as we can in respect to the size of the building. Internally to the building, in terms of culture, there's about 70 plus nationalities under one roof. And also we've got 2 active Nobel Prize winners as well. So in relation to the science that's carried out in the Institute, our strategy statement is Discovery Without Boundaries, which embodies our areas of research around about 7 core research areas. And these are, as you can see, growth, development, health and aging, human biology, cancer, immune system, infectious disease, and neuroscience. They all kind of feed into our strategic priorities, which are to pursue discovery without boundaries, create future scientific leaders, collaborate creatively to advance UK science and innovation, accelerate translation for health and wealth, and engage and inspire the public. The main aim is to translate discoveries into ways to solve human health challenges and encourage innovation. So, as I said before, in excess, we have about in excess of 100 scientific labs. In addition to that, there are 16 scientific technology platforms, or STPs as we call them. And these provide a core service. So, for example, electron microscopy is one of our core services. Scientific computing, which my team is part of, is one of the core service. And what that allows us to do is to centralize the expertise in one area to service multiple teams. So for example, for teams like electron microscopy, the instruments that they use are very expensive. So each lab wouldn't be feasible for each lab to be able to afford and purchase individual instruments. And also there is a space consideration within the building. So in order to make the best use of the specialism that we have, we kind of centralize that, harness expertise, and we can also contribute to the continuity of service and service the science groups at large as well. So it kind of makes sense in that respect. So just a little bit about myself. As I said, I introduced myself at the top of the presentation. So I've been the Research Data Services Database Team Lead here at the CRIC for the last 6 years. I manage a team of 4 very bright people with a mixture of expertise across database administration, development and application development. We have responsibility for the scientific database within the CRIC, as well as the operational database, and we also contribute to the data management within the CRIC itself. I previously worked at the Wellcome Sanger Institute in Cambridge, and for those of you who are not aware, they were responsible for sequencing 1/3 of the human genome as part of the worldwide collaboration project. So quite interesting times as well. In addition to my day job, I also do a lot of work around the EDI and equality space as well. I'm the chair of the Race Equality Staff Network here at the CRIC. I'm a member of the Athena Swan Steering Committee, and I also lead on the Race Equality Charter Group as well. So now on to the main point of this presentation. So just a little background of how we actually got involved in being a diagnostic testing centre for the COVID-19 effort. So in terms of the consortium, this was formed on the 19th of March. So this all kicked off very early in the year. And following discussions and meetings, and collaboration was formed between the University College London Hospitals NHS Trust, the Health Services Laboratory, which I'll refer to as HSL, the Institute of Cancer Research, and us, the Francis Crick Institute. Within 2 weeks, following the initial meeting, the consortium had set up a high throughput RT-PCR COVID-19 diagnostics assay within our research institute. So quite a quick turnaround. Following an accreditation with HSL, the pipeline, which is an extension of HSL, which is an accredited lab, was operational and up and running by early April 2020. We put it together with a mixture of on-site and virtual working. So during that time, some people were on site, but a lot of our staff were working from home, and we actually pulled that together with a mixture of that working environment. The main aims in setting up this pipeline was to minimize dependencies on reagents, which were in short supply at that time. So using our internal expertise, we devised an assay that did not have to rely on the main reagents that other testing sites were using. We also had to provide resilience to that pipeline and to provide a scalable platform to screen hundreds and thousands of healthcare workers and patients per day. So that were the main aims for us being involved, setting up the pipeline and moving forward with this initiative. The main driver for our involvement was summed up nicely by our director, Sir Paul Nurse. So as he felt testing was being the essential part of the national effort to tackle the spread of COVID-19. So therefore, he likened the institutes like ours coming together with, as he said, a Dunkirk spirit, the idea that we can collectively work together to have a huge impact on the national testing effort. So as I mentioned previously, we collaborated with HSL, which is the main sort of accredited diagnostic lab. And this allowed us to develop the main sample feed into our process, to be able to process those samples and return the results. At the start, our main sample source came from the hospitals within the University College London NHS Trust network. But we were aware that there would be other sample feeds which would require a route into our system. And ideally, we would need to identify that main point of contact and agree a standard uniform way in which sample information will be fed into our pipeline to be processed. Because our key aim was to ensure that the integrity of the data was maintained and ensure that we only receive sample information required to support the sample processing. From the start, when we were in initial discussions with HSL, we agreed the format and ensured that we didn't receive any patient identifiable data, which for our part of the sample processing pipeline was not really required. So we didn't really need to see any patient data. It's only the identification of that sample. So as HSL, as you can see from this diagram, was the main sort of interface into the hospitals and GP practices and care homes, they already had the systems that contain the patient data. So it was agreed that HSL would manage the patient data, maintaining that data confidentiality. And we would now have the sort of the main, and so HSL would now be the main interface into those heterogeneous systems which would feed into them, and they would then submit their sample information for processing to us. So in terms of, so let me see. So then at the end, we would then return the results back to HSL, and they would ultimately return the information back to the patient at the end. So that was kind of the process that we agreed with them, and that seemed to be the best way to proceed. So leading on from that point, so maintaining the end-to-end data integrity was our main focus. From the start of the process, samples would be barcoded from source. The samples would then be tracked all the way from source, which would then be prior to us being receiving them by prior to being received by HSL. So initially, the samples would come to HSL pre-barcoded. They would then register them in their system. They would then submit those samples, pre-register the samples with our system by sending us an order file. So that would be the quick order receipt. And we would then preload that into our system. We would then physically get those samples delivered to the crick. So at that point, we would then see those samples and be able to scan them into our system, having already had them pre-registered. The sample would then go to be processed and then go to the RNA extraction step, where the virus will be deactivated. Then that sample will then proceed to the RT-PCR step, which processes the sample and produces the physical output file for the reporting step, where the PCR output is checked by reporters and who confirm and save the results, and finally ends with the results being passed back to HSL. So we go through about 7 different stages in terms of receiving the physical sample and producing the results at the end. In each one of those steps, there's an auditing just to make sure that we've received the sample that we're meant to receive. We know where that sample is in the process. And if there's any problems with that sample, we can then report it and send it back to HSL and request a retest via HSL should we need to. When we receive the sample, we also do a check on the integrity of that sample to make sure that it hasn't been damaged or is leaking in any way, because we need to ensure, we can't have any samples that are contaminated going through our pipeline at that stage. So as you can see, there's sort of a mixture of technologies that we've used throughout this process to track the samples through each stage. So from the previous diagram that I've just gone through, you can see sort of that illustrates the physical process, but this in-depth diagram explains a technology process which supports the sample tracking and reporting pipeline. So as I said before, the sample IDs are pre-registered with our system from HSL prior to the physical sample being delivered to the crick. We receive the sample details electronically via an SFTP system or server, which contains the sample ID, the hospital number, the test type, and the test date, which is the main information that we need. This information is then imported into our database registration and integration system at this stage. On arrival at the crick, the physical sample is scanned into the crick sample reception to be confirmed as physically received into our database registration. And at that stage, as I said, the sample enters into our workflow and is into our internal laboratory information system. This step allows us the ability to manage samples so that if we can identify samples that may not have arrived or if they're damaged. At the sample, as I said before, at the sample reception stage, we also check the condition of that sample. So if it's damaged or leaking, we cannot process it, and we register that sample in the system as a failure with a reason around to request a retest from HSL, because what we don't want is for that sample to just go into the ether. We need to be quite proactive in getting that request back to the ordering hospital so that they can reorder that retest from that patient, and there's no time delay in that process. But in terms of damage to the samples, as you can appreciate, this is live virus within the samples themselves, and we need to operate in a highly risk-averse environment. So we need to make sure that our staff are not at risk in terms of testing the samples themselves. The samples then move through the physical stages, and there is some integration with our main instruments that we use at different steps. Once the sample is registered, then it moves to the RNA extraction step in a 96-well plate format using the Hamilton liquid handler robot. The tubes on the machine are then scanned and associated with a plate ID, and the format of that plate is then uploaded back into the LIMS system and then recorded. So at that stage, we have kind of a handshake. The generated plate will then proceed to the RT-qPCR step for analysis. The plate format is extracted from the LIMS, so they know kind of the format and the orientation of each sample in each well of the plate. The plate is then, the output files, the plate is then run on that instrument. The output files will be then generated, then are placed on our internal physical storage system. Once those results files are generated, they are then reviewed by a two-step reporter process. So they will then take those output files, have a first pass and look at the output and just confirm that the results that they're seeing are correct. And if they need to make any amendments, they'll make them at that stage. The output file is then passed on to a second reporter step. These are then uploaded into our bespoke web application, which was internally created for this particular process. And then that information is then accessed by external second stage reporters, who are then able to review the output and associate with each plate, look at the genealogy extracted and from our internal LIMS system. The results would then, once they're happy with those results, the results are then reported back to HSL. So we submit that information back via our SFTP server. And then the results will be processed and reported back to the patient through the HSL system, because as I said before, they have the patient data and information to do that. Those stats as well, in terms of the positive, negative results, are then reported back to Public Health England through HSL system as well. So they will contribute to the government stats at that stage. So in effect, the reason why we were able to instantiate the pipeline so fast was because we could harness the existing expertise that we already had within the building. And it actually was a true indictment of the hard work of the staff involved. We were also aided by the technology we already had and the knowledge that we had within the building, which allowed us the opportunity to create and repurpose and extend to support the pipeline while ensuring that the data integrity was maintained throughout the whole process. So the next two slides, I'm just going to show you a couple of images for the applications and the instrumentation that we use to support the different stages and that underpin the different stages. We also had to incorporate bespoke functionality where required to support sample registration step, which feeds into the main LIMS system, which was in this case Illumina, which was Clarity LIMS. Both of these systems were underpinned by open source database technology. So for our general sort of tracking database registration, we had MySQL as a database backend, but for Clarity LIMS, it's mainly Postgres, respectively. These application layers were also integrated with the instruments being used along the pipeline to record the progress of the samples. So also in the picture, you can see that we have on the right-hand side, the Hamilton liquid handler robot, which supports the RNA deactivation and extraction step, which then also feeds back into our LIMS system. Then we go on to the RT-PCR process, as seen in the picture on the left. We have our sort of physical instrumentation and the output files, which are generated from the Quant Studio PCR machine, and the physical files that we review here. In addition to that, we also had a bespoke web application, which was designed internally for this process, which allowed us to present the results and output files so that we could then support the second line remote reporters. The results would then be collated, as I said, and returned back to HSL via secure transfer route. They would then record those results within their system and return it to the patient. The web application, which is bespoke, was written in Python and Django with a MySQL backend, again, using internal expertise and the group that would develop that system. So to date, in terms of processing, we've processed up to about 150,000 samples with about 50 people working on the pipeline at any one time. Since the start of March, there have been about 300 odd members of staff involved in the development and the support of the pipeline to date. In addition to also testing healthcare workers and patients outside of the CRIC, we've also implemented our own staff testing system to ensure our on-site staff are routinely tested as well. In relation to turnaround times, we've more or less consistently achieved less than 24 hours for about 95% of our samples to date. So we're not doing too badly in that respect. And in terms of our immediate plans for the future, we are currently, now that we have had time to bed in the process and see how it works, it's a case of reviewing the current pipeline, looking at how we can streamline it and increase capacity. Because as I said, we'd set up the pipeline effectively in 2 weeks, and it's been running for about 7 months now. And I think we're at a point where we can kind of sit back and look at it and say, okay, how can we make this work even better? So I'm hoping that this provides you with a good overview of the work that we've done at the Francis Crick Institute and the staff's effort that have been involved in the last 7 months. If you're interested in finding out more about what we've been involved in, a lot of the information is posted on our external Crick website, and a link I've provided here as well for you to have a look at. We also made a point of publishing a lot of our SOPs around the pipeline. So the groups have put together the step-by-step process which underpins each area of the pipeline. And this allowed us to, and we were very keen to share that information with other institutes across the UK, who were keen to do a similar thing and weren't sure how to get started or where they needed to start. And this kind of helped sort of to springboard their efforts as well. We also managed to have some time to put together a publication about our endeavours. So, and this sort of just one of the publication we had published sort of explains how we managed to repurpose our institute into a diagnostic centre and what we had to do and the underlying assays and the development that was incorporated in getting that off the ground. And as I said, in true Dunkirk spirit, if you like, we shared our testing protocols with other institutes who were seeking to do the same thing. So as I said, this is some of the institutes that we've engaged with to date to sort of help them and sort of springboard their efforts into getting into being a diagnostic testing centre as well. So I suppose finally, the final thing to say would be to really extend a big thank you to all the staff who were involved in this effort in terms of getting the Crick to making it a success and making the diagnostics pipeline a success in terms of where we are to date. So that will be staff who work at the Francis Crick Institute, the Health Service laboratories, the Institute of Cancer Research, and the University College London Hospitals NHS Trust as well. So there's so many people involved, as I said, physically on site and virtually working from home, and it was actually quite an amazing effort from everybody. So, I'd extend major thanks to them. And also thanks to you all out there for listening today, and hope you have a very good day. Thank you very much.
Yeah, this was a fascinating talk that you just gave. It was really insightful what you did. I do have a few questions for you while we still got you. Got 2 minutes left.
Okay.
So I just wanted to ask, what do you think in your mind was the biggest challenge that you faced in putting all of this together and getting it done? Was it the short amount of time? Was it the pressure kind of externally of, this is being a global pandemic? What was kind of the biggest challenge that you faced here?
It was all of what you said. Mainly was the time, because from the time we entered into the conversation in March, we really had very little time to get this up and running, and it was mainly all hands to the pump, 24/7. Everybody was working, trying to, okay, how can we get this to work? What do we need to have in place? And you didn't really have time to think so much, but it was great that we had the expertise already in the building to be able to draw on, and for us to kind of come together and say, okay, these are the things that we need to put in place. And it really quite amazing in that respect that we managed to actually get it done in 2 weeks, because when it was first raised, we were like, no, that's not going to happen.
That's incredible.
Yeah, it's incredible actually that we actually did it. So, big kudos to all the myself and all the groups, all the people that were involved as well. So
awesome. Well, thank you so much for your time. I want to speak for everybody when we say thank you for all the work that you did in pushing this forward in these really important and trying times.
You're very welcome. Thank you very much.
Okay, with that, we've got more on slate. We've got our next keynote. It's going to be presented by Liz and Emily as a joint presentation. It's going to be organizing for your ethical principles. So let's get it handed over and let's get started. This is going to be an exciting talk. Oh, you're muted, Emily.
Sorry about that. Too many mute buttons. I'll share my screen now if that's all right.
Perfect.
And hopefully you can now all see the presentation. We are ready to go. So perfect. Liz will kick us off.
Hello. Good morning to folks on the US West Coast. Good afternoon, good evening to folks who are in Europe and on the US East Coast. So my name is Liz Fong-Jones. I am a principal developer advocate at a data analytics company called Honeycomb, and I'm joined by Emily Gorsinski.
Hi there, I'm Emily Gorsinski. I am the head of data at ThoughtWorks Germany. So guten Abend aus Berlin. Shall we?
Yes, let's go ahead and dive into it. So Emily and I were asked to give this presentation because data science is a field that has a lot of ethical implications, and we want to make sure that people are aware both of what their ethical obligations are and also how to act in support of their ethical obligations. So the work here is presented from material that Emily and I originally wrote a few years back for a book called Seeking SRE about some of the cutting edge topics in site reliability engineering. But it turns out it's pretty cross-cutting. It also applies to data engineering. So let's go ahead and make sure that people are aware of what we're going to be talking about. Unfortunately, this is a little bit of a heavy talk because when things go bad with mismanaging data, they go really, really bad. We're going to be talking about things that we've encountered, including sexual harassment, discrimination, state violence, hate speech, and death threats. These are unfortunately some of the hazards that we have to deal with as professionals who are marginalized in certain dimensions, as well as what happens if we see that data is being misused and how it can be misused. So let's start off by talking about what the ethics crisis is in tech and why we all have an obligation to care about this stuff. So there are a couple of different dimensions in which the ethics of technology, we need to care about it as people who work in the field. The first dimension is the ethics of our product. What is it that we're actually building day to day? And is it perpetuating bias in ways that we do not anticipate? So first of all, we can talk briefly about, go back a slide, Emily. So I can talk about the idea of poor accessibility, for instance, excluding people who have print disabilities, excluding people who have hand tremors, right? Like that your product is not accessible to people who are marginalized along the axis of disability, unless you explicitly design for that. But then there are things that are that your boss may ask you to do something that is unlawful or unethical, and you need to be prepared to think about what am I going to do. So let's talk about a couple of examples. There's Theranos, where they produced medical testing kits that didn't actually work and returned incorrect results. There's Volkswagen, who returned incorrect results when they are being tested for emissions, causing environmental harm. There's Cambridge Analytica, where they used the power of data science in order to push micro-targeted propaganda that was maximally targeted to mislead people. There's Absher, which collated a lot of information about where women in the country of Saudi Arabia were moving, like whether or not they could board an international flight, and male guardians could control with the push of a button whether or not to allow women to board a flight. But I think one that's particularly interesting is La Liga, La Liga de Fútbol Español, which is a Spanish national soccer league. and they eavesdropped on every single person who installed their app, thinking they were getting sports scores, in order to determine what the locations of unlicensed bars that were streaming their games, right? And these are things that we need to speak up against, right? Like, these things don't get built unless we as software engineers and data scientists actually work on them. So let's maybe think about not building things that are unlawful or unethical in that way. But it's not just product. There are a couple of other ways that we wind up perpetuating discrimination. So there's also work conditions, right? That data science is a field of technology, and in technology, we encounter all kinds of fascinating problems where people wind up on the basis of their race, on the basis of their gender, on the basis of what their previous pay is, being not paid the same for equal work, or being given the incorrect job title. So we need to do something about that, right? And this is actually something where we can potentially lend our skills and say, you know what? That's not right. Like, that's not fair. That is statistically not a coincidence that you have accidentally underpaid women by 10 or 20 or 30%. There are also things that we can speak up about in terms of people being treated unfairly, people being asked to work excessive hours, and then things that are much more overt, things like harassment, discrimination, and hostile work environments. But wait, there's more. We also have an impact upon the broader ecosystem of society, right? Where if you work on a product like Uber or Lyft or Amazon deliveries, right? Like, you are working directly on something that is contributing to an ecosystem of independent contractors who don't necessarily get health benefits, right? Where people don't get minimum wages, right? And that has consequences for people's financial stability. That has consequences for people's ability to speak up and organize if they're not all kind of employees of your company. And it results in kind of this permanent disenfranchisement and disempowerment and dismantling of labor protections. We also, at least in the times before COVID, had people who worked in cafeterias, people who worked driving shuttle buses, and all these people enjoyed much less plush working conditions than those of us who are engineers. And then we have to think about, when we go home, right? Like, or those of us who are sitting at home now, right? Like, the fact that you're able to afford your place means that you've paid more than someone else, right? And that has consequences for where people can live. That has consequences for the health of people and the health of where they live. And our employers lobby, unfortunately, large tech companies lobby against things that are pro-worker, and they lobby against things that are pro-environment. And therefore, we kind of have to say, you know what? Maybe that political action committee that my employer is asking me to donate to and passing the plate, no, thank you. I don't want to give money to you in order for you to, give it to a senator who's going to take rights away from Black people or take rights away from transgender people. No amount of protecting net neutrality is worth that. And then there are things that are kind of at the intersection of this, things that are both working conditions and also product conditions. So for instance, is it okay to ask someone to work on a project that harms them, right? Like, if you have someone who is from Iraq, right, and they're being asked to work on a project that does drone surveillance in Iraq, is that something that they're going to feel super comfortable with? Or if someone's working on Twitter or working on social media, right, like, and they're asked to maintain a public presence, doesn't that mean that you have an obligation to protect them in their Twitter life and not just in their sitting at the computer on Zoom life? So there's a lot of interesting ways that we need to look after each other and our neighbors in order to make our society better and more just. So this is not Emily and I's first time discussing this. Emily, when did we first give a talk like along these lines? I think it was...
So I think together this was in 2018 in Dusseldorf. That we first spoke on stage about this. But I think that you and I have been independently doing this for at least 2 or 3 years before that.
Yeah. So part of why this is a crisis to the point that Percona asked us to speak at this conference, right? Like, this would have been a little bit more of a fringe topic 5 years ago. And unfortunately, the reason why abuse of technology is so common in our discussion now is that we failed to act collectively 5 years ago, right? The best time to act was 5 years ago, 10 years ago, but the second best time to act is now, so that's what we're imploring you to do. So this is ethical debt. It's like technical debt, except for it's ethical debt. So Emily, why don't you tell us about this lovely machine learning model?
Yeah, absolutely. Thanks, Liz. So, you know, one of the things about talking about ethics and technology, and despite the title, this is not a talk about ethics. We're not going to present to you some like easy Band-Aid solution that's going to all of a sudden fix our problems. This is a systemic problem that needs systemic solutions. And the truth is, if we were to give this talk every month, it would be a different talk with different examples, because there's no shortage of really, really skeevy things happening in the tech industry from a perspective of equity, justice, and fairness. And a perfect example of this is the way that technology is used to wash or to sanitize otherwise aberrant behaviors. There's an example of the Immigration Customs Enforcement Division in the United States. They had built this software system that was supposed to recommend whether or not a detained immigrant could be let out while they were awaiting their court appearance for whether they were allowed to stay in the country or not. And this was supposed to take into many considerations, things like their background, their age, the likelihood of committing a crime or recidivism, all sorts of different factors. And it turns out that after running this system for a while, they just actually made it always output detain. So it's really just a return true. It's not even an algorithm. But they went through this whole process, this whole song and dance of saying, oh, well, it's not us, it's the algorithm. We're using technology in order to distance human decisions from human beings who are making the decisions. These examples are, you know, they're everywhere to be found. And of course, the United States presidential election is coming up in just a couple of weeks. And so everybody is talking about right now Facebook and social media, things about fake news and disinformation. Are foreign state actors meddling in the American elections? Are Americans meddling in other foreign elections? What is happening in our mainstream tech ecosystem? And the reality is that I'm a data scientist with over 15 years of experience, and I cannot understand the full scale of the algorithms that are being used, nor can the data scientists and engineers who are building them. So what does this mean in terms of a platform that has 2 billion people? What does this mean for the average person who is not a world-class software engineer, data scientist? And so we've just seen example after example, right? The last time, as I mentioned, so Liz and I gave this talk in Dusseldorf in 2018, in August of 2018. In the intervening years, these are just some of the headlines that have come out since we last gave this talk together. We've seen mass shootings, we've seen genocide, we've seen conspiracy theories, we've seen the pandemic, the success of the pandemic management be threatened by disinformation and fake news and conspiracy theories spreading on social media platforms. Moreover, some of you might be aware that I am also, in addition to a data scientist and an engineer, I'm also an extremism researcher. And within this universe, one of the main concerns is the way that extremists, violent extremists, are using technology platforms more or less unrestricted in order to recruit people to carry out violent acts. And they are recruiting people as young as 11 years old. They're doing this on sites like 8chan, which has now been taken down and has reemerged on a different platform. They're doing this through video games, through your Call of Duty, through your Battlefield games. They're doing it through mobile phone games.
And they're especially doing it through YouTube recommendations, right? That our machine learning algorithms are surfacing this content and exposing them to it and steeping them in this until they find a white supremacist community to join.
And so this is a grave concern amongst the community of people who study violent extremism, that this is a problem that has largely gone unchecked because it is up to the tech companies to be the ones to check this. There are very few other legal options to stop this behavior. And so what we want to talk about today is not about ethics in terms of there is some grand ethical code that we need to apply, but really to talk to you as people. Because it's not about whether or not some company, some nonprofit organization, some professional society has a code of ethics. It's about whether you do or not. Liz?
Yeah, so in particular, I think we have an obligation to act. And like we said, like 5 years ago was the right time to act. This is the second best time to act. So let's figure out what we can do today, especially knowing that, for instance, the US election is 2 weeks from now, right? What are you doing to stop misinformation from spreading, facilitated by your employer over the next 2 weeks? Like, this is not a trolley problem. This is not like a problem involving intangible trade-offs. This is something that we need to do something about right now.
So how do we actually go about doing this? How do we go about fixing this problem? So a little introduction halfway into this talk about who I am. So I've been in this space for a long time. I've been in tech for over 15 years. I was a research engineer and actually used to work for a defense contractor. So I've seen firsthand the type of outcomes that technology unchecked can do. Or can have. I'm also an advisory board member, as I mentioned, of 2 university-based labs that study extremism. And in a really terrible sort of set of circumstances, I've been assaulted for my work multiple times, including 3 attempts of murder, and I have the rare distinction of having survived 2 different terrorist attacks. So my passion for ethics is not just because I have some political agenda that I want to foist onto the industry, but rather that it is really a matter of life and death for me. I've written about this in many places, but really the most effective thing I can do is speak to you as technologists.
And likewise, I've had some successes with causing ethics to be a factor in decision-making at large tech companies. So I used to work at Google. I used to be a manager at Google, and I've been doing labor activism for over 10 years now. In particular, I was a key factor in stopping both Project Maven at Google, which would have caused the Google Compute platform to be complicit in targeting of dissidents in the Middle East, as well as rallying against Dragonfly, which was a project to aid the People's Republic of China in identifying dissidents through their web searches in the People's Republic of China. So not Emily and I's first rodeo, but we're here to kind of teach you what we know so that you can put those skills to work inside your own workplaces. But one thing I do want to emphasize is that, like, this is not an abstract thing, right? Like, as Emily and I were saying, like, you know, Emily's purposely survived terrorist attacks, and I personally survived having white supremacists at my employer try to get me fired from my job, try to make it a hostile work environment for me and for every single other woman and person of color at the company. So Google's ideological echo chamber was a document published by James Damore coming up on, I think, 3.5 years ago. And it was a very damaging document in terms of being covert white supremacist recruiting material. And the document leaked. And when it leaked, there was this firestorm of, you know, oh, should we punish the person who wrote it, blah, 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 blah. And eventually the person was fired and he sued Google. And his lawsuit was finally settled a couple of months ago, which is why I'm actually able to talk about it finally. So in particular, one of the things that happened was that this was an attempt to silence women and people of color and non-binary people and queer people at Google. When white supremacists are working at your company, and I assure you they are working at your company, they try to identify people that they can try to get fired, that they can try to subject to harassment because they want to create an environment that is a white men only culture. And so in particular, this is a list of 8 people that, that were publicly blamed for James Damore's firing. Only one of us was an executive at Google. And now at this point, only half of those people, less than half of those people still work at Google. And 2 or 3 of the people on this list have permanently left technology, right? This is what happens when you don't have solidarity, when you don't stand up for each other. So we need those voices in the room to speak up and say this stuff is not okay. So when they go after the most marginalized, like that's one of the techniques that they're using in order to perpetuate white supremacy. But it's not just threats to employment. Let's talk about this too. They've gone specifically after me, and they've specifically issued death threats and death threats that are specifically connected to my gender identity, sexual orientation, and the fact that and my race. And Emily's seen a lot of the same things too.
Yeah, and as Liz mentioned, this is not unique to either her or myself, but when you become somebody who is outspoken about the course of the technology industry and the ability for example, white supremacists to organize on the platforms that we're creating, when we try to put the brakes on the flow of capital somewhat, to start to think about whether or not what we're doing is the right thing, this has a violent backlash. And it's been so violent that I actually moved from the United States to Germany. I emigrated for my safety, and that wasn't enough, because if you don't read German, this headline down here in the bottom is about a group of neo-Nazi terrorists who actually flew from the United States to Germany in an attempt to find me and potentially kill me. So this is something that is, as I mentioned, deeply personal and deeply impactful. This is why we give this talk, because frankly, we're very tired. We're very tired of fighting this fight. We're very tired of being the ones who have to stand in front of the train and asking it to stop. We need your help. We need your help as engineers, and we need your help as people. We need your help as compassionate individuals who want and have a mandate to create a better world for the future.
So these are the 3 things that Emily and I are asking you to do, just 3 things. So first of all, what we're asking you to do is we are asking you to learn from what's happened. We're asking you to conduct retrospectives to really understand, next slide, Emily. We're really asking you to understand, how do I adopt not just a blameful behavior that says, here are the 2 people that I need to fire from my company, but instead, how do we systematically reinforce our companies and the systems we build against abuse? Secondly, we need to have you think about how to prevent harm. We need you to think about, what are the negative and anticipated cases? Could a domestic abuser use this? Could a rapist use this? Could someone who was compromised at your company use this? How are you guarding against misuse of the data that you are the custodian of? And are you providing appropriate controls to the person who owns the data? Thirdly, Emily and I are asking you to minimize the amount of data you collect. That means don't collect unnecessary data that you don't need. Encrypt your data so that it can't be intercepted by a nation state, or not even a nation state actor, just like some random person sniffing Wi-Fi. Encrypt your data at rest and in flight. And protect against insiders' threats, recognizing that you have white supremacists and you have misogynists who work among you who would be happy to leak information if they could get their hands on it. And make sure that your data is secure against, for instance, employees in the US being forced by US authorities to turn over data, or employees working in the People's Republic of China being forced to turn over data by governmental authorities. And better yet, delete the data that you don't need. Expire data so that it can't be used against your users. Or else.
Yes.
This is what happens if you do not minimize your data.
Yes, it's a particularly interesting set of case studies now with contact tracing for the COVID-19 pandemic. Depending on where you live, if you go to a restaurant or some other place, you might be asked to fill out some paperwork with your name and your contact information. there are growing cases of misuse of this data because our laws are not strong enough to protect people for using this data. But also we have created this culture of it's actually kind of okay to abuse data because everyone else does it. So there are cases of the police using contact tracing data to track people down and find people who are witnesses to crimes. There's cases of staff at restaurants using contact data to ask people out on dates inappropriately. And then there's also, excuse me, plenty of case studies where people who were running a website regarding, for example, the George Floyd protests or the J20 protests in the United States, who have simply run a website whose servers have been seized under extremely broad search warrants by law enforcement.
So what can you do in order to stand up to these things? You need to force change inside of your employer, and that means that you're going to need a little bit of backup. Fortunately, I got you. First of all, your company probably has some mission that claims to do good. Like, put that to work. Even if the executives don't actually sincerely believe in it, you as an employee can say, hey, I'm just following this company code of conduct that says do good. Secondly, Emily and I did DISC codes of conduct. You know, they're not a panacea, right? Like, they have to be coupled to action, right? So when you're going for backing, you can say, look, the ACM, the IEEE, they support me in saying that you should not be misusing and collecting and misusing this data. Thirdly, collective action really does matter. That we as engineers are very, very valuable. We're very, not inherently, but in terms of rarity of skills. So therefore, if we all go on strike, if we all quit, if our company no longer has a GDPR privacy officer or privacy department, right? That means that your company potentially has to think about that risk when they're deciding whether or not to do something unethical. Fourthly, there's the issue of local laws. In the US and in Europe and in many places around the world, there are labor protections and national rights to labor organizing, but the remedies are a little bit retrospective. So we still have to think about how we protect each other if we face retaliation, even if we can go and sue afterwards. Fifth, you can whistleblow, right? Like if you hear about something unethical and you don't think you can get employees at your company to do something about it, you can speak out publicly. There's a risk to you. You'll likely be fired, you'll likely be sued, but sometimes that cost is worth paying in order to make sure that the public's right to know about things that are grossly unethical is preserved. So we need to think about our backup strategies, right? What are we doing to support each other? How are we supporting our coworkers and ourselves in order to make sure that we are not being complicit in things? But this change is really worth the cost. So unfortunately, Emily and I don't have enough time to go through all of this in detail. We'll publish our slides later. But like, if we weren't already in a crisis, like, there would be a number of steps to take, but like, we're at the all else failed step, right? Like this is the place where we need to step up and really rise up in masses to prevent unethical things from happening. So what does this concretely mean? This means that we need to think about how we act sustainably.
Yeah. Ethics needs to be, like every other part of engineering, a continuous process. It needs to be part of every story, everything that we do. We must always look at, what are we doing the right thing? What happens if this is not the right thing? We need to run risk analysis as part of our jobs as engineers. We need to understand the impact of our technologies. We need to know where is the break glass in case of emergency button for when something goes wrong. Hopefully it never will, but like any other sort of deployment, we have to have these systems in place.
So talking about break glass, employee petitions, hugely effective. Walkouts, hugely effective. Talking to the press about your protected labor rights, super effective. And you can quit. 5% of Coinbase employees quit. I think that's pretty fucking powerful. So like, prevent crises by giving them the time and attention they need before they become crises. But that being said, we are in a crisis right now. I'm sorry, that's the bad news. So there aren't really band-aid solutions. The best thing that we can do is guard, strengthen, and extinguish. And those are things that we can credit privacy engineering for.
Yeah. And there's no, like I said, there's no Band-Aid solution, right? The reality is we're never going to write an ethical code that interrupts the flow of capital. So we have to create a culture in which doing the right thing is the profitable thing, that in a culture in which doing the right thing is the thing that we're supposed to do, and there's no other question about it. And that does require people to step up, do things that make them uncomfortable, and have a set of rules and guidelines for what is right and what is wrong and what actions must be taken. We also have to look beyond the tech industry, right? These are problems that have been solved before. The medical research industry, the pharmaceutical industries, engineering industries, none of them are perfect, but all of them have something. We don't have even a shred of something. So we need to be proactive about this. Like, we keep saying we're in a crisis, but you know what? It can get worse. And
there will be other
also get
crises
better.
after this too, right? Like, we have to fight this crisis and think forward to preventing the next crisis.
Exactly. And, we might need to think around what does it mean for us, in the middle of a pandemic, when things are going on, we do have to put on our own gas masks or oxygen masks first, or gas masks, depending, maybe you're at a protest. But you do have to take care of yourself. So that is also important. Finally, I think we need to wrap it up. We're just about at time. We do have a list of resources here for some more reading and other people to follow. We'll publish these slides and you can find them there. But we'll just kind of quickly page through them. And
coworkerfund.org if you want to support mutual solidarity. And yep, Amazon workers, Google workers, Microsoft workers, like people all around the industry are stepping up and taking action. So remember, tech won't build it if we stop them from building it.
Thank you very much.
Thank you very much. That was a powerful presentation and a great message that I think everybody can get behind. And every little thing that we can do individually helps in mass. It's not just about holding our corporate sponsors, right, the people that employ us accountable, but hold yourselves accountable is kind of my biggest takeaway there. And thank you so much for presenting that. That was really great.
Thank you for having us.
So we are butting up on time, so I want to introduce Sugu to get us started on why the cloud is inevitable, talking a little bit about the cloud space, and then we'll get into the meat of the technical presentations and deep dives. Thank you so much, Sugu. I'll hand it off to you.
Hello everyone, my name is Sugu. I'm the co-creator of Vitess. I'm also a CTO at PlanetScale. Today we're going to be talking about why the cloud is inevitable. But more importantly, what is it that we can do to face this change that is coming up? Okay? So before we go into the details about how to do this, let's think about why this change has happened. If you had come to me like 10 years ago and brought something, told me that you built something like Kubernetes, with all these orchestration layers, all these rules, all these new complexities that it brings with it, I would have been extremely skeptical. But come 2020, Kubernetes is now catching fire. Everybody is using it. Everybody is adopting it. So why is Kubernetes getting this popular today? And why was it not relevant before, right? For that, the reason is actually extremely simple. Essentially, CPUs are not getting any faster anymore, and software is continuing to grow. So the only way for you to keep growing is by spreading your software out into different machines. And when you go into this mode, beyond a certain level, you're just going to have just too many machines, too many pieces of software running all over the place. And a human is not capable of keeping track of what is where, like it used to be before. So this is why Kubernetes has become relevant in today's times, because of how wide distributed deployments are nowadays in terms of software. Okay, so there is actually a similar problem happening on the storage side, right? But for a different reason. In storage, the price of storage has dropped. to the extent that I can now afford to buy huge amounts of storage at a very low price. I could buy like hundreds of terabytes of data. And what that means is that if I can afford to buy hundreds of terabytes of data, I want to put more data in it and use it to get more results out, analyze things better, right? But the problem with hundreds of terabytes of data is that you cannot hang that under a single machine. You also have to distribute that data. It doesn't fit. Otherwise, you won't get the kind of throughputs that you would expect from data of that size, right? But when you did Kubernetes, right, the problem space it was solving was much simpler. It was just software pieces talking to each other. So it's essentially establishing RPC protocols between them was enough for them to talk to each other. So Kubernetes problem was relatively simple to solve. But when it comes to data, things are a little more complex. Data tends to be in one place. There's relationships that exist between data. So if you decide to distribute that, it is not as straightforward as you distribute software, right? In case of key value stores, it's in some respect, it's slightly simple because you just shard it and keep sharding. But if you're talking about relational data, there's relationships that exist between them. There's different types of tables, there's foreign keys. So how do you distribute data that is relational in nature, right? There is another problem, which is that software that manages data like MySQL or Postgres, each one has different ways by which they do this management. So the solution that you build for managing MySQL is not going to work for Postgres, for example. In other words, the kind of orchestration that Kubernetes managed to build as generic for software doesn't necessarily work when it comes to building orchestration layers for data. In this case, for example, Vitess is more specifically suited for managing MySQL in terms of orchestration. But then there is another problem. We also have to embrace the changes that are coming up. This orchestration layer has to play well with Kubernetes. And here we are going to use one advantage, which is one feature that Kubernetes has, which is the ability to extend Kubernetes through this thing called operators. So you can essentially make Kubernetes more aware of more things than it was originally built using these operators. They are called CRDs or custom resource definitions. Using those, you can basically raise the level at which you speak with Kubernetes in terms of YAMLs and etc. Okay, so all of this put together is the nice story that we can build when it comes to moving data into the cloud, into Kubernetes, right? So what do we need to, like today, if you take MySQL, what are the additional orchestration pieces that you have to build in order for it to be cloud friendly, right? We have identified 3 problem areas that you need to solve. It's not just for MySQL. For any storage system, for it to work under Kubernetes, you need to solve, in my opinion, 3 of these areas. One is orchestration, which means that bringing up instances, discovering them, handling masters, having replicas, wiring them up together, handling failovers. So all these are in the orchestration area. The next one is distribution. By the fact that your data is now split into smaller parts, some may be individual schemas, some may be sharded databases, you need something that brings it all together and gives the application a more simplified view in terms of its data. It shouldn't have to go and discover all these things. These things may be spread out all over the place, right? So that is the second problem. The third problem, which I will cover in more detail later, is day 3 problem, as in once you have solved the orchestration, once you have this distribution, you're going to be facing the need to keep pushing this data forward with the fact that your business needs are changing and your application is growing, it's scaling more. So you need to be able to keep on transforming this data to keep it relevant to the fact that your application is changing. So those are the 3 areas that need to be addressed for your database to go and live well in the cloud. So let's now first talk about orchestration. And actually, let's think about why, what it would take. Why is it that MySQL cannot just be moved into Kubernetes like software pieces are moving, right? So here is an example. The way you would deploy MySQL on Kubernetes is by putting it in a container and then deploying it as a pod. You deploy it in a pod, and what it does is that by default, it will use your local disk. So you create your database in your local disk, and then you can start sending traffic to it, right? Send it SQL queries, it'll work for you. But the problem is later, Kubernetes is going to come and say, oh, I need to move this pod to another server, so I'm going to shut you down and I'm going to restart you somewhere else. When it does that, the thing that Kubernetes will do is delete or wipe your local disk. In other words, if you restart your MySQL, it's going to start again with no data in it. So that is a problem with just taking MySQL and giving it to Kubernetes. This setup is quite convenient. If you're running tests and stuff, you just launch a pod, run it on local disk, and do your test. Once it's done, you just delete the pod and everything is gone. So it's kind of convenient for certain use cases, but not for production. Right? So what people have started doing is actually not use the internal local storage. Instead, they actually mount a volume. In other words, they deploy only the MySQL in the pod, and it connects to a mounted volume where it stores the data. In this case, if the pod is moved, the data is still outside, more persistent than before. But the problem with moving this data is when you reschedule this pod, MySQL has to come up, mount this volume, and perform a recovery. And this recovery is going to take time, which is going to be a loss of availability. And there is another problem. MySQL itself is tuned for using a local disk. Things are going to behave differently if it has to go through a network boundary to actually read and write its data. If you build an application with this setup right from the get-go, you'll probably be able to work with it. There are people who actually work with this setup. But if you are used to your application, to your MySQL, if you tuned your MySQL to actually use a local disk, this setup may actually be a little uncomfortable to move into. So what is the next possible thing that you can do to run MySQL on Kubernetes? You can say, well, let's do master replica and we can do failover, right? So right here, there is a problem where of identifying a pod specifically. Kubernetes has a few ways, and the most recommended way for a stateful set is what they call it, is actually something called stateful set, where each pod can be individually identified, right? So the app server, you can say pod 0 is the master, and you tell the app server, if you want to write traffic to the master, connect to pod 0 and you can write to it. So this works fine, but the problem is, let's say this master goes down, we could perform a failover. So first of all, if you want to perform a failover, you need an orchestration layer that actually does that failover and repoints the replicas to the new master. So you need something like the orchestrator to do that for you. So that is one glue code that you need to be able to run in Kubernetes. Right? Then there is another problem, is that you have to tell the app server that a failover has happened, and now you need to start writing traffic to pod 1 instead of pod 0. So which means that after the orchestrator has failed over, you have to push configs to the app server saying, now start writing to pod 1. Or the other choice is you may need to put a DNS up there somewhere, and then you update the DNS, and then the app server uses that DNS to actually reconnect to the new pod. So those are some of the things. But all that glue code, now in other words, you cannot just take MySQL and run it in Kubernetes. You need to start running these additional components to do this orchestration for you. Here is a third scenario, right? You have a master, you have a replica, you want to bring up a new replica. Typically, what would you do is you find a node, you bring up MySQL there, you SSH into that node, You then do the restore. There's a lot of manual setup that you do. Kubernetes doesn't like that. It wants everything to come by itself. When you say bring up a pod, all this stuff has to happen automatically, which means that the pod, the automation within the pod needs to know who it is, find the right backup, restore from that. After you restore from the backup, it needs to point to the master, wait for the replication to catch up. So all these things it has to do for this replica to be ready to serve traffic. And then beyond that, once you have reached this point, you have to somehow inform the app server that there is now this new replica that can accept traffic. So again, you need glue code. And then you don't want to be pushing all this config to these app servers. So essentially, this hints at basically that there is a need for a proxy in the middle that manages these changes, these state changes, these pods that are coming up and down, and shield that from the application so that the application can be more focused on its business logic and just send its queries to this proxy, and this proxy can figure out what things go where. So this is essentially another problem that needs to be solved if you are going to move MySQL to Kubernetes. And Vitess has kind of more or less solved these problems for you. It has solved the problem of discovery. When things come up, it can discover them, and there is a mechanism for that. It can handle failovers. You can actually do a backup, and then when you bring up a new pod, the pod would know to actually go fetch the restore from that backup and do all that wiring up, and eventually through the discovery mechanism allow the application to start using it. But we are not stopped there. We actually gone one level beyond. There are things that now developers expect from your software. You don't want to be. They don't like you to handhold a schema deployment, right? If you deploy schema, you have to run this ghost workflow and all these things. So Vitess has started to automate all those things. There is actually a presentation by Shlomi that I would highly recommend you attend, where you can just issue your schema change, DDL, and behind the scenes, just like you would say create table, alter table, you do those things, and then behind the scenes, Vitess will orchestrate this entire deployment for you of the schema with no downtime. So that's a session I would recommend. So the next problem that you want to solve is the problem of distribution of data. If you're going to distribute data into hundreds of machines or thousands of machines, you need something that brings that data together under one umbrella, under one model, as it were. So you want to be able to present a unified view of all this data that is there all over the place, and that is what Vitess solves for you. So on the back end here, you have all these what we call key spaces, right? Key spaces are like a database in MySQL, a schema or a database in MySQL. And then a key space can be unsharded, or you can say, I want to shard this key space, and then it gets deployed onto multiple MySQLs. And this thing can get deployed over multiple data centers, and it could be a pretty huge setup behind the scenes, but there is a VT gate layer that sits in the middle between your app server and these sharded databases. What it will do is, these VT gate layers are stateless, which means that application can connect to any VT gate layer. And for the application, this entire backend appears to you as if it is a single MySQL instance, single enormous MySQL instance. And then if you create new key spaces, no problem, they'll start appearing as new databases here. You reshard your key space, most of your queries will continue to work. Some queries may have to be rewritten because they are not cross-shard friendly. So there is some impact, but it is mostly isolated from the fact that you are making huge changes in the backend. So this is the next problem that Vitess solves for you, is continues to give you a unified view of an extremely highly distributed data on the backend. The next part is transformation. This is what we believe is the biggest differentiator that Vitess gives for you. What happens is that when you distribute the data to the extent, right, especially if you are going hundreds and thousands tens of thousands of nodes, you're going to have to manage that data. That data is not going to be just static, right? There's business needs that are going to change. Sometimes data is going to grow too big. You have to split it. How do you manage all those things? Replication is the piece of technology, the underlying piece of technology in Vitess that helps you do all these things. Here are some use cases, for example. In relational data, you cannot expect all relationships to be purely hierarchical. Relational data, by definition, allows you to have many-to-many relationships. For example, let's say you are a retail establishment. You may have people may be placing orders. They may have, the order will have multiple foreign keys. It's going to have foreign keys into a product. It's going to have foreign keys into a merchant. It has foreign key into the customer, right? If it's a marketplace, there are merchants that are selling. So if you decide to shard this data, where do you put this order? Where do you co-locate, right? If you say, I want to co-locate this order row with the merchant, then you cannot efficiently perform a join the customer with their order. It's going to become a cross-shard join. If you put it to the customer, then the merchant side becomes a cross-shard join. In Vitess, you can actually have the best of both worlds. You can say, I want to create the order row sharded, co-located with the user that's creating it. But I say, I also want you to materialize this row against the merchant that it was bought from, right? So in which case, this basically, so as soon as you create a row on the user side, that row will immediately get recreated or materialized on the merchant side. You change the row on the user side, it will be updated on the merchant side. And then when you do a join, you will get the best of both worlds, which means that it will be a local join, whether you join in the user or with the merchant, right? So this is one great example of use case. You can reshard, right? When your shard gets too big, you can do replication where you will create two new shards of your original shard, replicate the data out, split that into two, and then cut over the traffic to the new shards. Sometimes you may have decided on the wrong sharding key. You realize, oh my God, this is not the correct sharding key. I should have sharded it using that other key. Things would have been a lot more efficient. Vitess allows you to change your mind. You can say, oh, okay, if you want to change your sharding key, it's fine. Give your statement. We will actually convert this source table into a target table, shard it differently, and we'll cut over the traffic for you, right? So you can do that using Vitess. It is kind of similar to materialized views, but in this case, it is used for cutting over traffic from one to another. You can migrate data. Let's say your data is in an old MySQL instance, and you want to get out of that. You want to use the more up-to-date settings that Vitess has. You can bring up a Vitess instance and say, point it at that MySQL and say, suck all the data in. And while your application is writing data to the old MySQL, Vitess will keep this new data up to date. And at some point of time, you can cut the traffic over to the new data. You can also stream everything out. Let's say you have an analytics system. You may have ClickHouse on the other side. You may have Snowflake, whatever, right? You can stream data out of Vitess into those analytics systems to perform your analytics queries. There's a customer of us that actually used replication to upgrade MySQL versions completely safely. What they did was this was actually in Aurora. They were running on Aurora 5.6. They wanted to migrate to 5.7. So they set up a new Aurora cluster, used replication to replicate the entire data over to the new one, cut over to the new Aurora, and after the cutover, they reversed replication, just in case you have to cut back because if there are issues, right? So things like this you can do with replication. And I'll talk about the anonymized PII, which is a very cool use case in detail later. So Slack, for example, had to do migrate. So they were already running on Vitess, but only a portion of their databases was running. They still had over 1,000 shards that were left in legacy MySQL instances. They needed to migrate those. There were like over hundreds of terabytes of data, and they were serving like hundreds of thousands of QPS. And all that migration had to be done, had to be moved into Vitess. What did they do is their estimate was like, this is going to be a huge project. Like they were estimating 4 engineers, 3 to 5 years to migrate this. And this, in my opinion, was aggressive. But they used replication. They used 1 engineer in 1 year. Almost all the data has now been migrated, right? And that with 0 downtime, completely transparent to the application. These are the kinds of cool things you can do with replication. So Yelp actually had a completely different use case. To them, production type of, they want to test, their developers are used to testing with production type of data, right? But production contains PII. So what they did was, they used actually replication to anonymize anything that was PII. They used to, so the reason why you can do this with replication is because the core technology of replication allows you to express the materialization rule as a select statement. So you can say, it's like creating a view, and then you specify the select statement for the view, except in Vitess, it actually materializes that view for you, and not just within one key space. It can be across databases, it can be sharded, it can be anywhere you like. But then you get the full power of SQL for this materialization. So what Yelp did was they used actually MySQL's hashing functions to anonymize this PII data. And they had like over 800 tables from a single database, out of which 120 of them had PII. And they ended up creating 700 streams from the source to the target through replication. The reason why it was called replication is because it actually does this materialization by subscribing to the binlog stream and incrementally applying the changes by observing what it saw in the binlog stream. So which is extremely powerful, which means that replication is very efficient and very fast. You can incrementally apply every change, very up to date, which means that as soon as a change happens on the source, it goes as fast as basically regular MySQL replication. So ultimately, the way we want you to see data as, you want to see data as something that you can refactor and change as you go. You don't want to be stuck with decisions that you are. Like the ease with which you go refactor code, you should be able to go to the data and just refactor it, just like you would do code. And in this, we have some really, really cool thoughts that we are saying. Like, for example, let's say you want to split a table. You go to Vitess, say, I want to split this table into 2. And Vitess will say, okay, now you can rewrite your code as if you split the table. And so you rewrite your code. What Vitess can do is continue to send that second table access to the original table. And then it can do the materialization. And then once the materialization is done, it can cut over traffic for you, completely transparent to your application. And let's say after cutting over, you see some trouble, you can cut back because the source is also kept up to date. So because of these cool functionalities that you can add in Vitess, this makes it an extremely powerful tool for you to actually get both the developer velocity and overall feature velocity. So these are cool things that are going to be coming up in Vitess soon. So if you look at the market out there, you will see there are solutions that are coming up in the cluster management area. There are solutions coming up in sharded query serving or distributed SQL area. But replication is the secret sauce in Vitess that actually gives you huge power, huge flexibility in terms of things you can do with it. And these are things that you will get as you, and you can use these 3 things to also migrate your data into the cloud. And these are not things that we are theorizing as things that need. These are things that users of Vitess have adopted Vitess, have used it, pounded it to really, really enormous QPS. And when they were running at this scale, these are the problems they faced, and these are solutions that we built in Vitess to solve these problems. And these companies are extremely excited to use these problems. And even more cool, these are companies that are building technology using the future of the future stack of the world, right? The Squares, the Slacks, the GitHubs, the Pinterests. These are all companies that are building, using the newer ways of building software. So it's kind of cool that these companies are adopting Vitess. And there's actually a lot more that are in use. We'll update these as these companies add themselves to the list of adopters in Vitess. So before I conclude, I would highly recommend attending Shlomi's talk that is coming up soon. If you are planning to use Vitess, I would also recommend you join our Vitess Slack and feel free to ask questions. We love talking about all these things that you can do with Vitess. And now I'm open for questions.
Thank you, Sugu, for the talk. We are at the bottom of the hour, so I think we're going to continue sans any questions. But any final thoughts before we move on and dive into some of our non-keynote presentations?
No, if you have questions that you didn't have time to ask, feel free to pop into the Vitess Slack. I'll be happy to answer them. Or you can also ask on the Percona Slack. I'm on there.
Perfect. Thank you so much. And with that, my time is also concluded. I'll be gracefully handing over to my friend and colleague, Alec, who is in the UK, to cover the next stint of talks. Thanks, everybody, and have a great Percona Live.
Hey, Rick, thank you very much. And Sugu, a great conversation that. Superb, nice to hear. As Rick said, my name is Alex Smith. I'm based in the UK. I'm the Professional Services Manager for Percona. And I'm hosting the next 3 speeches. First up, though, is Emily Gorsensky. I hope I spoke your surname or pronounced your surname properly, Emily. If you have a surname like Smith, like me, you see, it never gets misspelled or pronounced, so it's a lot easier. Emily is the head of data at ThoughtWorks and just gave us a very interesting speech, presentation about an hour or so ago, which is very thought-provoking. But for now, Emily, I believe you're going to talk about engineering data reliability using service-level objectives theory, if I got that right. If I have, then I'll hand it over to you, Emily, and speak to you in about 25, 26 minutes. Thank you.
Yeah, thank you. So let me get my screen going here, just a moment, and hopefully you should all be able to see the fancy title slide. So thank you for that lovely introduction. And for those of you who were around for the talk earlier, thank you for sticking through what I know can be a heavy talk and a difficult one. The good news is this one is going to be a little bit less preachy and more designed to make your engineers happier is really the goal of this. So I'm Emily Gorsensky. I'm the head of data at ThoughtWorks Germany. By way of a brief introduction of the company, ThoughtWorks is a global consultancy. We have offices in, I believe, 14 countries now around the world, 44, 45 cities, and almost at this point, 8,000 technologists. And I bring this up not because I'm trying to sell ThoughtWorks, although you're certainly free to get in touch with me if you want our services, but really because we have seen problems of all different sorts at companies of all different sizes in all different industries. And this talk today is going to be about some of the patterns that I see over and over, regardless or independent of those variables. Also, one of the things that we like to do at ThoughtWorks is share our knowledge. We write quite often. Some of the sort of seminal concepts in modern software delivery, like continuous delivery and infrastructure as code, have come in books that were written by current or former ThoughtWorkers. And one of the publications that we talk about is, or that we produce twice a year, is the ThoughtWorks Technology Radar. And increasingly, we're starting to see more and more topics surfacing on the technology radar that have to do with engineering data, data systems, data products, data platforms in ways that are more sustainable than what we've done in the past. So let's talk about these patterns that I see all over the place. The reality is that data engineers are actually hurting in a lot of organizations. Retention is difficult, and it is very hard to recruit data engineers and data scientists at the current moment. The job market very much favors the candidate and not the company. And so we should be incentivized to make the lives better of our data professionals. So the first pattern that I see is the sort of quote unquote firefighting issue. Too often in organizations, data engineers are spending their time putting out fires. This means that they're dealing with things like backfills or database issues, reports that are late or missing. And what this means is that they're always they're in a purely reactive mode. They're always responding to some incident rather than engineering systems for higher reliability. On the other side of that coin, so we had fire and now we have ice, is a different but related pattern that I see at organizations often, which is data engineers are treated as ad hoc. They're spending all of their time doing ad hoc requests. They're basically being treated like an IT help desk. I like to describe this as building a snowman one snowflake at a time. Oh, can you pull me the data on this? Can you pull me the data on that? As if that data exists in some nice, clean, and perfectly maintained table somewhere, just waiting for somebody to query it for the wealth of insights. That's not reality. That's not what's happening. The third pattern that I see in data in organizations as it pertains to data engineering is long delivery cycles. Some of you might recognize the tower at Berlin Airport, which I'm pleased to announce is opening this fall. I believe the year is now 2012. But we see this in data engineering all the time. We want to implement, say, a Kubernetes migration or increase the version of a database or implement a Kafka stream. This ends up taking much longer than it should. And the reason that these lead times are so long is because of the first two issues. Data engineers are not given enough time to engineer systems. And then finally, the biggest problem that I see at organizations is a lack of trust in the data. And this lack of trust is coming from poor data quality. This is the #1 anti-pattern that I see, regardless of company. And this is the most dangerous anti-pattern, because when people start losing trust in data, then what happens is they stop making data-driven decisions and they start using their instinct to make decisions instead of doing what the data is telling them. That is the opposite direction of where we want to be going if we're trying to become a data-driven organization. So if any of these patterns sound familiar to you, there's great news. You are not alone, and it is not a feature of some unique property of your team, your organization, or your industry. I have seen these patterns happen in organizations from 100 people to 100,000 people. I've seen them in every industry, from real estate to e-commerce to medical devices. No matter what you do, data is kind of a mess right now. We can do better. So in order to think of how we can do better, let's think of how we've done better in the past. So when I started looking into how can we engineer better data systems, I started looking at the problems and I said, wait a second, all of these problems sound exactly the same as something that I've seen before. Where was it? Well, that was the operations world 10 years ago. In some places, it's still the operations world today. But Liz and I just gave a talk about site reliability engineering, and site reliability engineering evolved from this need to stop the bleeding in operations teams because people were being overworked and underappreciated. So how did we break these habits in the operations space with sort of quote unquote normal software delivery? And how can we take those learnings and translate them to the data space? So we've seen this problem, as I mentioned, in operations, the sleepless nights, the long on call, being paged in the middle of the night for something that you didn't break, but somehow it's now on you to fix. These are the sort of trends that we've seen over and over and over. We're seeing them in data engineering now too. So what is the first thing that we did? So in software, the first thing that we did was start to redefine our organizational structure. So we started moving away from hierarchies and we started moving towards domains. We started bounding context. This happened with the advent of microservices and other organizational and architectural transformations where we can look and say, this is what the product is, this is the scope of the product, this is who's responsible for the product. Now let's focus on just building that product rather than how do I integrate this product into this complex architecture or this complex ecosystem that takes me 3 months to deploy software into. The other thing that we did was build up concepts like DevOps and site reliability engineering. So this is all part of sort of the continuous delivery transformation, the agile taking over the world and things like that. But with DevOps, what we did was we said, okay, now that we've bounded the context of our products, now we're going to start reshaping the expectations of our engineers. And so sometimes companies were like, ah, yes, DevOps, I have a DevOps team. That's not how you do DevOps. DevOps is not a team. DevOps is when developers are responsible for production deployments. That means that developers are responsible for production incidents. That also means that developers are responsible for the quality of their production software. This was a small but significant change in the way that software was being developed. Because what this did was, once people started becoming responsible for the issues that could arise, they started feeling a little bit of the pain of when issues arise. And so we started building better tools, better practices, and implementing better patterns of software engineering to stop making it hurt so bad. One subset of this was site reliability engineering. This kind of grew up independently. It's a little bit disingenuous to say that SRE is a subset of DevOps, but the Google SRE book says that it's a subset of DevOps, and they invented the concept. So I'm going to go with it. SRE is a sort of a specialization of DevOps built around keeping enterprise class, carrier class systems online with high reliability, however we define that reliability to be. And that is the essence of what this talk is now going to be about. So the sort of evolution of SRE came with the concept of building out service level theory. So we have SLIs, SLAs, and SLOs. We're going to talk a little bit about these now, kind of introduce the concept very broadly, but really I want to talk about SLOs as the most important thing in this sort of stack of terminology. So what are these service level things? We have indicators or SLIs, objectives or SLOs, and agreements or SLAs. And these are all built around one concept, and that is codifying delivery promises in a way that is measurable and traceable. This is the most important thing. So it's not just, oh, I want my service to be up 100% of the time, 24/7. That's not a realistic goal. SLOs are about defining targets and measurements that make sense in a way that is unambiguous and can be tracked. At the core, SLIs are the indicators or the things that you are tracking. And when we define SLIs, we want to not just talk about what are we measuring, but how and how frequently. What units is it in? Is it over a rolling window? Is it a percentile? Is it a quantile? What are the, how are we actually computing these indicators? Those are very important things to get right, because otherwise, if you don't have the specifics of your definition, then you get into a case where your service level is now open to interpretation, and that's not a place that we want to be in. We have SLOs, which we can roughly think of targets for our service levels. I like to instead think of SLOs as the North Star for a team. SLOs should be the benchmark by which we measure our engineering effort. So we want to meet them and we want to surpass them, but we also want to think of them in a structured way that they drive continuous improvement. I'll talk about that briefly in a moment. And finally, we have service level agreements. Service level agreements are essentially a contract built around an SLO, or one or more SLOs, I should say. These are bipartisan, right? These are between two parties. And they talk about what are the commitments, what are the promises that I am making in providing the service, and what are the promises that you're making to me in exchange for the service. So that might be money if you're a cloud provider. It might be submitting bug reports in a certain way if you're just doing internal team service. It might be expectations around time to respond to tickets before an escalation, right? So that somebody is not running to the manager if you haven't fixed their bug within the first 4 hours of your morning. One of the things that I see, and this is a little caution, is that in lots of organizations, people get SLAs and SLOs wrong, or they get them mixed up. These are two different things. If you define an SLA just in terms of an SLO and not around what type of work needs to go in to meeting and maintaining it, then you're sort of missing the point of what service level theory is all about. And I'll talk a little bit about that now. But I see this all the time where people are like, my SLA is 99% uptime. It's like, no, that's your SLO. Your SLA is what's going to happen if you don't have 99% uptime. Your SLA is what's going to happen when we need to do an upgrade and we can't meet 99% uptime because we have to take the system down in order to apply a security patch or something like that. So when we talk about building effective SLOs, this is true for software as it is for data. These are product decisions. These are not things that emerge from a system. These are things that drive forward the engineering quality of the system. And the tighter that your product requirements are, the more engineering effort you have to put in. I see a pattern all the time where people will build, say, a machine learning algorithm that needs to do, classification of something on a web service, and they're like, all right, I built my system. Now I'm gonna define my SLOs. No, that's backwards. You want to define the SLOs around what your product needs. This algorithm must be effective 99.9% of the time, otherwise bad things happen. When we frame them in terms of product decisions, then we should be able to make clear that these map to business value. And so what we want to do is we want to define SLOs that are clearly linked to some amount of money, something that is valuable to us as a business. We don't want to just pick SLOs because that's what Google does, or that's what Amazon does, or that's what Microsoft does, or whatever. We want to pick SLOs that make sense for our product. And our SLOs in one team may not even be the same ones as the SLOs in another team sitting down the hallway, because the value propositions are not necessarily going to be the same. Also, a lot of organizations use SLOs to drive incident response, and I think this is bad because SLOs should be carrots and not sticks. They should be a tool by which we can improve our service, and they should not be a driver for punishment. They should not be punitive. They shouldn't be used to, say, withhold budget for an underperforming team. They should instead be used to give budget to a team that is able to elevate its service level to a higher standard in the next quarter, in the next year, in the next whatever. They should be driving the quality of our product forward. They should not be punishing us when things that are usually outside of our control have a product quality impact. So we want to think of SLOs as a positive thing. And because they're a positive thing and they're meant to drive change, SLOs themselves should change. They should evolve over time as we get better at building technology. So if one time your latency is 100 milliseconds, maybe we can step that up to 70 milliseconds. Or if your availability is 99%, maybe next year we target 99.9%. These are the ways we need to revisit them. And these are the ways that we use SLOs to keep our teams getting better and better and better over time. So that's a lot of introductory material. So now I want to actually talk about this in a concrete data engineering context. So let's talk about them for data engineering. This is just one example. If you want to read more about SLO theory, I'm going to pitch a book. It's not mine. It's this book by Alex Hidalgo. He does talk about data in one chapter of this book, but lots of really great stuff about how to implement it. I'm not paid to advertise his book. I just think it's really awesome and that he's really awesome. So the first challenge is that SLO theory came from the cloud. And not all of these concepts translate super easily to the data space. There's a lot of really advanced work around latency measurements and how to build the right SLO around uptime. Some of this isn't relevant for data. If you're building a BI system and you know that your query is going to take 2 to 3 minutes because you're crunching on so much data, 40 milliseconds versus 50 milliseconds isn't going to be very meaningful. So we actually need to develop new theories specific for the data context. Some ways to do that, you can think of these in terms of value axes based on what your data product is. You know, if you're doing online machine learning, sure, latency is probably super important, but so also might be precision and recall, or maybe your false negatives are way more expensive than your false positives. And so we want to link it to what that value proposition is. Alternatively, if you're doing something like stream processing for anomaly detection, you could create an SLO around the time to detect an anomaly. So you want to minimize that time so that you're able to respond faster. So maybe you can build some statistics around that and use that as a service level offering. So when we define these in context of data, we have to ask what is the product and who is the product owner? In other words, who is the boss? Data engineering in an operations context like this makes this difficult. Because if you're doing something like a BI system, do you really have a clear product owner? The answer should actually be yes, because you have clear users. And one of the first things that I advise organizations to do is to make a clear product owner for that data platform, regardless of what it is, and to make sure that that product owner is talking to the users to get their feedback. Secondly, you have to build SLOs that make sense. I said this before, I'll say it again. 100% is impossible. Everyone wants 100% uptime 24/7, but I'm sorry, the power grid is not at that level of reliability. And so you have things that are going to affect that, your ability to deliver on that. And the more nines you add, the more expensive things get. And it's not linear. So if you go from 99% to 99.9%, that increase in cost is much smaller than the increase in cost from 99.9 to 99.99. So you have to ask yourself, what do I actually really need? What is worth the investment? Wayne Gretzky was the great one, and he only had 2 nines. So do you really need 99.99%? So here's a working example. I have a few minutes to go through it. So let's say that our use case is this. Let's say that I'm a supply-side business intelligence analyst, and I want the weekly sales reports to be available in time for my Monday morning planning meeting, which happens at 10 a.m. And I need to review these. So I really want the data ready by 8 a.m. so that when I go into this meeting on Monday morning, I have everything I need, and we can submit our materials purchase orders before our competition. And that means that we will get more competitive rates. Okay, wonderful use case, clear business value proposition. Data is there faster equals less money spent. Great. So let's build an SLO for this. Let's say that we need to crunch this data overnight. We're going to crunch, a week's worth of data or 3 months worth of data. It must be ready by the time the analysts get in the morning on Monday. So how do we do this? So here's one sort of naive example. So you might say, my SLI is that data is fresh at 8 a.m., true or false, and the SLO is that the data must be fresh at 8 a.m. on every working day. Is this good? What do you think? No, this is not a good SLO. This isn't a bad SLO because binary measures don't give us a way to measure improvement very easily. Moreover, this sort of every working day is always an instantaneous measure, and we don't care about history, right? And there's no way of telling like what's worse. What if the data is available at 8:02 in the morning? That's like a violation according to this SLO. But is that better? Is that not better than if the data is only available at 3 in the afternoon? Like what is bad? Are there degrees of bad? So let's think about ways that we could do this. So in Alex's book, he gives an example of, maybe you want to do 99% of the data. must be available. Unfortunately, batch processing systems don't often work like that. We don't have the ability to go back and say, I'm going to only pick 99% of my data, and therefore it'll be a little bit faster. It's usually an all or nothing thing. So that's our central challenge. So let's think about it in terms of use cases. So the business intelligence analyst, maybe they want to really not just have the data available for this report. That's their key need, but they also want to look at it, during their working day, during the week. So let's say that we start measuring the data's lateness, and we start accruing lateness at 8 in the morning, and we stop accruing lateness at 6 p.m. And so any time by clock minute that the data is not fresh and up to date, like yesterday's data is not available within this time window, is bad, and it starts accumulating over time. And we want 99.5% freshness over 30 working days. This is a much better example. Why? Because we can construct an error budget around this example. So if we do the math on this, this means that, with a 0.005% error budget, this roughly boils down to, or not roughly, exactly in this example, boils down to 90 minutes per 30-day rolling window. That means we have an hour and a half any given 30-day window where we can miss this if something bad happens. That means that, maybe we can actually do our database upgrade at 5:30 in the afternoon on Friday. Like, maybe it's not a big deal. And, yeah, the system will be down, but, we're only eating up a third of our error budget at that point. So let's go ahead and do it. What does this get you? This gets you a lot of things. It gets you, if you craft an SLO like this, it's going to drive your team to supporting it. That means you're going to improve your pipeline observability. You're going to have better monitoring in it. You're going to implement better quality gates so that you're aware of data quality issues earlier on, which gives you more time to fix them or to react to them. You're going to have less technical debt built into your system. You can improve your documentation, reduce your bus factor, and you can automate much more of your tooling. All of this is built around this idea that you only have 90 minutes of time that you can miss. So if you know that you can only miss in that 90-minute window, what are you going to do to make that? And because this is an SLO, this is now your priority. So you're actually going to invest the time into doing this. And if somebody complains that, oh, it's 8:05, where's my data? Well, if you've only eaten up 5 minutes of error budget, you get to tell them, don't worry about it. So you can sort of forestall some of those complaints. So we actually put this into practice in one of my teams. I'll wrap up with this example. This is a little bit derived. Some things are changed to protect the innocent here, but we had a similar use case, and we engineered our systems, a very complex system, with an SLO just like this. As we started doing this and tracking this, we got some immense improvements. Our total run duration of our pipeline was cut roughly in half. We implemented way more quality gates. We are now not only integrating, but we're automating the integration of data quality tests whenever we institute or implement or connect to a new data source. So we connect to a new data source and we automatically stand up data quality tests around it. This gives us the ability to stop the pipeline at different stages and investigate quality and make decisions on what to do if the data quality that day is bad. Because we turned this into an SLO and because we created working agreements around it, our support requests reduced by a factor of 3. And because of that, that meant we could spend more time engineering, which means that our lead time for features was cut in half. Our bus factor went down because because we built a better pipeline, there was less specific arcane knowledge in how to fix the pipeline. So now if we want to fix something, it's really just a couple clicks of a button and everyone on the team knows how to do it, which means that everyone is responsible and everyone can respond to these requests. So now our team is much more resilient. And because we cut down so much compute, we actually saved a bunch of money in the process as well. So this was actually a really interesting exercise for us. And this is just one example of one SLO that we could create. Alex gives lots of examples in his book around consistency examples, around around other ways for fault tolerance and things like that. But we can really build some interesting systems if we start thinking in terms of deliberate, measurable, concrete service level theory for our data systems and our data pipelines. So that's all that I have. I don't have time for questions, but please feel free to reach out to me. My email is here. You can also reach me on Twitter at Emily Gorsunsky. And so thank you very much.
Hey, Emily, great presentation. Thank you very much. That was really interesting to talk about the different SLO or SLA, SLO, SLI theories. That's made me rethink things for sure. That's great. I don't think there are any questions, as you've said. So if that's okay with you, we'll move on to our next presenter, which I think is Gavin. Have a safe day, Emily. Thank you very much. Gavin Mendel Gleeson, if I've got that right, Gavin. Yeah, Gavin is CTO for Terminus DB, and he's going to talk to us about revision control for structured data.
That's right.
Yeah, looking forward to that one. Cheers, Gavin. Over to you.
Thank you. So let me just share my screen here. There we go. Yep. Okay, so the title here I have is Collaboration for Structured Data, but as you see, as I go on, you'll understand why it's actually revision control for structured data. So I'm Gavin Mendel Gleeson. I'm the CTO for Terminus DB, and I've had a sort of a very eclectic experience in computer systems and big data, including things like chemical combinatorial chemistry, through to machine learning and search platforms, content control, and then most recently started a database for revision control called Terminus DB. This is going to be a more general talk, though, about revision control and the general process of the way that we do data and data collaboration. So first, I'm going to give you an outline, a little bit of an idea of what the talk is actually about. So first, the motivation. Why do we need structured data in the first place? Although it's Percona, it's probably people already know why you need structured data. But then once you've chosen to use structured data, what are some of the problems of data management for teams that you need? And then I want to talk a little bit about the challenges that we have. Why can't I just use Git for doing revision control? And why can't I just use my database? Now it'll turn out, of course, that you can use both of those things, but I'm going to suggest that there's a better potential solution, which is to use distributed data collaboration using revision control. And I'm going to try to motivate that through my talk. Okay, so first, why structured data? Well, data is really core in the way that we conduct the modern enterprise. It's really important for making the appropriate decisions about things. You need to have the right data, and in order to have the right data, you need not only to understand what it is, but you also need software to understand what it is. And if the software is going to eat the data, it needs to have some understanding of the structure of the data. So in order to make pipelines, in order to be able to do artificial intelligence, machine learning, in order to do surfacing of information for publishing, all of these things require structured data. In data analytics and data science, it turns out that around 80% of the time in that task is taken in data curation in the first place. So people are taking the data, they're curating it, they're removing incorrect information, doing data cleaning, making sure that it's correct first, and then that you put it through some machine learning pipeline, and you may have to massage the data, you may have to do some transformations of the data as well, and usually this is an iterative process, and a lot of it is just the curation end of things. So the data structuring and the manipulation of that structure is really core to all of the machine learning and artificial intelligence and data analytics, depending on where you are on that very variable sort of pathway in terms of complexity of the analysis. So curation and editing to obtain this high quality data is therefore really critical. And it has to be facilitated for both machines to do automated cleaning, but also for humans to do structured cleaning of the data and to make it really feasible to use it as an input. And then on publishing of data, you need easy access to the data. So you need to be able to query the data. You need to be able to get the right data out. You need to be able to surface it in some way with the appropriate information about what's in there in order to construct the right kinds of outputs. So graphs, charts, forms, and web pages. So really our challenge right now is that data is still in the dark ages. We haven't really solved a lot of these problems in a way that is convenient for programmers and for people who need to view the data, customers, etc. There's a lot that can be done here to improve the way that we manipulate it. Some of it can be process controlled. Some of it, of course, are these ideas that, like the prior speaker, where we're looking at ways and means of setting up approaches to the data, and that's really important. But there's also technical solutions that can help us. So whether we're talking about structured or unstructured data, we're still doing it wrong. And you can see this in enterprises because of the way that they're actually using data in practice. So even in very sophisticated machine learning and artificial intelligence houses, you see people moving CSVs around to each other, and they're often slacking them, or they're emailing them to each other, or they're storing them on a drive with the suffix on the end of the CSV that gives you some kind of information about what its version is. We're repeatedly recleansing and reparsing information. So in the case of CSV, there's no metadata about the data. You have only the column name is the only thing that you get by design. And there's not information about like whether or not something's an integer, whether it's a string that looks like an integer right now, but doesn't 10,000 down, those kinds of things. So there's a lot of repackaging like that happens in these processes because there's no way to store that metadata in an appropriate way with CSVs. With Excels, it's slightly better. You get type information, but even then you don't get the version information. So you have a lot of Excels that are floating around with different versions of things in them. And even if you go beyond that, there's still a lack of metadata about the data. Now there's structured ways you can deal with this. You can have CSVs that are coupled with another metadata CSV essentially, but then you have to have a process that keeps them coupled in some sort of way. And then we have like Git, which is a fantastic and really important inclusion in the software engineering lifecycle. So previous to Git, people were actually emailing each other source code. I remember back then when that happened a lot more. And people who were more sophisticated often did use revision control systems, but they were quite closed, quite centralized, and they didn't have the same sort of freedom that you get with Git. And they also tended to be less sophisticated and harder to use. Although Git is very sophisticated and can be hard to use, for a lot of simple operations, it works very cleanly. So one of the problems with Git, though, for structured data is that it doesn't actually maintain structure itself. It actually just maintains information about changes to lines of text. And lines of text are great. I mean, they're not ideal actually for source code, but they work pretty well. And there's ways of getting around that. But it doesn't scale very well to data type scales. So even sort of normal CSVs, you can often see in the 600 megabytes or even 2 gigabyte CSVs floating around. That becomes awkward to use in Git very quickly. And even if you are able to use this, which you can, and it's an improvement to use Git for CSVs as opposed to slacking them. I would, if you had to make one change from slacking them, I would say, move it to Git first. That's definitely, if you make that solution work, it's going to be better for you. But you also want to be able to have structure and discoverability. So these problems of repeatedly reparsing and recasting data in order to use it in analysis are hard to solve permanently if you're just using CSVs. And you can't really query a Git repository in the way that you can query a database, which is really convenient for surfacing data, for automated cleaning, for these sorts of operations. Now, at the same time, if you're a house that has managed to get a database into your machine learning, artificial intelligence, or analytics pipeline, then you're doing better than most. So a lot of houses in practice do not. And it is a big improvement in a lot of ways. However, databases are also awkward for this. Now, they give you all of this structure and discoverability, but they don't have a lot of the other features that Git has that are very helpful. So the revision control features you can retrofit, and those I've seen people use a lot of retrofitting of revision control type features in databases, but that means you have to pollute your schema or your data model with a lot of information about the revision control features. And the structure of that can be somewhat awkward. So whether it's by table, by row, how are you doing the revision control? You have to build all of that into your system as well, and that can complicate things. And at the same time, it can make things awkward in terms of query. But it doesn't resolve a lot of the problems in changes to structure either. So if the structure is also changing, then you need some way to manage structural changes, and that requires some sort of revision control of the schema meta language itself. And there are solutions to that, but I would say many of them are quite awkward. Some of them are not too bad, but it's an additional layer of complexity that you have to put in. Finally, you have to hand roll the way in which you do distribution. So I mean, in some ways, it is quite possible to, for instance, have all of the clients that are trying to get the information to do some sort of analytics by taking it down in a query, doing some kind of transformation, some machine learning, and then putting results back into a table. But then you have this whole problem of revisions, maintaining them, making sure that everybody's collaborating in a successful way. And that's also a problem. Now the database model tends to be very centralized. It's not very bottom up. So it pushes, it doesn't have to be centralized, but it tends towards a very centralized model, which increases the costs of experimentation. So it makes it harder for people to do tests, iterations, etc., because of the lack of the revision control aspects that Git gave us. So Git really did a great job here. It solved this team problem of collaboration with revision control. So it gave us a bunch of things. One of them is provenance. So we know who made which changes. We can see the revisions and the authorship. It gave us safety. So safety is a huge part. So lack of fear is what allows us to do experimentation. So if you have some kind of code resource, you can feel confident. I can make a branch. I can try and experiment on the branch. If it doesn't work out, I can leave it. I can throw it away. Or if it turns out to work, then I can merge it back. And then you have, from that, you have quality. So you can get CI/CD type pipelines. You can say, okay, well, you're not allowed to actually merge back and push this to main unless you have passed certain tests. So, and then, you know, in practice, in a software development life cycle, you may have multiple branches. So you might have dev, canary, and then production, or you might have 4. I mean, I've seen even more complicated setups, and lots of them make sense. So each of these stages can be sort of cascaded. You can have different kinds of acceptance criteria before you move on to the next one. And this brings us really to the main reason that Git is such a great collaboration feature, and that's the distribution. So the ability to do push, pull, clone, and merge really make it so that all of these sorts of revision control features are not just revision control. It's not just about knowing what happened and when and with which author. It's also the ability to communicate those changes. So you can take it offline to some place, do some experiment, make sure it works, and then you commit the whole thing as a transaction. And that transaction is also going into some end of the pipeline where it's acceptable. And when it's accepted, it won't disrupt too badly other people's work, and they can continue with it. So the solution that we really want for data is a database that's designed for distributed collaboration. So what should a tool that's built for collaboration on structured data look like? Well, going back to the database. So I'm a big fan of both MySQL and Postgres were databases that I've used a lot in the past, and there's really big advantages to using them over, say, a CSV. So discoverability and schema, those are really important aspects. You want to be able to do queries. You want to be able to retrieve and update programmatically. So not just updating a monster CSV file with sed or something like that. You actually want to be able to do a proper query, get back all of the results that match something, and then edit them in some sort of way. And the structure and typed entities are really critical. It means that like when you're doing data cleaning and casting, you shouldn't be resolving this problem every time you ingest it into a machine. And that's not just an inconvenience or a time problem, but it's also a quality problem. So there's many times that I've seen where it works most of the time, and then some of the time it doesn't work because there's some casting issue with one of the elements, and that can then cascade into other problems further down the line. And machine learning, this can be a big problem in terms of actually processing. So having a schema, though, is so critical, but it also means we have to pay attention to schema migration. And that's probably one of the most awkward points for current databases with revision control. So the other aspect that we need to have built in, I think, is revision control. Scalable to typical data set sizes. So, you know, not all databases, actually most databases tend to be less than 2 gigabytes, and the vast majority of them are under 100 gigabytes. So those sorts of scales will solve most people's problems. Now, a lot of people think they want to go immediately to sort of internet scale, Google size databases, but most people's problems are not actually that large in practice. So we need to be able to at least deal with these typical data set sizes that we see in practice. And of course, as it gets easier to use big data sets, people start pouring even larger data sets in, which is always a problem of efficiencies. But we want that provenance. We want to be able to have authorship and commit time and these sorts of things built into the way that we manage our data, especially in the artificial intelligence and machine learning area. It's really critical that you know how, when a data cleaning took place, what was run, whether it was a automated procedure that was doing something, and so that you can do quality checks on it, and then perhaps even roll back to a previous step and try again. And so it's really useful if you have that visibility where you can see what was changed by what and how to go back and undo it. It gives you a lot more control over your pipeline. So pipelining itself, modern CI/CD architectures work because of the ability to do branching, to do these sorts of tests, to do all of those elements that really make it possible to do continuous integration and continuous deployment. And finally, we want safety. So branch and rollback allow the experimentation that you really need, because you don't always know what you have to do to the data to curate it ahead of time. Once the pipeline's all set, you might think, oh, okay, it's grand. But actually, even once you have a process, you want to be able to go back and increment and change the process, fix the process, get higher qualities out of the process. And that means you have to have visibility of what's going wrong and where. And with a lot of pipelining solutions, it can feel like you don't know where it's gone wrong. And it can be a debugging situation to go back. Now, if you have the visibility of where the changes take place, that can solve a lot of problems, and it has been a big advantage in code. So, and that brings me really to the thing that I think is most critical about revision control, which is collaboration. This was the thing that really made Git a sea change, and it's why Git is better than Subversion was or some of the other ones. It's this multi-mastering sort of push-pull peer-to-peer interface really made it amazingly cool for doing programming. And it turned out like that's really sort of the right way to do it. There may be better ways in the future, but it's certainly a sea change and really improved things over how it was done before. And that collaboration is enabled by the revision control features. So you want modifications to be safe. So when for instance, when I have a centralized database, it's often the case that you get a sort of contrasting interests between the person who's running the database and the people who are trying to use the database. And a lot of times it can feel like a pull-only type scenario. You're only allowed to do queries and get the information out because they don't want you to pollute the database with information that will screw it up or change information, etc. And so in order to have that sort of push and pull architecture, you need these revision control features. So it's the collaboration is facilitated by this revision control. So that the effective collaboration requires revision control distributed between collaborators. So we need to be able to push, pull, clone. And part of this is because we want to be able to work offline, but sometimes you might say, if I'm doing a machine learning pipeline, offline might not be offline from the database. It might be on a large server that has a large number of processors, GPUs, etc., that's designed for running the kinds of problem I want. And what I want to be able to do is pull or clone a version of the database locally, do some processing on it, come up with some feature set, enrich the database with new information, and then push that back after it has passed some acceptance criteria. And in order to do that pushing and pulling, then you really want to be able to distribute deltas. So Git does this delta manipulation. You move around deltas between client and server, or in a peer-to-peer type of fashion. So we want to be able to store data as deltas, and that would be really advantageous. So then finally, in order to do change management, you need merge. You need the ability to figure out how to combine different deltas when different deltas happen from the same tip. So you need to do it properly. To do distributed writes, you need to be able to do merge. And you also, if you want to move data around, data has a very oftentimes it has security implications. So you want to be able to move it around in an encrypted way if possible. So there's multiple solutions to this problem. There's not only one way to do it. You can do it inside of the database. You can do it with custom tool chains, and you can use CSVs in Git, which is an improvement for a lot of houses from what I've seen people doing it in practice. But then there's a new series of open source databases that have come out, DVC, Dolt, and Terminus DB, which all give you these sorts of revision control type collaborative aspects. So if you're interested in an open source solution to collaborative revision control for graph databases or complex data sets, you should give Terminus DB a try. And you can also check out the others, TBC, Dolt. Thank you.
Hi, Gavin. We've got a couple of questions that have come in for you, if you don't mind. Sure. The first one is revision control really going to become a major feature which is used in data content management?
Yeah, I would say absolutely. So, I mean, okay, so if you look at data content management in some kind of practical system, for instance, something that's widely used, WordPress. Okay, so what they did in WordPress is they ended up having revisions internalized into the system in the database. So it's already used in content management systems like WordPress, and many other will have some sort of revision control aspect. And then when they started trying to add features to their records, then they ended up building a sort of internalized graph database inside of WordPress on top of MySQL, or usually on top of MySQL. So they also realized at some point that in order to do the revision at a fine grain, you would also need to be able to have a sort of graph database internalized. So I would say people have been forced into this solution, but they also didn't get the collaborative aspects that have made Git so popular as well. So I think there's no question in my mind that as we go forward, we'll see more looking at from first principles how to do revision control aspects with data. And from my own experience in machine learning, really people are the more forward-thinking people are starting to use Git a lot to do their CSV management. It's really, really horrible to just be slacking CSVs to each other, but also it like I said before, the trying to surface it just in a database, a centralized database, is quite awkward as well. You're going to have to build some kind of revision control aspects into your database if you're actually going to allow different experimenters. And with machine learning, you have to experiment. You don't know the answer a priori. You have to test different feature sets against each other. You have to see whether or not this channel works better than this other channel in terms of trying to determine features. And that experimentation means that somehow you have to be able to feed all the information back, be able to make comparisons between them, perhaps on different branches, for instance, and then choose which one you want to go to production as the way that you're going to identify classes or features.
Okay, thank you very much. Second question, which is kind of a question of, it's almost like two parts to the question, so I'll give you both parts in one go. Is it possible to merge a structured data? Is it possible to merge structured data effectively? And the other part is, Git merges are a nightmare. Will this scale?
Yeah, those are both very good questions. So the part of, okay, so one, it is possible. You can do it. Merges are complex, and that's the reality of merges. In Git, you don't have very much information about the semantics of what you're having. So I alluded to it very briefly previously that a line of text can work all right for source code, but it's actually not even ideal for source code because the computer doesn't know what the AST looks like. And there's lots of merges that could be avoided, or you could know how to resolve the merge conflict if you understood something about the structure of the data. So if you're given more structure about the data, if you have information about cardinalities, et cetera, like that, then you can come up with strategies for automatic resolution. So there's not, it's not going to be a perfectly solvable problem in the sense that there's a way to solve it in all cases. But there are a number of things that you can do. So one of them is the patches that happen in Git tend to be manual. You need to be able to have a query language that allows you to do the resolution of merge conflicts when they occur. So coupling strategies, more structure, and queries for automatic resolution of merge conflicts will get you a lot of the way there. Then there's, you can do other things subsequently where you do have a merge conflict. You could say, okay, well, this one has to win, and then somehow we're going to have to calculate a delta out of this, and then you're going to have to come up with some kind of automated structure, usually because the amounts of data, the quantities can be quite large. Now, if you're doing smaller revisions, then usually you could just do the choices by hand. So in a lot of content management type situations, those merge conflicts can be sorted just by a human curator. So there are cases where that also is going to be an option.
Okay, thank you very much. I think that's the questions we had for you, Gavin. Great presentation. Thank you very much. Very interesting to listen to.
Thank you.
I think that's it. We've got a couple more minutes to wait as we wait for our next presenter to begin. So if you just bear with us for a couple of minutes for everyone else, and we'll start again at 30 minutes past.
Hi Percona Live Online. We hope that you're enjoying the conference so far. As we're presenting live, one of our previous speakers has finished slightly early. Please bear with us while we get the next speaker to start on time. In the meanwhile, have you joined the Slack channel yet? Slack is the official chat channel of the conference, and you can join using the link on screen now. In here, you can engage with other conference attendees and ask questions of the speakers. We thank you for your patience, and we'll be with you really soon. Hi Percona Live Online, we hope that you're enjoying the conference so far. As we're presenting live, one of our previous speakers has finished slightly early. Please bear with us while we get the next speaker to start on time. In the meanwhile,
I think we're back on track. Welcome again, everyone, to Percona Live Online. My name is Alex Smith. I'm the Professional Services Manager for Percona. And our next speaker is, let me see if I get the name right. Is it Jorg or Jorge Torres, CEO of MindsDB, who will talk with, sorry, Jorge, sorry. Who's going to be giving us a presentation on what if we could use machine learning models as tables. And that's it for me. I'll hand over to you now. Okay.
Okay. Let me share my screen. Having trouble sharing the screen.
You can see your screen now.
You can?
Yeah.
Okay. Just bear with me 1 second. All right. Okay. Hello, everybody. My name is Jorge Torres. I'm the co-founder and CEO of MindsDB, and I'm here to present to you an idea about what if you could use machine learning models as tables. This is frozen. Sorry. For some reason, my browser just froze.
The joys of presenting live.
Yeah, I apologize. I'm going to stop sharing the screen just 1 second while I reset the.
Sure. Do you want us to try pull up your slides?
Yeah.
Okay. Just give me a moment. Okay, sorry, just bear with us for 1 moment. Do you want me to share my laptop screen as the slides?
Yeah, I'm just restarting my browser. Okay. I'm really sorry about this.
That's okay. These things happen. If that doesn't work, I can share my screen with you. It's no problem. Just while we're waiting for the slides to reload, I'd just like to take this moment just to remind everyone that we would really appreciate if you could go in and rate the talks that you have watched so far. If you go onto the Percona Live agenda and click on the talk specific to the one that you want to rate, you can go in there and let us know what you think. So with that, it looks like we're ready to go. So Jorge, I'll hand it back to you.
Yeah. Sorry, everybody, about this. So it's an idea about bringing machine learning models as tables, and why we're doing this, and how we did this for MySQL and Postgres, and a demo. That's essentially what we're going to walk you through. The first thing is anyone that has dealt with machine learning before understands that clean data is a fundamental ingredient to it. And a lot of clean data already exists in databases. You know, like actually when you put information in a database and in tables, you're kind of like turning that into information per se. So the main requirement for machine learning is already existing in like many databases out there, and therefore, if it already exists in databases, it makes sense that we could try to bring machine learning to the database itself. And can we do this? Can we perhaps train models and use models straight from the database? And maybe machine learning or applied machine learning actually better lives in the application layer, in the data layer rather than the application layer. So let's assume that we can. And perhaps if you think of a machine learning model, you can think of a machine learning model as a table where you can select the variables that you want to predict, and you pass the conditions for your prediction, and that's essentially what you have. If you can do this, we would like to call this particular kind of tables a little bit different than how you can call a normal table. Let's call them AI tables. And the main difference between an AI table and a regular table is that when you query an AI table, you're actually getting information that is generated upon being queried. Whereas when you query a real table, you're getting actual data that exists in the database. But functionally, they should behave the same way. And if we start doing this thing, then again, we can start moving the machine learning components from the application layer to the data layer. And in our opinion, this structure of machine learning lives better in the data layer, because that's the main source of any machine learning model is information. And even when you consult the machine learning model, once it's being trained, you're actually just querying a model. So by making this transition, perhaps we need to also think of, well, if we can query machine learning models as tables, can we train them? Can we test them as we actually use a database as well? And one way to do this, and is of course what people do today, which is using PyTorch, TensorFlow, and all this. And many people love it. But in reality, most developers and most people that are using databases, they understand machine learning, but they would like to get their hands into solving the problem rather than building the machine learning part. So we should cater for both, rather than just allowing people to test and create models separately and then loading them into the database. It's thought that maybe machine learning automation, it's also a great fit for databases themselves. So think of the process of creating a table. It's very similar to the one of creating a model. You want to, define whatever columns you want to predict, and perhaps you want to do it from what data you're going to load it from. And if you think about this, probably the best interface will be, well, I would like to create a new AI table that will predict these columns from this given table, and use all the other columns from that table as input, and publish that as whatever I want to publish it. So we thought that maybe we create a construct, which is a table called predictors, in which you can insert that very same statement. You want to insert what is the name of the columns that you want to predict, from what table you want to learn, and also how do you want to publish this. Then that will be an instruction for an AutoML framework to actually go and take that task and build and train a model and test it and do all the things that AutoML is good at, and then publish that as a table that you can query as if it was a real table. So with this idea in mind, we thought, well, still what we want to ensure is that people that are in the application layer, they can consume these tables in the best possible way, and in a seamless way as well. So if people within the application layer, they don't see any differences from the AI tables and the normal tables that just connect to a database, we can perhaps use this very nice feature of many databases of today, which is federated storage. And in that way, we can publish specific tables that don't exist in the database, but when you connect to your actual database, be it MySQL or Postgres, you still see these tables as if they existed there. And the same way, you can pull the information that you need to generate and train from the table itself. So the way that we do this, again, Postgres has forwarding data wrappers. MySQL has the federated store engine. MariaDB has a connect engine. So by using this, we can kind of essentially embed these AI tables into the databases that actually support federated storage. And in that way, we can bring machine learning and AutoML down into the data layer. I think that the best thing from now is to show you an actual demo, because this is something that is already built, and we actually are announcing right now in Percona. So I'll hand it over to Soren, and he will guide you through the actual experience.
Thank you, Jorge. Let me just share my screen. Okay, so hello everyone. So my name is Zoran Bandowski, and I'm working as a full stack developer in MindsDB. In this 10 to 15 minutes demo, I will guide you and present to you how you can train and query the machine learning models directly from PostgreSQL database by using MindsDB AI tables features. As a prerequisite for this one, you will only need to have MindsDB installed, which could be installed as any other Python module. So you will do pip install MindsDB, and that's all. And after that, you're starting just with Python and MindsDB. After MindsDB started, it will create some of the prerequisites for connecting to your databases and provide you an option to to integrate with those databases. So right now, what we will try to do in this demonstration, it's let's imagine that we had airline passenger satisfaction data inside our PostgreSQL database. What this table contains is an airline passenger satisfaction survey data. Let me just quickly show you how the data looks in our PostgreSQL. So I will try to select from the table. This table contains different features as class of the travel class in the plane of the passengers, something like business or economy. Also, it contains information about the customer type, purpose of the flight of the passenger, satisfaction level of the on the in-flight Wi-Fi service, and other features. So what we will try to do now is from this data is to try to predict the passenger satisfaction based on the other features. The first thing that we will need to do here is to train the machine learning model. How we can do that is by simple inserting inside the MindsDB predictors table. How we can do that is just using the simple insert query that we will provide some information in. So what we're trying to do now is just do some insert query inside the MindsDB predictors table. And as parameters, we are adding the name of the machine learning model that we will build. So I will call that passenger satisfaction model. Let me just add a demo at the end. What we will try to predict is the target variable that we will try to get the predicted. So from this data, we will try to predict the passenger satisfaction. And the third argument here is the select query, in which we are telling MindsDB from where the data should be ingested. So we are just adding the select statement, and we are trying to select the values from the table. And just for the demo purpose, I have added like a limit here, just because the data set is quite big and it contains more than 100,000 rows. So if I run this, you can notice that MindsDB started in the background. It's trying to do a black box analysis and start a process of extracting, analyzing the data, transforming the data. And it will take some time to train the machine learning model based on usually that depends on the size of the data, the columns types, and etc. How we can check that the training has successfully finished is we can do a select from MindsDB predictors table. So if we try to select, we'll get two records here. The one is passenger satisfaction demo model that we are trying to train now at the moment. And for the sake of demo presentation, I have one pre-trained, so we don't need to wait of this one to finish, as you can see here. So it says the status is completed, and for the previous one, it's still training. So while the model is still training, what we will try to do next is we can try to get the passenger satisfaction out of the trained model. Well, how we can do that? It's quite simple. By running a select statement on the model, which behaves like it is a standard database SQL table. Let's select the predicted value and confidence, and the additional information in the select that we will add will be, let's imagine a customer that is customer that is loyal customer, that he rated that the in-flight Wi-Fi service in the are quite good, that he's traveling, the type of travel that he's doing is a business travel, and the class that airplane class that he's using is an economy. So if we run this select statement, you can see that MinesDB already returned the results back. So MinesDB thinks that the predicted value is that this customer is quite satisfied with the airline agency that he is using, and the confidence for this, MinesDB thinks that this value is like around 95% confidence for that. There are additional informations that we can query from the models, and that provide us additional statistics about why this prediction and why this type of confidence. So I will run additional select statement. So in this one, I have included additional satisfaction explain column, in which MinesDB will try to provide additional information. So not just the predicted value and confidence, but additional statistics. So let me just try that one. So it's quite similar. So we are just selecting the predicted value, the confidence, and the informations, and we are adding in the where clause the other features for getting these predictions. So here in the info, you can check that the predicted value is satisfied. So MinesDB thinks that this user was quite satisfied with the airplane agency that he is using. The confidence again, but there are additional information like the prediction quality. So MinesDB thinks that this is it's very confident for having this prediction. Important missing information. So what model thinks there are quite important features to have while training the model, but also when you're querying the model. So MinesDB thinks that the flight distance, the online boarding, and baggage handling are quite important for getting better prediction. And also you can see the ID here, which could be easily excluded. When you are creating the insert statement, you just add the remove parameters value, and you're including the columns that you want to remove from the training. Additional to that, we have an extra insights where we're trying to guess how MinesDB would predict if some of the values that we provided in the where clause are missing. So for example, if customer type was missing, the model would predict satisfied, and also it's returning the informations for the other features, and MinesDB is trying to guess those predictions. So yeah, it's quite simple what we tried to did here. So we covered two things. The first one, with a simple insert query inside MinesDB predictors table, we were trying to do the auto machine learning in the database and try and create the machine learning model. And the second one was using the select statement. We were able to query the model and get the predictions back from it. What I show you right now was through the PostgreSQL database. But here in the right side of my screen, if you can see, I have MySQL opened, and I can do the same thing from MySQL. So even if this one created from the PostgreSQL, you can connect to your MySQL and also do the same querying, the same training as it is in any other database. So just for this presentation, I will try to select everything from MinesDB predictors. And you can see here that we have the two machine learning models, the one that I have pre-trained previously and the one that we did through this demo. So you can see that the stylus is complete and we have around 94 accuracy. Yeah, so as an overall, it's quite easy. Anyone that have a general knowledge of databases and SQL can train and do the machine learning right from the database with just simple insert and select query. And it's not related just to one database. You can do that in the Postgres. You can do that in the MySQL. We have other integration like MariaDB, MySQL, ClickHouse, and other databases. On top of this, there is some graphical user interface that we have built for visualizing of most of the things that I already showed you. So I will just try and quickly share that one with you. So we've built this graphical user interface that we call Scout. just for explainability features, and everything that you can do through the SQL can be done here with few clicks around. So in the integrations tab, you can see that I'm already connected to the PostgreSQL and MySQL. The interesting part that I want to show you is data sources. So if you go to the quality tab here, what we will present right now is you can get the additional data analysis information, like score for each of columns, input values, and variability of those values in the data set. MindDB looks in every column, tries to analyze the data, figures out the quality, and shows suggestions and warnings about the data that you have. So you can see here, I have some warning for some of the features. So for example, for the customer type, we have a one warning that there could be a potential bias in our data. And MindDB is giving you a suggestion that you need to check the occurrences of variable on the data set. Also, if we scroll around, I guess there should be more. So if we check the arrival delay in minutes column, we can see that MindDB thinks there are two warnings for this one. So there are some potential outliers in our data. We can visualize those, and you can see from which values MindDB thinks that these outliers came from. Additional thing here is the predictors, where everything that we train through PostgreSQL can be done with a few clicks. And also you can do the same query that we did with the select statement, but you can do it from here through our graphical user interface. So let me just try and show you that. So what you can do, you will select the model. You will just provide some information that from which you want to get the prediction. I will just add one for the demo purpose. And if you try and run the query, now MindDB will display the predicted value here. So you can see that for this query, MindDB thinks that the user was quite satisfied with the airline agency, and MindDB thinks that it's 94% confidence for doing that. Yeah, I think that pretty much covering what we will try to present. And if someone has any questions, please share them on the Slack channel. And I think that Jorge will share with you our social profile so you can check what we've presented right now.
Hi, Zoran. Is Jorge talking anymore? Because we do have two questions that have come through. Who's shining those at, Jorge or yourself, Zoran?
We can take the questions right now and in between Zoran and myself, but let me share in the meantime this, and yeah, let's go for the questions.
Okay, all right. First one is, can I train the model with other data sources and query them from the database with SQL queries?
Yes, you can certainly plug in data sources from the following options that we have right now, which are like from files, URLs, information that lives in either ClickHouse, MariaDB, Postgres, MongoDB, MySQL, Microsoft SQL Server. And then you can just train from data that lives in any one of those, and then you can consume them from any of those databases as well. So right now, the ones that we can publish to are the ones that support the foreign data wrapper or kind of like a federated storage. And we also are adding other data sources such as Snowflake and like the usual data lakes, so that you can pull information from those but still consume them from your normal database rather than your data lake.
Okay, thank you. And the second one is, can I tune parameters of the model, or can I use other machine learning libraries like scikit-learn, PyTorch, etc.?
Yeah, so you can bring your own models, so long they're either on scikit-learn or PyTorch. Those are the two frameworks that we support. And yeah, you can wrap your models around, and there's a way for you to like upload them through the graphical user interface.
Okay, thank you very much. I don't think we've got any more questions that have come in. unless Bronwyn tells me differently. So I think that's it for us. I think, Bronwyn, we've got another 5-minute gap now between now and the next presentation.
Yeah, we have. So just while we wait and begin our speaking slot on time, I am just going to play a short video here that will just fill the space a little bit, and then we will hand over to the next speaker.
Thank you.
Thank you, Jorge. Thank you, Zara.
Thank you, everyone.
My name is Manu Rigger. I'm a postdoctoral researcher at ETH Zurich in Switzerland, mentored by Professor Janu Su. And in this short talk, I'm going to present you SQL Answer, which is a tool that I've developed to automatically find logic bugs in database management systems. So what are logic bugs? I want to explain this on a short test case that was actually automatically generated by SQL Answer and exposed a bug in a previous version of SQLite. So if we execute this test case with the latest version of SQLite, where the bug has already been fixed, then the correct result will be returned, which is -1. However, if we execute this with an older version of SQLite, namely the version that we tested, then the incorrect result is returned, which is the empty result set. In general, logic bugs are bugs that cause the database management system to return an incorrect result set. SQL Answer automatically finds such bugs by automatically generating test cases that are then sent to the database management system under test. The result set that is then returned by the database management system is inspected by SQL Answer, which judges either if the result set is correct, such as here, or if SQL Answer finds that the result set is incorrect, then it will actually display an error message that the database management system is affected by a bug. So overall, there are two main components that SQL Answer uses, namely, first of all, it generates an effective test case. For this, it has a component to generate the database as well as queries, and the random database and query generator is actually implemented for each database management system that SQL Answer supports. More importantly, SQL Answer contains a test oracles which can decide whether the result set that is returned by the database management system is correct. And this is actually the most innovative piece of our approach and of the tool. Namely, we came up with 3 test oracles that use different ways of judging whether the result set is correct. We have non-optimizing reference engine construction, NOREC, pyramidal query synthesis, PKS, and ternary logic partitioning, TLB, as such approaches. Now I'm going to present you NOREC, which is an approach that has detected over 150 bugs alone. Let us revisit the example. So, assuming that we execute this on the buggy version of SQLite, we will get the empty result set, such as mentioned before. And what this means is that basically for the single row that is contained here in the table, the were clause evaluated to false. Now, what we do next, or what SQL Answer does next, is it derives a second query from the first query by moving this condition, this predicate, directly after the select clause. And for this version, SQLite actually returns true. Now, the predicates, or what is contained here in the result set, are either true or false values, depending whether the predicate evaluates to true or false for the respective row. Now, when looking at this, we might notice that this cannot be true, because this indicates that the result should contain one row, because for one row, this predicate evaluated to true. This was not the case, and this discrepancy allowed us, or SQL Answer, to detect this bug. So why could SQL Answer detect this bug? Well, the insight here is that queries of this form, they are often optimized, and here actually SQLite could profitably use an index, but unfortunately, when going through the index to the bug, it missed this value here. And for the second query, to which we refer to as the unoptimized query, actually the predicate must be evaluated on every row, so that the database management system under test cannot or does not meaningfully evaluate this query. So overall, NORAC detects bugs in the query optimizer specifically by translating an optimized query to an unoptimized query. Using this and other approaches, we have found over 450 unique bugs in popular and widely used database management systems, such as MySQL, Postgres, SQLite, and others. You might also try the tool yourself and report bugs or even contribute to it. It's actually quite straightforward to get started with it. All you need to do is to clone the repository, use Maven to build the tools, and it's written in Java, and then execute the jar selecting which database you want to test and which test oracle that you want to use. If you're interested in more information, we have published 3 scientific papers on the different testing approaches, which you can find on my homepage, and you might also check out the SQLancer Twitter account that we have. So with that, I want to thank you for listening, and if you have any questions, then please reach out to us. Thank you.
Hey everyone, good to be back. That's the end of the 3 that I've been hosting. Thanks to Emily, Gavin, and Jorge for 3 fantastic presentations. I'm now going to hand over to my colleague Camilla Arusa, if I've got the surname correct. I seem to be getting them wrong all day, so apologies if I've got them wrong, but over to you, and I hope the rest of your Percona Live goes well. Thank you, everyone.
Well, hello, everybody. Thank you so much, Alik. Thank you all for having me. I am Camila Rosena, HR assistant in Percona, and I'm based in Montevideo, Uruguay, South America. I am going to be your host over the next hour. I will be checking out questions on the Percona Live online Slack channel and YouTube, so you can ask all the questions there. And if we don't have time to answer your questions after the presentation, the speaker will try to answer those in the Slack channel. So now we are ready to move forward. I'm thrilled to introduce you to Elisha Chistenga from Zimbabwe. Elisha is a finance software developer and speaker with vast experience and knowledge in cloud technologies, security and compliance at Crest Club Advisors. Crest Club Advisors is a YAF-based open source organization advocating for tech-based solutions to Africa challenges through open source technologies. He will be talking about mastering open source data governance. And well, now I'm going to hand it over to Elisha. It's all yours. Welcome.
Thank you so much, Camila. Thank you so much. And I think everyone is hearing me.
Yes, we can hear
Hello?
you.
Yes, we can hear you.
Okay, if you're hearing me, so I'm clear to go. Let me put my screen share for the slides. Hello, is everyone seeing my slide?
Yes.
Yeah, you're seeing my slide.
Yes, we are seeing your slide.
Okay, thank you so much. So I'm ready to take off.
Okay.
As it says, thank you so much, Camila, for introducing me. My name is Elisha from Zimbabwe. I'm a certified information systems auditor. So I'm happy to have you all guys. My Twitter handle is there at Chitenga. I'm always available at Twitter 24/7. Here, I'm going to talk about the mastering open source data governance, like in Percona.
Hey, Alicia, can I just stop you there for a moment? Can you, it looks like you've paused your streaming. Would you mind just sharing your screen again?
What about now?
We just can't see the slides. Can you just stop sharing and restart it again?
Okay.
Okay, just try it again.
Now? What about now? Are you seeing it?
Yeah, just give it 1 second.
Are you seeing the slides?
Yeah, now I can see it. Yeah. Okay, you're good to go.
Okay. Thank you so much. Thank you so much. Yeah, as I said before, my name is Elisha. I'm going to talk about mastering open source data governance. I'm happy to have you guys. I'm also available on Twitter. I'm from Zimbabwe. Firstly, I'm going to introduce what data governance is all about. Like in the instances we are around the world, we have got ever-changing data environments, such as cloud and the data requirements and data maintenance that need to be considered. So with that increasing complicated, we need to look at data governance. How do we manage our data? How our data is being stored in all our database. So that's what the presentation is going to talk about. Let me take you to what data is all about. Data is all about the text, numbers, or videos, or anything which we can use. That's the data that we can feed into a system to come up with information. So after data has been made meaningful, they will become information. That's the information that we need. If it is, for example, we are in the time of Corona, COVID-19, information will be coming from each and different departments within a country or within whatever department it is. If it is in an organization, then from that information, we can make up from that data, we can make up the information that is crucial for the operation, especially in the open source enterprises or open source organization that we have. That's my introduction. Then data governance ensures that. So when we talk about data governance, we need to look at the stakeholders. What the stakeholders needs? The stakeholders, they include if it is the directors for the company, if it is the users, they're also part of the stakeholders, the engineering team, or whoever who is interested in such data, it's the stakeholders. So what they need, that's what we need to be taken into consideration whenever we are looking at data governance, especially in Percona databases. Then we need to look at the direction. What direction has been set for the information management capability? What direction? Direction is like the steps that we have for managing that data. Then we look at the performance and compliance of data or information as it is being monitored or evaluated. So that's what data governance is all about. So you can just take the stakeholders, what the stakeholders needs, the direction that need to be set, and also the performance and compliance. That's what comprises the data governance. Yeah, then we move on to what data governance. It reflects the practice of evaluating requirements, bringing direction, control over data and information, so that users can have access to data and can trust on. So whenever we take the data we might have at a certain time, we need to evaluate the requirement and also set the direction, control of that data, so that whoever is using it, we have the confidence that this data is valid data. So you're going to learn about the characters later in the presentation. Then we move on to, it involves data governance. It involves the monitoring performance of IT operations. This is specific areas that relate to data and that means we need to look at the availability, integrity, and confidentiality. That's the three most important characteristics of data governance. Availability, is that data available? How integrated is that data, and how confidential is that data? But some of the data that we might have is so sensitive, so we need to take steps to protect it. Then we move on to open source data governance management. This DMBOK defines data governance as the planning, execution of policies, practices, projects that require control, deliver, protect, and enhance the value of data. So that's what the data governance is all about. It's all about the planning and execution of policies, practices, the projects that require the control of data. So first we need to acquire the data, we need to control it, then we need to protect it, then we need to deliver it to that data that the delivery will be like the information that the output, and also to enhance some, if you need to put some value to it, like value addition to such data. But data is part of our information assets, especially in the open source industry. Then data governance is also part of data enterprise architecture, which is the part of the enterprise architecture, as you can see. It's also part key of what is important in enterprise architecture. Then you move forward to the characteristics of data. Characteristics of data, we need to look at the three sub-dimensions. Firstly, we need to look at intrinsic, how intrinsic is that data. Then we go on to contextual, then we go on to security or access. So I'm going to take you through the sub-dimensions of data governance. Firstly, information quality, that all that quality of information should be. If it is, we talk about intrinsic, we are talking about the extent to which the data is in conformance with the actual or true values. On the intrinsic effectors that we need to look at, accuracy. Is that data we are processing in our databases, is it accurate? Is it true or correct? As you know, because if you put this inaccurate data, we might have inaccurate information, we might have inaccurate decision that comes from out of that data, that data which is passed out as information. Then you go to objectivity. Is that data unbiased, unprejudiced, or impartial? We need to look at it whenever we are going to talk about the intrinsic value of quality of data. Then we've got the deliverability. Is that data true and credible? Then we've got reputation. We need to look at the highly regarded term, especially in terms of its source. Where did that data came from? Is it that it came from a reliable source, like someone who is instructed to come up with that data? So we need to look at on the intrinsic values, the accuracy, how accurate, the objectivity, and the deliverability, and also the reputation. Then we'll go on to the contextual quality criteria. This one is the extent to which information is applicable to the task of information used presented in an intelligible and clear manner. As you can see, the presentation is what the contextual data quality criteria talks about. That information quality depends on the context of use. Here we on that, the factors that we need to look at. We need to look at relevance. How is that data relevance to the information, to the use of in the open source industry? If it is applicable or helpful, we need to look at completeness. Is that data complete, or it's missing some information? And we go on to talk about the currency. Is it that data is sufficiently up to date? Then we go on to the appropriate amount. The volume of information is appropriate to the task at hand. Is that data we can take it as of the appropriate amount of, or it is missing? Then we are continuing the quality criteria for the data in our databases. We need to look at the concise representation. Is that it compactly represented, or it has got such kind? But then we want to the consistent representation. Is it presented in the same format? So we need to look at our data standards. Are they consistent, especially when they are passing out information like in the presentation? Then we go on to the interpretability, which talk about is that data presented in an appropriate language, unit, or function, or definition? That's what we need to look at also. Then we're going to the understandability. Sorry for the spelling. Understandability. Is that data easily comprehended? Then lastly, we have got the ease of manipulation. Is that data is to manipulate whenever the stakeholders need to work with it? If it is the engineering team, like the design, the guys that need to look at it, look at like this system development in that process. We need to pass that data from the other guys to the other department to other department. That data can manipulate, those guys can easily manipulate it to come up with the result they need to. Then lastly we have got the quality criteria, which talks about the security or accessibility. This one is the extent to which information is available or obtainable. On that one, we have two items. Firstly, we have got the availability. Secondly, we have restricted access. On the availability, we need to look at, is that data available when required? When we need that data, can we easily require? Like the availability, if you talk about the cloud is always there 24/7 and it's easily available. That's how our data should be like especially in terms of availability, and can it be quickly retrievable? Then we talk about the restricted access. Restricted is that data restricted to appropriate parties. We're talking about the unauthorized people. Unauthorized can get into our databases if there's no any restriction in place and manipulate that data, so that at the end of the day we might have corrupted data or some problem. Then we go on to the data lifecycle. What is involved in when data is coming from its origination to the end? So here we are going to have the data lifecycle, like the stages that data goes through in the course of its existence, in an organization or in but this data governance applies to all the organizations around the world. Here is the data life cycle. As we can see, we start with data planning. We need to plan our data. How our data are we going to use it, and how are we going to acquire it? Like the creation, acquisition, and use in the planning stage. Then we go on to the design stage. In the design stage, we are going to specify how information will look and how system processing information will work. So firstly, we need to plan. Secondly, we need to design. Thirdly, we need to build or acquire. Like the information resource is acquired. How are we going to build or acquire that data? Then we go on to use or operate. On that one, we have got three factors we need to look at during the use or data operation. Firstly, we need to look at the store. How are we going to store the data? Secondly, we look at the sharing. How are we going to share the data? Are we going to make it available to the public? Are we going to leave it to certain people? And thirdly, we're going to use. Who is going to use that data? That's the use or operate in the data lifecycle. Then we go on to the monitor. We need to keep on monitoring, like information resource continues to work properly. Is that we need to monitor, put steps and some strong controls how that data is being used. That's in the data lifecycle. Then lastly, we've got to look at the dispose, like information resource is transferred or retained for a defined period. If you are going to use that data for 10 years, how are we going to dispose it after 10 years or retain it in the system? We might retain that data or we need to destroy it. We're going to learn in the next slides. Then that one we are going to talk about the end, how are we going to handle that data or archive it. If it is not sensitive data, we can archive it, but there are guidelines which need to be followed, especially in each and every region. If it is in Europe, there are some guidelines which restrict the data disposal, and also in US, there's also even here Africa. So we need to look on how the data is going to be disposed. So this is our life cycle. Then we are going to take the data life cycle summary. Here's the data life cycle summary. The activities that involved in each of the stages of the life cycle I've talked about. Firstly, we've got the design. In the design stage, we need to activities that happen in that stage is like in the design we need to look at the definition, data definition. How we are going to develop our data, like data definition, data collection, access, storage, like the metadata characteristics or data classification. We need to look at it whenever we are going to design our data, especially when we even started the process. Then we go on to build or acquire. The activity that involved in that refers to the creation of data, purchase of data, or loading of external files. After acquiring the data, if we acquired from third part or our data providers, we need to, how are we going to purchase the data and load it into the external files? That's the activity that's involved in that stage. Then you go on to the use or operate. That one we have got three, as I said. Firstly, we need to look at the store. How are we going to store the information? It's either electronic or hard copy. As you know, data can be stored in electronic, like the in the SSD hard drives or in our data warehouses, or as a hard copy like paper document. They also, if it is electronic or hard copy, they also constitute the data that we need to work on. Then we go on to share. How are we going to share that data to let into the places where it's going to be used? Because data, if you are sharing it, we don't mind if you are sharing someone for some people in Japan or some people in South Africa or some people in Brazil. So that's how we're going to, we need to look how we're going to share that data. Then we are continuing the use or operate the data. On that one, how are we going to use that data? Information usage activities like information retrieval and converting from one form to another. We need to look into what happening with that information. If we are going to retrieve it from our databases and we are going to convert it into one form to another, that's what is being involved in that data life cycle. Then you go on to monitoring. We need to keeping information up to date. We need to keep it up to date, like updating information each and every time, and other kind of information management activities that involve enhancing. We need to keep on cleansing. We can even merge with some new information from the other data providers, or remove some duplicate information in the data warehouse. So we need to, this one is the important step, just because we need to keep it monitored, just because we don't need to keep obsolete that data or data which we don't use often. Then we go on to dispose. In the dispose process, the activities in this phase may refer to the information retention, archiving, or destroying the information. After we have used all the information, we might decide to archive or retain it or to destroy it. It depends how sensitive that information, how useful that information. If it became obsolete, so we don't need to keep it anymore. So that's the data life cycle that is involved. I think I'm done with my presentation, and I have some anonymous questions that come to me during the preparation of this presentation. Like someone might ask, how can we ensure that data captured and meets the required standards? And also the second one, who is responsible for ensuring configuration of open source data application database management are in line with expected objectives? And I think I'm done. This is the end of my presentation. Thank you so much. Back to you, Kami.
Great. Thank you so much, Elisha. Great presentation. Well, we have some minutes left, so I can share with you some questions. For example, how can we ensure that captured and processed data match required standards?
Thank you so much for the question. And I think this question I'm going to answer it in detail is in our Slack channel, where I'm going to give each and everyone tips on how we can ensure, because that one is another presentation that we need to consider in the future. How are we going to come up with the standards? How are we going to come up with the, as you can see?
Okay, great.
Is it
Well,
okay
now
with you?
we will share some filers content now, Bron.
Okay, thanks everyone. Just while we wait for the next speakers to start in about 6 minutes, we will play some content. We have a pre-recorded video actually from Matt, who unfortunately can't be with us today, but we will be sharing some content that he has pre-recorded actually from the last event. So please stay tuned and we'll be back with you in about 5 minutes time. Thank you.
Hello, Matt Yankovic with another quick hit. So this quick hit is, why should you consider a multi-cloud, or should you at all? And so we wanted to take a few minutes to just talk about this. Now, that is a good question. A lot of people are talking about, do you need a multi-cloud strategy? And a lot of them want to know, do you really want one at all, right? And so this is a critical question a lot of people are struggling with. And what we've seen in our data, as I pointed out earlier, is that multi-cloud growth is becoming more of a new reality. So when you look at our survey data so far this year versus last year, we've seen a 9% increase in the number of companies that are deploying a multi-cloud strategy. And this is nothing new. If you look at headlines today, you can see that multi-cloud deployments and strategies are a common thing. And in fact, a lot of cloud providers are now starting to promote their cloud software as hybrid or multi-cloud in order to capture more market share. And this is an important thing to understand, because this is a trend that they're starting to see and they're trying to capitalize on as well. So this is a reality now. Now, some points to consider when you're considering a multi-cloud strategy. So the first point is, it's probably already happening to you. A lot of our data shows that people inherit multiple cloud systems or multiple applications running in multiple clouds, and that's how they first get into the multi-cloud strategy. So you probably have a couple of development teams or a couple of business units that are already running in a different cloud than what you might have standardized on. So this shadow IT type of problem has existed for a long time. There's a lot written on it, so it's already happening to you. Now, one thing you're going to realize pretty quick is, at least initially, this is going to increase the complexity of your systems. And it is going to cause, some heartburn for some folks, because when you're trying to deal with using competing APIs or different application stacks, and infrastructure as a service stacks in multiple locations and multiple providers, it will increase the complexity, even if it is just a smidge. But it really impacts the team, because if you've got certified AWS engineers and all of a sudden you start to inherit things that require Azure or Google, that means that your teams need to start to come to speed with those tools as well. So realize this is going to increase the workload for your teams, at least at the start. And your costs are probably going to go up as you start to experiment here and figure out what the best solution and best combination is. Also very important to consider. So why even then consider this? So number one, because you have to, right? As I mentioned, a lot of companies have a lot of technology that they have been forced to adopt or inherit. So you probably already have some databases or some things that are running on multiple cloud providers already. And so you're going to have to deal with it. But that's not the primary reason. The primary reason most people are looking at this is really more of an insurance play. So they want to ensure that they have, portability between cloud providers in case, costs raise, or, in case, things in one provider move more rapidly in terms of adoption or new technologies. But you also have protection, right? And we're not talking just about security protection here. We're also talking about the protection from outages. And we all know that, big systems, big infrastructures do have outages. So being able to run a mission critical application across multiple providers, if one provider goes out, you still can service your customers and they won't notice a disruption. That is the nirvana, that is the goal. And if you can make that happen, then you need to make that happen in order for your business to survive. And that gets to this business continuity piece. If you think about most companies and most database infrastructures, we've had business continuity plans and high availability plans forever. How many times have you gone through a DR test failing over between data center 1 and data center 2, ensuring that your critical systems will still work? It's the same thing here. You're just using multiple cloud providers and public cloud providers to maintain that. And so we're seeing that growth there. So the business continuity and ensuring that you can go between cloud providers and survive those outages is critical for many businesses to survive. And protecting that business and protecting your revenue stream, that is the primary reason people are looking at this, right? Not only do you have to, you're being forced to, but you're starting to realize that as an outage happens or a slowdown happens or something happens within one provider, having that protection to go to another provider is mission critical. And so long-term costs can also start to be mitigated, because as cloud providers compete on price, and they do, you're going to see that having some portability gives you some flexibility in where your costs are and how much you're spending.
Okay, great. I think we are ready to move forward with our next presentation. I'm so excited to introduce you to Tong Sang and J.V. Baker. J.V. Baker, our next presenters, are both located in US. Dr. Sang is a co-founder and chief scientist of ScaleFlux, responsible for developing key techniques and algorithms for computational storage products and exploring their optimal use in the mainstream application domains such as database. J.V. Baker is a successful technology business leader with a track record of driving top and bottom line growth through new products for enterprise and data center storage. They will talk about how can database capitalize on computational storage. So if you are ready, I will turn it over to them now. Welcome, Thong and JV.
Thank you, Camilla. Share screen. Okay, is that coming through well?
Yeah, all good.
All right, great. Yeah, so I'm JB Baker, Vice President of Marketing for ScaleFlux, and we're going to lead you through how databases can take advantage of computational storage. So first, just a very quick intro to ScaleFlux and computational storage, and then we'll dive right into the benefits of computational storage for databases, and then examples of how you can achieve those benefits. So ScaleFlux has been around since 2014. We're a leader in this emerging category of products called computational storage. We were the first out into production with a computational storage drive, and now have our second generation of computational storage drive out in production. We have consistently been winning awards for innovation and leadership in computational storage across different industry forums. And now computational storage, a newer term in the industry, has come out there, and we've got a definition that's been worked out with dozens of companies who have joined an industry group called Storage Networking Industry Association. There is a working group focused on computational storage. And we've come to a definition that the core of the definition focuses on offloading processing from the host CPU to other devices in the system, reducing data movement, which those architectures enable much more parallel computation and helps alleviate bottlenecks that have come into existence in the overall infrastructure. Now, a computational storage drive takes the features of an enterprise class PCIe SSD and adds to that some compute offload engines. So within the drive, we're going to do some direct compute on the data. Now, to illustrate how this benefits the system, in the traditional processor-driven architecture, what we saw is all the data has to pass up through the CPU Maybe there are offload engines with FPGAs on add-in cards, but all the data has to pass back and forth through the CPU structure. And that was fine when you had hard drives serving up megabytes per second of data. But as we've transitioned to SATA SSDs and SAS SSDs and now NVMe SSDs that deliver 3 gigabytes per second of throughput, you put multiple drives in a system, now we've created all these bottlenecks up at the CPU. And there's very little parallelism in the compute function. With computational storage, what we do is enable a much more data-driven architecture where we move some of those compute offload functions. Rather than having them sit off to the side of the CPU, we put them right down into the drives. And what that is going to do is create a much more balanced overall structure. And it enables the compute to scale nicely with the storage performance, because every single drive bay is now also has some compute function in it. So we've got tremendous parallelism, and we're able to significantly reduce the overall movement of data and get rid of those bottlenecks. Now for Percona customers, what the key focus is going to be around, okay, great, there's computational storage, but what does that mean for my database, right? What advantages can I realize there? Really two core categories of benefits. First one is going to be increasing performance, whether you're focused on queries per second, transactions per second, your latency or quality of service. We're able to improve those by alleviating those bottlenecks. And then secondly, if you're more DevOps or data center manager, reducing your cost. So cutting down the total infrastructure that's required to achieve a certain level of performance, cutting down the power that's needed, and reducing all those efficiency metrics like cost per query or cost per transaction or cost per gigabyte of data that you're storing. And we've done significant testing with MySQL, MariaDB, Postgres. All of these can see the benefits. Now, to realize the benefits, some of them you can do without making any changes. Some are going to require some minor tweaks to your database or storage engine, and others are going to be a little more innovative. So first, without code changes, we think about more transparent functions here, and we'll talk more in depth about the benefits of compression and decompression being offloaded into the drive. And then in the future, some of the encryption and decryption and additional features may be able to be added in. For the minor tweaks, what we're talking about here, some non-transparent functions, we're going to have to make some modification to existing storage engines or to an existing database. An example that we've deployed already is predicate filtering for MyRocks. And in the future, which Tong is going to dive into more details on these, some things like sparse logging and dual mode page format. And then more innovative side here may require even new data structures and an optimized storage engine where we're developing the software with the hardware or the software to take full advantage of the new hardware capabilities. And Tong will go in more detail about these sparse data structures for key value. So first with the transparent compression, we'll talk about the performance benefits. So this graph is pulled from the white paper that was produced by Percona testing our drives with MySQL. And here what we see in the dark gray is an ordinary NVMe drive running kind of baseline settings, right? And then we turned on host compression, and you see performance dip down to the light gray line when you use host compression with an ordinary NVMe drive. When you plug in the computational storage drive, which has built-in compression decompression, it boosts the performance significantly. So with double write buffer on, you can see in that light blue that we get to 2x the performance of the dark gray in many instances here. And the bottom of the x-axis here is the number of threads that are running. And then with the computational storage drive, we also do support atomic writes, which allows you to turn off the double write buffer to gain an additional performance boost shown in the darker blue. In terms of cost, utilizing compression can help reduce the amount of space that's consumed by your storage or by your database, right? And Tong actually early on, or 2015 here, and his students at Rensselaer Polytech had done a survey of industry data to see how compressible different types of data were. And they found that database data tended to be greater than 2-to-1 compressible, or cut from its original size by 50% or more. And then as we've deployed the computational storage drive with built-in compression decompression out to customers, they are validating the work that Tong and team had done and feeding back to us that they see 2.5, 3, 4, 5-to-1 compression with their database applications. So utilizing this compression could allow you to cut your storage footprint by 50 to 80%. Now, sure, you could ordinarily, or you could use CPU compression to achieve a similar level of storage footprint savings, but that typically is going to come with a performance penalty. And we'll show that here. So in similar data, what we showed before, the dark gray here is the baseline of an ordinary NVMe drive running a 2.5 terabyte data set. Now we turn on host compression with that same data set, and performance dropped by up to 50%. And with this synthetic database, they achieved a 1.6-to-1 compression ratio using that host compression. What's happening here is you're burdening the CPU with performing that compression function instead of allowing it to focus on performing the database functions. Now with the CSD 2000, with the computational storage drive with built-in compression and decompression, what we see, we took a 4.7 terabyte data set. So this was much larger than the physical capacity of the drive, a 3.2 terabyte drive. And utilizing the compression, we expand the capacity. And what we see here is that while doing compression and storing twice the capacity, we achieve over 2x the performance of the NVMe with CPU compression. So we get the performance and the cost savings of the compression at the same time by utilizing a computational storage drive. So we talk about this as compression without compromise, or penalty-free compression, by offloading that compression function down into the drive and adding it with every single drive that you're putting into the system. And with that, I'm going to turn it over to Tong to lead you into more details about some of the minor tweaks.
Okay, yeah, thank you, JB. Okay, so yeah, the remainder of this talk will show that transparent compression could, beyond the straightforward deployment, the transparent compression could enable very exciting new innovation opportunities. Actually, it for the first time decouples the logical storage space utilization efficiency from the physical storage space utilization efficiency. In particular, as illustrated here, as this so in this cartoon, with transparent compression, actually we no longer have to fill each 4K byte sector with valid user data, and we no longer have to use all the LBAs. So as a result, the OS and the user applications can purposely underutilize the logical storage space in return for performance benefits, and meanwhile without sacrificing the true physical storage cost. So this really opens a very unique opportunities for system level innovations. So to better demonstrate the potential here, I will present a couple case studies under the 3 categories JB just mentioned. Okay, so, under the first category of simple optimization without any code change, so let's look at Postgre, so the second most popular open source relational database. So Postgre, we know that it uses a parameter called the fill factor to control the amount of space reserved in each 8K byte page for future updates, which further determines a trade-off between the database performance and the storage cost. So that is like if we reduce the fill factor to leave more space for future updates in each 8K byte page, the database performance will improve. But meanwhile, the storage cost will accordingly increase. So as a result, Postgre actually by default sets the fill factor at 100%. So that means that to fully fill the whole page with valid user data. So in order to minimize the storage cost. Actually, interestingly, like once Postgres runs on the computational storage drive with built-in transparent compression, the storage overhead caused by the reserved space will largely disappear because Postgre initialized the reserved space as all zeros, and the transparent compression can very highly compress those all zero segments. So this naturally enables Postgres more aggressively set the fill factor without sacrificing the physical storage cost. So to illustrate this, let the blue and the black dots represent the operating points when using our drive with built-in transparent compression as a normal NVMe drive. So with the default fill factor of 100%, they have pretty much the same performance. And our drive can reduce the physical storage cost by half through the built-in transparent compression. But once we reduce the fill factor to 50% under the normal NVMe drive, the storage cost directly almost doubles and the performance improves. So very clear trade-off between the performance and the storage cost. But under the computational storage drive with built-in transparent compression, we can expect the same performance gain, but meanwhile, the storage costs remain almost unchanged. So really if we further carried out the Sysbench TPCC benchmarking, we set the raw data set size at 1.4 terabyte. As we reduce the fill factor from 100 to 75%, from 100% to 75%, the TPS can improve at about 33%. But under the normal NVMe drive, the physical storage usage really jumps from 1.4 terabyte to 1.7 terabyte. But in comparison, as clearly shown here, that under our drive with built-in transparent compression, the physical storage usage only slightly increased from 340 gigabyte to 360 gigabyte. So this study clearly shows that by simply configuring the fill factor parameter, Postgres can take much better advantage of transparent compression to further improve the TPS without compromising the physical storage cost saving. Okay, so under the second category of minor tweaks on source code, now let's consider the implementation of a red hat logging. We know that in current practice, once we write one transaction into the in-memory log buffer and commit the transaction, the entire 4K byte block will be flushed from the buffer to one 4K byte sector on the storage. And after the transparent compression inside the computational storage drive, the compressed data block will be stored in the NAND flash memory. Then later on, once we write another transaction into the in-memory log buffer and then commit the transaction, the 4K byte block consisting of both current transaction and the previous transaction will be flashed to the same 4K byte sector on the storage drive and further compressed and stored to the NAND flash memory. So in the same way, upon committing the third transaction, we will rewrite the same 4K byte sector again and store the compressed data block. So clearly that as we keep flashing the same 4K byte sector to the storage drive upon continuous transaction commits, the exactly same transaction data are compressed and written to NAND flash memory again and again, really multiple times. So in this example, the same transaction 1 data are compressed and written to NAND flash memory by 3 times. So this clearly leads to the write amplification. So we know that a larger write amplification will cause more interference with normal I/O requests, and of course, the shorter NAND flash memory lifetime. So clearly, we want to mitigate this issue or even eliminate the write amplification caused by this write ahead locking. So to achieve that goal, we can apply a sparse logging data structure. The basic idea actually is very simple. So instead of tightly accumulating data transactions in the write ahead log, as in current practice, like for both MySQL, MariaDB, Postgre, always all the database use the same way. And then instead of doing that, we always allocate a new 4K byte sector after each transaction commit. For example, after committing the first transaction, instead of appending the second transaction tightly after the first one, so we put the second transaction in a new 4K byte space and flash to a new 4K byte sector on a storage drive. So in the same way, for the third transaction, we put it in another new 4K byte space and to flash it to another new 4K byte sector on the storage drive. So by underutilizing the logical storage space of the write ahead log, we eliminate the write amplification. And meanwhile, we still maintain the physical storage cost savings through the built-in transparent compression. So this clearly can help to improve the overall storage system I/O performance and meanwhile increase the NAND flash memory lifetime. Yeah, again, it's a very simple idea. So for the first purpose of illustration, this figure shows the physical write data volume normalized with the current practice. That here we assume that right after each transaction is committed to the write ahead log buffer, we immediately commit and flash to the storage drive. Here, the horizontal axis is the size of each transaction, ranging from 128 bytes per transaction to 2 kilobyte per transaction. So the results here show that the smaller each transaction is, the more we can reduce the physical write volume. For example, with 128 bytes per transaction, such a sparse write ahead logging data structure can reduce the write amplification or can reduce the write volume by over 90%. Okay, so another possible minor tweak is to modify the relational database by deploying we call the dual in-memory versus on-storage page format. Again, the basic idea here is very simple. That is, when a page stays in a buffer pool, it keeps the existing conventional raw-based format. But when flashing a page from the memory to a storage, we convert it on the fly to a column-based format and transform each column to improve the data compressibility so that it can be better compressed by the computational storage drive. So raw and the column page format conversion is handled by the background I/O thread in the database, completely transparent to other modules in the database. So for the purpose of demonstration, we incorporated this simple idea into MySQL storage engine, like InnoDB, by only adding 600 lines of code. And our Sysbench-based benchmarking result show that the proposed dual mode page format can further reduce the MySQL storage cost by up to 50%. And the on-the-fly page format conversion only incurs very few percentage of TPS loss. So this simple idea can provide a very nice option for users to take better advantage of the computational storage drive with built-in transparent compression. Okay, so now let's talk about the last case study. So it is about the hash-based key value store. We know that in conventional practice, to implement hash-based key value store, we have to first hash the key space onto an in-memory hash table. Then the hash table further points to the location of all the key value pairs that are tightly packed on the logical storage space, which are further transparently compressed and stored into the NAND flash memory. So such an indirect addressing through the intermediate hash table can maximize the logical storage space utilization. But meanwhile, the memory footprint of the hash table is directly proportional to the number of KV pairs. So this leads to a very high memory cost for larger scale hash-based key value store. So the very high memory cost is arguably the main reason why its real-world deployment of the hash-based key value store really pales in comparison to other key value stores with using other more memory efficient data structure like log structured merge tree. So leveraging the storage hardware with built-in transparent compression, we propose a so-called table-less hash-based key value store as shown here. That is, we directly hash the key space onto the logical storage space without going through a hash table. So by completely eliminating the use of a hash table, we remove the memory cost barrier on implementing the hash-based key value store. So meanwhile, by relieving the CPU from managing and searching the hash table, we can consume much less CPU cycles. So actually, as discussed earlier, that the indirect addressing through the in-memory hash table can guarantee compact placement of key value pairs on the logical storage space. But in contrast, the proposed table-less approach is subject to a significant underutilization of the logical storage space. That is, almost all the pages have a noticeable amount of empty space left unoccupied. But once we fill the unoccupied space with a highly compressible dummy data like all zero, we can still achieve almost the same physical storage cost as the current practice. So in summary, that by intentionally underutilizing the logical storage space, the proposed table-less hash-based key value store can completely eliminate the in-memory hash table without sacrificing the physical storage cost. So for the purpose of demonstration, we have implemented a prototype called the CalXDB and compared it with the RocksDB using the YCSB workload. This figure shows compares the average throughput between RocksDB with three different compression settings and our CalXDB. The result show that the CalXDB consistently achieves higher or much higher operational throughput. For example, in the case of workload YCSBF with 50% of read and 50% of read modified write, CalXDB can achieve 2.5 times higher throughput. And meanwhile, the higher throughput comes hand in hand with lower read latency, as shown in these two figures in terms of average read latency and the 99 percentile tail read latency. And finally, this figure compares the CPU utilization in terms of CPU cycles per PV store operation. the results show that the Catalog DB consistently consumes 2 to 3 times less CPU cycles when we're achieving the much higher performance. Okay, so in conclusion, that today we talk about how database could benefit from the new growing family of computational storage drive and presented several case studies to show the potential. So at ScaleFlux, we really sincerely look forward to working with the community to further explore how we could take full advantage of such a new storage hardware. So this ends our talk. Yeah, thank you very much.
Great, thank you so much, Tong and JV. That was great. Now we are at the top of the hour, so we would need to continue with the next presentation. Thank you very much.
Thank you.
Well, I'm pleased to introduce our next speakers, Werner Keil and Theodoris Bies, both are located in Germany. Werner is a cloud architect, Eclipse RCP and microservice expert for a large bank, helping global 500 enterprises across industries and leading IT vendors. Theodoris Bies works as a Scrum Master for ABN AMRO Bank and contributes to the prosperity of the IT community in several ways. He is founder and leader of Utrecht Java User Group, which counts around 2,500 members and has hosted exceptional speakers, among others, James Gosling and Uncle Bob. They are going to talk about NoSQL application development. I'm going to hand over to Werner and Theodoris now. If you're ready, it's all yours.
Absolutely, Camila. Thanks a lot for the very nice introduction. Just a small remark. Unfortunately, we are not co-located with Werner. I am located in the Netherlands, and Werner is located indeed in Germany.
We actually plan to host the Women's Football World Championship in a couple of years. Germany, Belgium, and the Netherlands together, but so far they are only united by the EU.
Exactly. So I hope by now you can see our screen. And with that, let's kick it off. It is already 9:01 here in Netherlands, 3 in other time zones. So welcome all. Thanks a lot for being here today with us. Just a short introduction. We're gonna compare Java persistence frameworks for NoSQL databases. Our agenda is quite tight for today, so let's quickly meet each other. Werner, who are you?
I'm the Jakarta EE committee representative in Eclipse Foundation in Jakarta EE, and I'm an active participant in several other open source projects, for example, in the Java community process, leading several Java specs.
That's good. Also a short intro about myself. My name is Theodoris Bies, or Theodoris Bies in English, originally made in Greece, living and working in the Netherlands for the last 5 years. I work as a Scrum Master for the ABN AMRO Bank. I'm also running the Utrecht Java User Group here in Utrecht. And of course, in my free time, I help people find their own motivation in career and life. Something before we start diving into the presentation, we always appreciate feedback on our presentation. So feel free to reach out to us via Twitter. And also during the session, we really encourage you to shoot any of your questions using the chat in this session, in this Zoom session. So one more marketing slide, because I have already mentioned that I'm working for the ABN AMRO Bank. So basically, we are hiring. So we are currently moving towards a sustainable and a future-proof bank. So feel free to have a look at our current and open, of course, vacancies, and reach out to me if you're interested, because also in my own in my department we are hiring. Enough about it.
let's quickly move forward. We are in 2020, right? And let's be honest, we had a tough year so far. But there are also a few trends for 2020. So first of all, nowadays, more customers are going online. Another trend is also that the internet is connecting everything nowadays. A third trend is, of course, that big data is getting bigger and bigger. One more trend, apps are moving to the cloud. And the fifth one, of course, the world has gone mobile. What does this mean actually? It means that new digital trends create new technical challenges. And what are those challenges? First of all, we need to develop with agility, right? Second of all, we need to operate at any scale. And last but not least, we need to also deliver the performance and availability required to meet the demands of digital economy businesses. Now, I'm quite curious, what are the advantages of NoSQL at this moment? First of all, NoSQL can handle large volumes of data at high speed with a scale-out architecture. It helps us store unstructured, semi-structured, or structured data. It enables easy update to schemas and fields. It is, of course, developer-friendly, and it takes full advantage of the cloud to deliver zero downtime. Why this talk, though? I'm quite curious at this moment. So do you, I'm pretty sure about it. First of all, as we all know, the JVM can cope with heavy loads nowadays. However, there are tons of persistence frameworks out there, and especially Java specific, of course. So here comes the question, which one performs best for your case? It would normally take ages to compare all of those, so we did it for you. And this is what we're gonna see today. Just a quick overview of what NoSQL databases stand for. Of course, we are talking about database that doesn't use structure nor any transaction, and it is also based on the base concept. Werner will tell you more about it later on. Also, about the very last point, Werner will tell you more about the 4 different types of NoSQL databases. Speaking of Werner and of the topics we still need to cover, Werner, over to you to start unveiling this entire schedule for today.
So the key value store is the first type of database. Actually, you just saw another example by the previous speaker. Other popular examples would be Amazon NoSQL databases like Dynamo or S3, Redis or Hazelcast. Then there are column-oriented systems, Cassandra probably being the most well-known example, DynamoDB or Apache HBase. They're probably closest to traditional relational databases, which is why sometimes you also find solutions by vendors that are bigger in the traditional SQL databases. Then there are document-based systems using document formats like JSON, or in some cases, you may also see other formats, including XML, but JSON has become the predominant format. Apache CouchDB, Couchbase, and of course MongoDB, which is pretty much the leading document-based solution. Then there are graph databases like Neo4j, Hypergraph, and others. They have certain specialties that are along the lines of graph-based solutions that you also see, for example, the graph query language introduced by Facebook. And then last but not least, we have the shapeshifters, if you want, multi-model that support more than one concept, sometimes even in the same database. So let's compare them. Here we have the main acronyms in the traditional SQL world, like a table, row, column, and a relationship. In key value, there's a bucket and a key value pair. In column, there's also a column, which is similar to the traditional SQL standard. With documents, there are collections, documents, also key value pair. And in graph, you usually have either a node, a vertex, and edges. There are two major concepts, one called base, basically available, soft state, and eventually consistent, as well as acid, stands for atomicity, consistency, isolation, and durability. Then there's the so-called CAP theorem for consistency, availability, and partition tolerance. And here you see some examples for traditional SQL databases as well as NoSQL databases where they are located in this graph. Furthermore, there's scalability versus complexity. And you see the four major types of NoSQL databases, which one is more scalable and which one is more complex. In the traditional relational application, you usually have a logical tier, a data access object, and then layers below, including JPA or JDBC on the JVM. For a NoSQL application, the general structures are similar, but in most cases, you don't have something like JDBC or JPA as of now. That's why you often need specific APIs that are specific to either Neo4j, MongoDB, and all the other systems. So in an extreme case, you may end up having to support 5 or more different APIs in your application just because you want to support multiple different vendors. So we are comparing Spring Data, Jakarta NoSQL, that's where the Diana Duke stands for, Micronaut, as well as Micronaut Data, although we'll come to how far it supports NoSQL at the moment, and Hibernate, especially Hibernate OGM. And for the sake of time, we are only going to cover Neo4j and MongoDB here in our real-life examples, but all of these support at least these 4 major players, and many of them also support quite a lot more. So what are the problems applying JPA and traditional relational persistency frameworks to NoSQL databases? You have async, storage and callback, time to live. You have a consistency level, and in many cases, it's based on the SQL language, whereas on the NoSQL side, you have a large diversity with sometimes not always fully compatible concepts. For example, you would have a graph with edges, and on the other hand, you would have a document and properties. Most of the solutions that we are going to show and that we took a look at support the concept of annotated entities. It may not always be called entity, especially several solutions differentiate even to the extent that they are not fully compatible. So you may have a Mongo entity versus a Neo4j entity. Some of them try to find a common denominator, for example, use something like document entity as opposed to graph entity. And if you simply call it entity, especially the ones that are compatible with JPA. And then you have a concept of column or property, and a few other annotations that are sometimes specific to a particular system. Then there's the template pattern and the templating mechanism that's applied to almost all of them, especially the major players like Spring Data or Jakarta NoSQL. As well as the repository pattern. Here again, we have the example of the Mongo repository as it's defined by Spring Data. Now looking at Jakarta NoSQL, there the dependency injection uses CDI. That's why you usually see the add inject, where in the Spring world, they're compatible. So you can usually also use inject, but Spring historically prefers its own auto injection, but you can use both of them. In Jakarta NoSQL, since it's based on the Jakarta EE spec and CDI, you would usually use add inject. And annotations like add database for the database definition. And then you define, for example, a repository in this case. You can use queries to be more flexible. For example, a query like select star from person. Then there's great diversity supporting additional annotations that are specific to a particular system. So here, for example, we have the common ones like entity or column, and then we have very specific ones that are special to Cassandra and only defined in the Cassandra driver and Cassandra layer like UDT or CQL, allowing you to do certain things that are specific to, for example, Cassandra, or maybe in Neo4j, you may have similar special annotations that allow you to perform graph query language annotations that only make sense for a graph database. We also support query by text. It's closest to, for example, something like a sort procedure or plain SQL queries in traditional SQL systems. Now let's look at the next player in our end game, Micronaut, which has been around for not that long actually, but it got a lot of momentum recently. Most of its creators come originally from the Groovy and Grails world. There's a Micronaut data module similar to Spring Data, but with a little caveat. At the moment, the NoSQL support is not done directly in Micronaut data, so they are working on that. But there's lower level support for the specific APIs for all the major solutions, including MongoDB, Neo4j, Cassandra, and a couple of others. So this is why the repository currently in Micronaut does not require any annotations. And usually there are also no base types to inherit from, unlike most of the other systems that we're going to look at. Same for the entity. It's just a plain POJO object in this case. And you can have query by text here, for example, graph query specific to Neo4j. Now let's look at a little bit of code. For the sake of time, we're going to show some systems supported by a particular framework. First of all, Jakarta NoSQL, supporting the repository pattern. So here you would have a God repository. And if you do the same with the template, you will notice that they are not so different. Actually, the only difference here right now would be that you replace the word template with repository or vice versa. Most of the other operations are very similar. Now again, here we have the next example. The Jakarta examples all run on Java SE. So you could create a fat jar or run it in the console or even a standalone application. And here's another example of using Neo4j with the actual graph relationship. So here you would have the access to the so-called vertex in Neo4j. Jakarta NoSQL for some systems, especially Neo4j and other graph-based solutions using the Apache Tinkerpop project, it allows to run those in memory. So you can actually run some of them, including Neo4j, without actually having to install Neo4j. For others, you will usually need the database. But you can also run it in the standalone mode. So this one's running against an actual Neo4j system, backing it. And here you get the last one.
Werner, maybe for the sake of time, we should start proceeding to some Spring Data examples as well.
Just 1 second for Micronaut. That one was actually started already. So here you see the Neo4j graph definitions. And let's run this against Micronaut. So we count the cities and let's just run one more query. That's basically to get a particular city that you just saw in the graph. So over to you.
Yeah, if you can stop sharing so I can take over, that would be great.
Oh, it's just, here we go.
Yeah.
So you should have it now.
Sure. Yeah, looks good. Let me just go directly back to the presentation, actually. So Werner has already showed you a few things, and let's see what we can cover in the next 7 minutes. More or less, he covered already all the flavors of repositories and templating and different patterns that are used among the different frameworks. So the logistics and domain for Spring Data and MongoDB is quite straightforward. You just add the Spring Boot starter data MongoDB, and yes, we went directly for the Spring Boot dependency because Spring Boot is quite widely used nowadays from most clients. Of course, we still need to add some dependencies, some application properties. In this example, and as Werner showed you earlier, we're using a mythology database just for the purpose, just for the sake.
Just me, or are we not seeing your slide?
Oh, is it? You're not seeing the slides?
No, at least I'm not seeing it.
Oh, maybe.
Not at the moment. Can you try share again?
Yes, I'm gonna share again. Okay. So
now I see your ID.
Okay, I'll go directly to the IDE because I've already spent quite some time. So application properties I was mentioning, right? So we're using a mythology database, just a very sample database with 2 properties, port and mythology, and everything comes out of the box with just a couple of annotations for your data, for your Spring Data MongoDB connection. So here comes all the magic, your document annotation for your model. So that way, we're actually telling to our MongoDB connector that we're gonna connect to a GODS database. In the repository, as Werner showed you, nothing that crazy, right? So we're just extending a Mongo repository to use as an interface, of course. And in the controller, no magic at all. Our typical REST controller, right? So just a REST controller and some request mappings. No magic at all here. No extra annotations specific to MongoDB. I have already started the Spring Boot server, and just for the sake of saving some time, these are some sample data. So with that, I will also pull my Postman just to show you how things are going here. I hope the database is still running, yes. And this is how it goes. As you can see, the requests are going. Now we're requesting for a specific God by name. And of course, if we want, let's say, to delete a specific God by ID, I have already created this request here just for the sake of time. Let's see how that goes. I should get 1 record less, which is the case, right? So solid do has been removed. So not enough time, we will post everything later on via Twitter. You will see the links to our GitHub repository to see more about the example. And with that, let me just move to just quickly to also show you a bit about the MongoDB database. So basically, Neo4j DB comes together with a movies database pre-set up for you. So once you start your Neo4j instance, you will see a movies database set up for you. So I have set up everything here. For the sake of time, I will show you the movie entity. Just a node, everything works in nodes in Neo4j. Same goes for person entity, different node, and of course the movie repository, which needs to extend from reactive Neo4j repository. This is of course a framework specific or a dependency specific or database specific, of course. So, and some roles here. So one more annotation you need to keep in mind, the relationship properties annotation. You can find more about it in the example. I'm not gonna show you more from the code at this moment, because looking at the time, we're really running out of time. So back to the presentation, and while it's loading, Werner, is it visible now?
Yes.
Great. So, and while it is loading, as I was saying, I know due to time, maybe we have not been able to show that much. Please stay tuned on our Twitter accounts. We will post everything online. You will also find a link to our GitHub repository at the end of these slides. What about Hibernate OGM? What happened to this one though? We also gave it a try, right? So far we talked about Micronaut, we talked about NoSQL, of course, and about Spring Data for MongoDB and for Neo4j. What about Hibernate OGM for MongoDB? You will see the old-fashioned style of persisting data with transaction managers and all this kind of stuff. I personally got allergies. And of course, over to our conclusions. So about the NoSQL, it is still in progress, of course. However, it does remove much of the boilerplate you're already familiar with or not, and provides a cleaner and more readable DAO. It supports a huge number of NoSQL database systems, and of course, it is loosely coupled. It has a loosely coupled code, which makes switching between different NoSQL vendors just a matter of configuration. What about our conclusions for Micronaut? Also still in progress, switching between different NoSQL vendors, not so easy. In addition, Micronaut data does not support NoSQL databases yet. However, it is often faster with a lower footprint. Polyglot, it does support polyglot language for Java, Kotlin, and Groovy. Now, over to Spring Boot and Spring Data, right? Spring Data actually removes a lot of boilerplate code. It provides a cleaner and more readable Java implementation. It does have a loosely coupled code, which makes switching between different NoSQL vendors just a matter of configuration. However, only half a dozen wider used NoSQL databases, and only half a dozen wider used for NoSQL databases, and of course, some others require more effort or will not work yet. As I mentioned about Hibernate OGM, it does have outdated documentation. And of course, using a mapper for all scenarios is not a recommended approach. However, some JPA concepts are not easily mapped to the SQL world. And of course, it is not error-safe way. It does not provide an error-safe way to run the query language and hydrate DTOs from the results the simple possible way.
In fact, it hasn't even released a major release for the last 2 years. So it's not only the documentation that it seems outdated.
Exactly. So it's not only about the documentation, even the support from the community is not there for the last 2 years, as Werner correctly pointed out. So here are the links to the JNoSQL project, but also to our GitHub repository, where you will find all the code examples we just showed, or that we were not able to show due to limited amount of time. For now, some credits to flatiron.com for being able to use some icons for free, and of course to Michael Simmons for helping us out with these solutions. Thanks a lot for your time, and of course feel free to follow both of us on Twitter. We are quite active to also answer any kind of questions. Camila, sorry if we exceeded your time.
It's okay. Great. Yes, we are already at the bottom of the hour, so thank you very much for your presentation, Werner and Theodoris. See you next time.
See you. Bye.
See you. Bye-bye.
Okay, great. Well, for the next sessions, I am going to pass my hosting duties off to Matthew Bohem. Matthew, feel free to take it away.
Hey there, Percona Live. How's it going today? Can you hear me good, Camilla?
Yep.
Yeah, all right. So it's a fantastic day here. I'm in Houston, Texas, so I'm going to be your host for the next hour. First up, we've got Kevin Jernigan from Amazon, and he's going to talk to us about deploying your application database essentially globally. How do you scale how do you, when you create your database in the cloud, you want to do it multi-region so that you've got that fault tolerance. What all do you need to think about when you're doing that kind of deployment? So I'm going to let Kevin take it away, and he is going to explain to us all that we need to think about when doing such a monumentous and complex task.
Great, thank you, Matthew. I want to make sure you guys can see my screen.
I can see it, looks good. And I can see you as well.
You can see it and you can see me. I'm just checking to make sure because I can't see me.
Yeah, you look good.
Okay, yeah. Okay, I see. Great. Well, thanks for the intro. Yeah, my name's Kevin Jernigan. I'm a principal database solutions architect on the Aurora Postgres team at AWS, and I've been with AWS for about 5 years, working on Aurora Postgres. And just want to thank everybody for taking your time, the time today for this session. I know you have a lot of things competing for your attention. Hope you found it worthwhile. There is, of course, live Q&A or live chat and Q&A going on both in the YouTube and in the Slack channel for this session. So please contribute. Love to have some questions to answer at the end if we have time. So I'm going to talk about global databases and really specifically about global relational databases. And at Amazon, we always start with a customer, and that's where I'll start. Why do customers want their databases to be global? What problems are they telling us they're trying to solve? And along with customer requirements, of course, I'll dive into several ways to make a database global and review the trade-offs for each approach. And then I'll talk a little bit about how we solve these problems with Amazon Aurora. So as I mentioned, I've been with AWS for almost 5 years, and I've been working with relational databases for more than 30 years. I started my career way back in the late 1980s with Oracle, but then I was an independent consultant through the 90s, an entrepreneur in the 2000s, came back to Oracle for a while, and then joined AWS in 2016. So in my career working with customers, I've learned a few things about what they want from their databases. They want durability and reliability, they want performance and scalability, and they don't want to lose their data. Now, to ensure they don't lose data, we've invented lots of technologies over the years: disk mirroring and stripe and mirror everywhere, CRC block checks, replication, both logical and physical, log streaming, and others. And all of those technologies were invented before the cloud came along. And with the advent of the cloud, customers have started to focus on ensuring their workloads are resilient, not just within a single data center or across data centers that are close together, but also across multiple regions, while also leveraging the globally distributed infrastructure available in the cloud. So in AWS, we organize our data centers into what we call availability zones, and we organize multiple availability zones into regions. And each availability zone consists of one or more data centers, and each availability zone is designed to run on separate power, separate networking, different floodplains, et cetera, so that any single event is unlikely to impact more than one availability zone at a time. Now, at the same time, availability zones within a region are close enough together to support synchronous actions between the availability zones with latencies in the range of a small number of milliseconds. At the same time, in addition to that, each AWS region is geographically separate from other regions with latencies ranging from tens to a few hundreds of milliseconds, depending on the distance between the regions. So with that background info on how we organize our infrastructure, let's look at how our customers are asking us to support global deployments of their managed relational databases. Our customers want to maintain multiple copies of their databases in regions separate from the primary region to provide disaster recovery support, or in other words, protection against loss of access to the primary region. And in this picture, you can see the primary database on the West Coast of North America with read-only secondary copies of the database in other parts of the world. So this is a topology customers are asking us to support. But this brings up a second global database feature which our customers are asking for, and that's the ability to use the secondary databases for reads. So early implementations of technologies for global databases couldn't make the remote copies accessible. Now, as you'll see, you can use more modern approaches to create topologies like this in which each copy is available for reads, for queries, and for reports. And this can greatly reduce read latency for users who are closer to one of those secondary databases than they are to the primary read-write database. So great. So customers are asking us to make their managed relational databases resilient against regional outages and to make read-only copies of their data available across the globe to reduce latencies for their end users. So what are our options for actually doing that? Well, there's really two primary options for supporting global database deployments: logical replication and physical replication. And so to support the requirements that we just discussed, you need to have copies of the data in each region. And you need to keep those copies consistently updated with changes that are being made to the data in the primary region. Now, with both options, replication is used to copy data from the primary database to the secondary databases to keep those secondaries copies close to in sync with the primary. Now, remember we talked about latencies between regions. That latency prevents us from doing synchronous replication from the primary to the secondaries. Otherwise, the transaction latencies on the primary would be too slow. That means the secondary copies will always lag behind the primary. Changes committed on the primary might not be visible in the secondary copies for tens or hundreds of milliseconds, or sometimes even multiple seconds, depending on the implementation and the distances between the regions. But let's dive into logical replication first and talk about customer use cases that can be solved with logical replication, and also talk about the challenges of using logical replication. So I've worked with a lot of enterprise customers in almost every industry, and the common requirements consistently appear. Customers in telco, in e-commerce, and in financial services have implemented database solutions that support a wide range of multi-data center or multi-region requirements. And these requirements include easy migration from one region to another, easy upgrade paths for database patches and new versions with minimal and zero downtime. Customers also want to maintain multiple copies of their data across regions, as we already discussed, for disaster recovery and for redistribution. Sometimes customers only need a subset of data to be available in multiple regions, and with local reference data maintained separately in each region. And to avoid overwhelming networks and replication infrastructure, customers sometimes want to turn off replication per session or sometimes per statement if they want to, for example, update all the rows in a billion row table. And sometimes customers want to delay replication of DDL or schema changes to manage slow or staged rollouts of application upgrades across regions. And sometimes customers even want to implement active-active capabilities in which transactions can be processed from multiple regions and not just from one primary database in one region. So customers who have this combination of use cases and requirements will often choose logical replication. And so how does logical replication actually work? Well, relational databases are designed to keep data in memory as much as possible for performance reasons, while not compromising users' expectations about durability and survivability of the data in storage. So the typical relational database architecture will start with an SQL query optimizer at the top, with a transaction layer managing concurrency and database transactions, a caching layer to manage data in memory, and an I/O layer to move data from storage to memory and back. And down in storage, data is usually stored in database files and log files, where the log files contain a sequential stream of log records that represent changes to the database over time. With logical replication, changes to the database are replayed in the secondary copy of the database, either by mining the log files and transforming the log records into SQL statements to be executed on the secondary, or by using triggers on the database objects in the primary to create SQL statements that are then executed on the secondary. Now, it's easy to see how to meet some of the customer requirements we just reviewed by filtering which database objects for which you replicate changes, for example, or by managing schema changes separately from changes to data. However, there are some challenges and limitations with logical replication. It can be complex to set up and manage. You have to decide which tables to replicate. You have to ensure there are primary keys on all those tables. And because logical replication requires each transaction to be replayed on the secondary database, you have to have a database instance running on each secondary database. Replaying each transaction adds to the replication lag, which with logical replication will typically be measured in tens of seconds or even multiple minutes. In addition, ensuring transactional consistency can be challenging while supporting parallel application of changes to the secondary databases, further limiting performance and increasing replica lag for high change rate workloads on the primary. And then multi-directional replication, or bidirectional replication, or BDR, as some people like to call it, is tempting. Why not use logical replication to support active-active implementations? Well, it quickly gets even more complicated. For one, you have to decide how to manage conflicts when the same data is modified at the same time on two different databases. For example, if a user updates a row in one database and a user in another database deletes that same row at about the same time, and then those two changes are replicated across to the other side, how should the system resolve the conflict? The usual answer is last write wins, i.e. the change with the latest timestamp overwrites the conflicting change. But regardless of the conflict resolution algorithm you choose for each table, and they can be different for each table, application developers and end users need to be aware of the behavior so they aren't surprised by a deleted row suddenly reappearing, for example. Another challenge with BDR is monitoring and management. If the replication stops working or gets delayed by networking issues, etc., then tables can get out of sync. You need to have monitoring in place to detect this and to have tools and procedures and playbooks and all that to get those tables back into sync when they drift apart. And last but not least, what about DDL? If your implementation is supporting high change rate workloads on multiple active copies of the database, and you want to, say, add a column to a table or resize an existing column, can you do that reliably and safely across all copies of the database without disrupting the running workloads? There's challenges there that you'll run into with logical replication. But to be clear, I'm not trying to talk you out of using it. I've seen many successful implementations of logical replication to support distributed databases and active-active architectures. If you do your homework and do the appropriate long-term planning to ensure you have the skills and infrastructure in place, you can get it working and you can get it working at scale. But let's change gears and talk about use cases that lead to physical replication and the benefits and challenges of using physical replication. So we just now discussed logical, in which changes from the source database are used to execute the same changes on the target database, usually as SQL statements, logically recreating the transactions in the target database. But with physical replication, changes are replicated using the underlying storage system. Physical replication is usually implemented in the storage system, often blind to the database system accessing the storage. Physical replication can also be implemented with varying levels of integration with the database system to deliver better performance and consistency. So customers who have stringent disaster recovery requirements and need to minimize data loss and minimize failover time will often choose physical replication. In my experience, this usually includes customers in financial services and telco for their tier 0 workloads, where those workloads have stringent RPO and RTO requirements. And who depend upon the efficiency, especially of database-aware physical replication, to minimize their data loss and failover times. Another type of customer that typically uses physical replication are gaming customers, and they'll use it more for geo-distributing their read traffic, which helps with response time for users accessing games, where those users are often distributed around the globe, and is simply just easier to implement and maintain physical replication as compared with logical for their use cases. So, as I mentioned, physical replication can be used to protect against losing the database when the region goes down. The simplest form is to periodically copy database backups and log files from the primary region to the secondary. This has the advantage of being relatively simple and easy to implement, but doesn't provide good RPO. Minimizing data loss and a failover will be limited by how often you can copy your backups. Now, you could tweak this approach and copy log files in addition to database backups, which would allow you to keep the RPO lower. In a failover, you could restore to the point in time in the most recent log file, but recovery time will likely be increased. You'll have to restore the last backup, then roll forward through all the log files copied since then before you can bring the database out. A more integrated approach is to use storage-based replication to copy changes as they are made to the database in storage. If this is implemented without database integration purely in the storage layer, then the target databases are typically not accessible. They're only made available when the primary database goes down or when the replication is manually stopped and the secondary database is started. With this approach, changes are replicated by the storage system itself, usually at the block level, preventing access to the database because the replication isn't transactionally consistent. Data loss with this approach is typically smaller as incremental changes are replicated relatively quickly, and recovery time on a failover is really limited only by how long it takes to start up the database on top of the replicated storage. There might still be a small amount of database recovery needed. So with database-aware physical replication, the secondary databases can be made accessible for read traffic while maintaining consistency guarantees despite the replica lag. In other words, all reads on the secondary databases will be consistent as of the consistency point in time of the replica, but the data seen by those queries will lag behind commits on the primary. This is often implemented using some form of incremental replication or log replication to make the replication more efficient and to allow the secondary database to present a read-consistent view of the data. So physical replication is usually all or nothing, unlike logical. Replication of subsets of the data isn't typically supported with any physical replication implementation. Blind storage-based replication can be inefficient for workloads that only change a few bytes per page, because they typically will replicate the entire block every time. But having said that, storage-based replication is still usually more efficient than logical, with replica lags often below a second, even for regions that are cross-continent. It's also usually not feasible to support active-active with physical replication. So let's talk briefly about how we think about these types of customer requirements in Amazon Aurora. But first, what is Aurora? Well, this is our high-level, descriptive or marketing slide. I mean, Aurora is an enterprise database where we took open source projects, both MySQL and Postgres, and integrated them with our own cloud-optimized storage system. It delivers at a high level both better performance and better durability and availability out of the box, but still with simple managed database capabilities and simple pay-as-you-go pricing. But let's go dive real deep into how it actually works. We built Aurora to address a fundamental bottleneck with databases, the connection from the database engine to the storage. And with Aurora, we've divided the traditional database stack into two tiers. A database tier that's really just the traditional database engine, and a storage tier which looks very different than typical database storage systems. Database tier in Aurora writes redo log records or write ahead log records, WAL records in Postgres terminology on the network using a 4 out of 6 quorum protocol to storage nodes in the storage tier. Apart from these log records, which really you can think of as change vectors or deltas for changes to the database, nothing else is written. There are no full data blocks written whatsoever, not for checkpoints, not for cache eviction, not for background writes. Instead, the log application, which has been managed in the database engine for 40 years, has been moved to the Aurora storage system. The Aurora storage system itself is a highly parallel scale-out service in which we parallelize and scale out that log application process. Typical Aurora storage volume will contain hundreds or thousands of EC2 i3 instances, each with many CPUs, lots of main memory, lots of local SSDs. That same log apply processing, which used to live in the database tier, is now distributed and scaled out in the storage service. Among other things, this allows the storage service to generate database blocks on demand, and also in the background to continually materialize those database blocks. So in this architecture, if a database node needs a block that's not in its buffer cache, it goes to the storage tier and fetches the block from there, where the storage tier can generate it on demand if it's not already materialized the block in advance. From the database perspective, the log is really the database. How and where the blocks are materialized is no longer directly relevant. Because of this architecture, we're only writing individual diffs or deltas. And so we end up writing almost an order of magnitude less data on the network. And that's the fundamental innovation that leads to the performance benefits of Aurora. At the same time, even though we're writing less data, we're writing it to 6 different locations across 3 availability zones, which gives Aurora additional high availability and durability. Now, with that in mind, let's talk about logical and physical replication capabilities in Aurora. So Aurora supports logical for both engines, the MySQL compatible and Postgres compatible versions. For Aurora MySQL, we support bin log replication. And for Aurora Postgres, we support both replication slots and PG Logical is something we launched support for, I think, a couple months ago. So you can use these logical replication capabilities to meet some of the customer requirements that we discussed earlier, including replicating subsets of data, managing DDL replication separately from data, and bidirectional replication with conflict management, and at least in some cases. For physical replication in Aurora, we've implemented the Aurora Global Database feature. Aurora Global Database enables faster disaster recovery and more enhanced data locality than is possible with logical, replicating and distributing data across multiple AWS regions and supporting remote readers that can be promoted quickly for fast DR. Aurora Global Database also brings data close to your customers so they can operate with low latency, enabling you to distribute your entire application infrastructure while supporting reads in many different regions. Let's talk about how it works under the covers. To set the stage, we already talked about how in Aurora, writers are sending log records or deltas to storage. An Aurora cluster, even in a single region, can have up to 15 read replica instances. These readers consume the same log stream that is sent to the storage nodes in order to keep their local buffer caches consistent and close to the actual writer. And in practice, we see in-region replica lag of typically no more than 20 milliseconds. Now for Aurora Global Database, in the storage layer, we have added an additional agent for outbound replication in the primary or source region. And in the secondary or target region, there's a corresponding inbound replication agent. These sets of agents, which are individual microservices in architecture, are continuously communicating, where the outbound agent receives the same log stream that all the readers inside that primary region are receiving, and it sends that log stream across regions to the inbound agent in the secondary region. This entire process has been engineered by us to operate in our WAN environments across continent, across the ocean, around the world, while still maintaining high throughput. And that's the key. We're able to hit 200,000 writes per second with negligible performance impact while still maintaining low RPO across continent, typically well under a second. Our goal with Aurora was always to provide high throughput and high performance without sacrificing availability and durability. And what we're doing with Aurora Global Database is keeping that same goal while increasing availability and resilience beyond a given region to a global infrastructure. So how does Aurora Global Database provide fast cross-region disaster recovery? The idea here is to have a distributed deployment across a global footprint where you have very fast recovery, less than 1 minute RTO, to accept full read and write workloads in the event that you have unavailability of your primary region. What's really important to understand is how things work when there are failures. And so let's start very briefly with failover within a single region. You have an application with writers and readers. The writing part of the app is pointing normally to the writer or cluster endpoint, and the reads are balanced across multiple readers. This is a common configuration in Aurora. Many customers use Aurora with this pattern. When you have a failover due to a transient issue, a network issue, for whatever reason, the system will automatically choose to promote one of the readers to be a writer. And what actually happens is there's a DNS change for the cluster endpoint. The writer endpoint ends up pointed to the newly promoted writer, and the old writer, which is now demoted to being a reader, joins the reader endpoint. From the application perspective, there's almost no impact. There's a small blip, and with the magic of DNS, everything proceeds as normal. When you think about a global database, we have a different architecture. You now have to worry about multiple application stacks. Customers typically operate in one of two modes: a pilot-like mode, in which they maintain a minimum set of resources in another region that's ready to come to life in the event of needing DR. And the other is data locality, in which the customer maintains a copy of their data in a second region that's close to some of their end users or customers, and they have a fully operational application stack in that secondary region. This slide shows the second model we just described, with a secondary region providing low latency read access for users closest to region 2. It's important to note that the database is operating in 2 regions in this example, and the app stack also exists in both regions. Here, when you have a catastrophic event, we're going to show what needs to happen in the application in order to leverage the global database infrastructure. So let's walk through what happens when you have a failure in region 1. The application stack can be spun up in the event of a regional failover if running in pilot-like mode, or if the application stack is already available because it's in use for reads. Once one of the readers in the secondary region has been promoted to be the writer, then at the application level, something must be done to promote the application components to start taking writes and to start sending writes to the newly promoted writer. Once that's done, the clients that are connecting to the application through DNS redirection can start pointing to the new stack that is running in the new region. So that's how we get low RTO, or recovery time objectives. Low RTO is great, but that's not our only goal. We of course want to have global reads with very low replication latencies. And our goal is to have low remote read replica lag of less than 1 second for cross-continent, cross-country deployment scenarios, even under heavy load, which will allow customers to achieve very low RPO, or recovery point objectives, with the read replicas in the secondary regions lagging at most a few seconds behind. And with the way we've implemented global database, sending just the log records across to be applied in the storage systems in the remote regions, we're able to deliver on that goal for most workloads. Now, low RPO is important because, even if you're able to quickly resume transactions with low RTO, if your data is minutes or hours or days out of sync, it doesn't really help to be back up and running quickly. So, the combination of low RTO and RPO, we think, is what's critical for customers. All right, so we're just about out of time. I want to thank you for your attention. Happy to take a question or two if we have time, but Matthew, I'll let you make that call.
Yeah, we do actually have a couple minutes here before we get started on the next one. I don't see any questions in the Slack chat, and I have not been monitoring the YouTube because I was told that we were just going to be using the Slack chat. So I don't see any questions there, but I do have a couple for you anyway that I came up with. The first one was you had mentioned that physical replication can't handle subsets of data. Could you maybe elaborate a little bit on that?
Yeah, so there's a couple things there. The kind of the blind storage-based physical replication doesn't really understand what it's replicating. So it just sees changes to blocks and files in storage and replicates the changes. So kind of the original old style way of doing replication storage-based, there was no chance of it understanding anything about what it was replicating. But even the more database aware approach, like we're doing in Aurora Global Database, it's challenging to do the right kinds of filtering without having a real major performance impact. And so, well, I won't say it's impossible. It's not been a high demand feature for what our customers are asking us for. They've been asking us, like I said, like I've described, to deliver low RTO, low RPO to meet their DR requirements and their geo-distributed read requirements. But so far we haven't seen a high demand for that kind of filtering for global database requirements, at least not for physical replication.
Okay. With this global architecture, you basically have full copies of your data set basically all over the world. How does that compare to somebody who's trying to do like a sharded solution instead?
Yeah, so yeah, we all know there's a bunch of different solutions out there that do various ways of sharding and subsets of data. And I didn't want to, include that in this presentation because then it would take too long. But basically, yeah, the way I look at sharding is, yeah, you can decide to shard tables and put different subsets of your tables in different databases. Some of those databases can be in the same region, some can be in other regions. You still have to think through replication ideas, replication options, because if the shard only exists in one region and you lose the region, you've lost all that data. So you still need to think about replicating the shards around. And there's other complexities with sharding. They're not bad or good, they're just complexities. Every solution has its complexities. What about cross-shard transactions? How do you make sure those scale well or at least don't impact performance? What about resharding? If I have a terabyte of data sharded across 5 regions and now I got to reshard it in a different way, that can take a while. These are all interesting and solvable problems, but they are things to think about when you consider a sharding solution.
Certainly. All right. I think that's good for me. And like I said, I don't see any other questions coming in. So thank you for your time. Thank you for your presentation. That was very, very informative. I learned a little bit about the back inner workings of Aurora, so that was good.
All right, thank you.
All right, thanks, Matt. Have a good day.
You too.
Okay, hopefully everybody is still with us. Let's see who's up next. That would be Marcus. Marcus Strauss is coming to us from Solar Winds and is getting ready to do a topic that I actually talk about in our trainings. If you didn't know, Percona does training. We do MySQL training and lots of other topics as well. And one of the topics that I discuss inside my training is application profiling. So I feel that Marcus is going to take us on a whirlwind tour about how, yes, your database exists and monitoring your database is important, but what if you've got problems in your application? How do you find or determine that the problem exists inside your application and not necessarily the problem exists within the database? So let's see if Marcus has his slides, camera, and microphone up and running. And we'll see if we can't get him coming on.
Slides and microphone, yes. Camera is unfortunately, due to very poor weather conditions here, not going to happen today.
Okay. Go ahead and share those slides for me because I'm still seeing just your name.
Yeah, give me 1 second. Zoom is currently not very cooperative with me. It does not show me my slide deck anymore. And of course, we went through this earlier on in the test, and of course, now it's not working. That's generally the way things like that.
That's generally how it works. You know?
Yeah.
Everybody is a fantastic typer until someone's looking over their shoulder. Then every third character you type on the keyboard is a mess up, and you're hitting delete constantly. Yeah.
Absolutely, yes. And while we're going through that exercise, a little, I suppose, correction on the part of the topic earlier on. It's actually the other way around. So in essence, the part of the conversation I wanted to, and I kind of start off with the introduction here, to go through is the other end of the spectrum, right? So once you know that there is a problem, you generally go through this from an APM perspective, and you go through the application performance monitoring stack, and you figure out that the problem is with the database instead of the app stack directly. But where does that leave you, right? So in essence, some of the things that I wanted to talk about in the next 30 minutes was around what you do then, right? So I just thought I'll bring that up. So with that, I kind of made the introduction already. So let me step into the next slide. So the topics that I want to go over in the next roughly 30 minutes is essentially what sort of challenges do we have in observability today? Some of the troubleshooting and tracing, and it's a topic I think we're all very familiar with, unfortunately. Looking at some things like tuning query performance and how to get there, and how to make the most out of that. What sort of impact on our overall performance in terms of how our services, applications, and the database itself, the infrastructure has. And then kind of like lastly, which is usually the first step in the process, but we're going to get to it last here, is how can we essentially take all of these points and deploy code with greater level of confidence, right? And then we obviously have a Q&A part at the end of this. I'm going to get to the most boring part of the presentation first, and that's the introduction. I think just like everyone else, I don't particularly enjoy talking about myself. But my name is Markus Strauss. I'm one of the product managers at SolarWinds. I'm responsible for the database performance monitoring product, DPM. I've only recently joined SolarWinds, just roughly about 7 months ago. Before that, I've spent quite a number of years at McAfee managing their database security products. And I have had, like so many of us, various stints in other companies over the year. And do feel free to reach out to me on LinkedIn if you want to. And with that, I kind of leave it at that. Like I said, nobody really likes talking about themselves too much. So challenges of observability, and it's a funny one, right? Because we generally try to achieve something without, at least in most cases, having all of the right tools at hand. And that's something that I've painfully experienced myself over the years, and I'm sure everyone else in the audience has too. We generally get to having to achieve some level of observability by means of there is a problem or there is a need for it, right? And very often we do that with not necessarily having the right tools at hand. But one of the things that modern applications have in common is that very often they're pretty difficult to troubleshoot, and that's largely down to several items, right? I mean, we deploy pretty complex distributed architectures these days, and that's good, right? I mean, we want that, we need that. It helps us create better services. It helps us create faster services, better products, better experiences for our end customers. But in the end, it does make it more complex to troubleshoot. In a lot of cases, our workload on the environments that we manage has become quite demanding over the last number of years. And to top it all off, as always, usually we don't have the best instrumentation in place. Again, I'm going to use my experience there. For me personally, in a lot of cases, instrumentation becomes a topic once something went wrong, right? I mean, we all build apps in general to serve a purpose, right? It's to solve a problem, or it's to serve a specific customer need, or to build a product, or to create an internal service, or something along those lines. We generally don't build applications around all of the different instrumentation needs that we possibly ever could have. And by its extension, then usually when things go south, that's when we realize, yeah, we probably should have spent a little bit more time on that. But very often that's just the way it is, or we inherit applications from various areas, right? When things go wrong, there's a lot at stake, right? I mean, again, I'm going to use myself as a guinea pig here, right? But I'm old enough to remember when you went onto, let's say, a website, right, and it was perfectly acceptable for it to take 25 seconds, 30 seconds to load the ever dreaded number of GIFs or GIFs, whatever camp you fall into pronouncing that, loaded, and we were all very happy with that. But those times are gone, right? Our end consumers have pretty high standards when it comes to responsiveness and just plainly the thing to work, right? If I install an app on my phone, or if I use an app on my phone and I open the app up and it just doesn't load, or it errors out, or anything like that, in 9 out of 10 cases, if that app isn't absolutely crucial, it's gone. And I'll find a different one that does the same thing, right? And I think we all have had that experience, both on the consumer side as well as the provider side. So customer experience has become a huge impact, and it impacts our bottom line. Then the inability to really measure workload properly has become a pretty big challenge when it comes to if stuff goes wrong, not being able to know where do I need to throw extra capacity at, or where do I need to spend more money. And especially in a world where it is so easy to spin up more pods or more instances very quickly, the knowledge of understanding where do I need to focus that money is very important, right? It's easy to throw money at the problem, but if I don't throw it at the right area of the problem, then all I'm doing is I'm wasting money. And if I'm not able to really pinpoint and understand where, and excuse me, my voice has been funny all day. If I'm not really understanding where the root cause of the problem is, then, well, we all know how that looks like. Generally, the finger pointing starts, right? We do end up with the, well, that's not our problem, that's their problem. It wasn't our fault, it was their fault, right? So there's quite a lot in terms of challenges that we need to deal with on a daily basis when we start looking at the whole cycle of monitoring the performance of an application, right down from the application stack down to the database layer. And historically, I think it's somewhere around 70% of problems that are performance-based problems within your app stack is traceable back to a problem of sorts within the backend, within the database layer, right? So the two biggest ones out of all of the challenges that we face, and that list was certainly not exhaustive, right? I mean, I'm sure we could all add another 10, 12, 15, 20 challenges that we all face on a day-to-day basis. But the two biggest ones are probably complex architectures and just having poor visibility. And again, complex architecture in itself is not a challenge. Well, it can be, right? But not in our example here. It's something that we want. It's something that we need. It's something that we have to use and build up to provide better services, to provide faster results, to provide a better experience for whatever services that it is that we provide. But we do need to be able to capture workload, not just from the application stack perspective, but also from the database perspective, right? That goes both ways. We need to understand where do we need to focus our energy and our resources in order to understand where the root cause of the problem is. And we also need to be able to correlate all of the individual data points that we collect, whether that's on the app stack or whether that's on the database layer. We need to be able to correlate all of these together into a much bigger much clearer picture that we can use as the baseline of figuring out whatever problem it is that we need to solve, or whether there is room for improvement. So when I think of troubleshooting and tracing, the first thing that comes to mind is that dreaded phone call at 1 o'clock in the morning, where you pick up the phone and someone yells at you that something broke down. And I think that's probably, in a lot of cases, the experience that most of us have when we think of troubleshooting. It's that dreaded email or phone call that something just simply stopped working, right? And where we need to start looking at from a database perspective, and obviously this conversation is very much database centric. I do keep it product neutral because I'm not here to talk about products, but what we do need to start looking at it from a database level is, what's usual, what's unusual, how do we find outliers? When we look at, again, that threaded phone call at 1 o'clock in the morning, and you have a look at the environment, and what do you need to look at over the last hour? Usually that's kind of like the time span you'd look at. But who tells you what's normal and what's not normal? I mean, yes, of course, if you look at the environment every single day, you'll understand what's normal, what's not normal. And that works fine for 1, 2, 5, 10 instances and a couple of small environments. But once you start going over that complexity and over that level, purely just looking at something and understanding where it goes wrong only really works when the lights are out, right? So the box has crashed, or the service is no longer running, or something along those lines, where it's really, really obvious. In a lot of other cases, it is not that obvious, right? And if we take the conversation back to the database layer, then with that in mind, we need to be able to correlate queries itself, the query behavior, against all of the other data points that we collect, whether that's from the system stack, from the infrastructure, or whether that's from the app stack, and really start correlating those queries against what we see in the other metrics that we collect to understand where is something, and to be able to isolate what's potentially unusual behavior. Like we all have stuff in our environment where a query is pretty damn slow, and we know that. It's that one sign up query that just isn't working really well, and we haven't really gotten the time to look at it in much more detail. It works fine, it's not the greatest, and it runs about 500 times a day, so we're okay, it's not that bad. But if I look at it and it suddenly has run 20, 25, 30,000 times in an hour, then I know that something isn't quite right. Now, it might be okay, and we've just gotten really successful overnight, and instead of getting 500 signups a day, we've now gotten 25,000 in an hour. That's all great, but I still need to have the ability to understand that increase is unusual, right? And I also got to be able to really look at the individual query performance in itself, and looking at execution plans and things like that, and really understand, are we doing full table scans? Are we, maybe that query hasn't been constructed very well, and things like that, in order to understand where I need to again focus my attention on, in order to get to a quicker resolution time, in order to essentially ensure that the whatever service that I've gotten that call at 1 o'clock at is back up and running as quickly as I humanly possibly can. Because we all know that the longer a service has an outage, the bigger the potential damage is to, whether that's the bottom line, the brand's image, the overall customer experience, or internally, whether there's other tools that are connected to that service that would require our service to be up. So we know that the sooner we can get to the root cause analysis and the sooner we can fix the problem, the better. Now that kind of brings us into the next area in terms of, well, now we've kind of put the fire out, so to speak, and we may have fixed the imminent doom that the problem and the phone call at 1 o'clock brought us. But now is the time to start looking at where can we potentially look at making our overall environment more performant. And we got to be able to have a pretty quick overview on what's going on, right? And I'm not talking necessarily about, are you 5 versions behind? That's in a lot of cases pretty self-explanatory, might not be the best option. And again, those things are relatively straightforward in a 1 instance, 2 instance, 5 instance environment. Where it gets a little bit challenging is when we start looking at a multitude of instances, different versions installed because of different requirements. Some libraries might not work well with some versions, and we've all been there. We got to have a way to pretty easily figure out what's going on and where do we have room for improvement. For example, very, very easy, straightforward ones. Where are we missing indexes? Things like that. Have we done all of the updates that we need to do? Have we looked at the configurations the way we should? And in some instances, especially with configurations, they can be very subjective. In some environments, we do need to configure instances in a certain way so that everything works and plays nicely together. And we know that, and we can look at that, and that's fine. But nevertheless, it's good to have a way to get a quick overview of, well, are you sure about that? This is what we generally consider best practice. And, well, is your environment different, essentially, right? But again, it shouldn't be reliant on someone's memory. It should be reliant on there is an overview and there's an easy way for us to have a look at these and understand how our environment is set up and how we configure it, what versions we're running, things like that. And equally, just plain and simple understand query syntax performance, right? So, are we doing a lot of full table scans? Are we doing a lot of, where clauses that aren't, running properly? We don't have any way of limiting the results in those, and so on and so forth, right? Again, in a lot of cases, the way we deploy or the way we develop, we make use of built-in libraries that auto-generate our queries, right? And I'm pretty sure I'm not the only one that has done that in the past. It's a fantastic way of making sure you have a unified way of query generation, and everything works well from a developer's perspective. It doesn't necessarily mean those tool sets and libraries generate the most efficient queries on the planet, right? And it's good practice to understand what the impact of those would be, and where there's room for improvement, especially in setups where there may or may not be a dedicated DBA or someone with years and years of experience available to go through these very granularly and understand what the potential performance impact would be, right? And then kind of build on that is the infrastructure input. I mean, again, any sort of changes in the infrastructure are going to ultimately, inevitably have an impact on everything above that stack, right? So if my CPU is pegged at 95% most of the time and I'm running at 100% memory utilization, well, to be fair, if that be the case, then you have bigger problems. But generally speaking, that's not a good thing, right? Usually things don't perform very well at the upper limit of what's possible. So understanding the infrastructure and the impact that it has on how everything performs from the database upwards is very important. And on being able to correlate that stuff against your query performance, and understanding that, well, hang on a second, if I have a query that's probably my indexing is a bit rubbish, and I haven't done a majorly good job in writing that query, and as soon as my memory utilization hits 80%, that thing just gets stuck and it runs, and you run into deadlocks and all sorts of other really, really interesting scenarios. Being able to correlate those things is crucially important. Understanding how the infrastructure and, like I mentioned earlier on, the potential of throwing money at the problem can have an impact on your overall performance, and being able to pinpoint where you need to throw the money at, if there is a need indeed, that can save a lot of money. And obviously it can help with reducing time to resolution, and just overall make sure that capacities are managed a little bit better and with more insight. And then kind of lastly, I'm going into, like I said earlier on, it generally is the first step in the process, but I kind of purposely kind of put it at the end of this, because having the ability to know all of these things along the way, from an APM perspective, from a database performance perspective, into something that we all are very familiar with, which is essentially, you know, the ability to deploy code with a level of confidence that you understand that if there is code deployed, you can describe the impact it has on the environment. And from a database perspective, those are really, you know, the two main things to look at are the query performance pre and post deployment. That's a very easy one, and anything that's new, right? Understanding what is new in the environment is really important, because you may come across a query that was never there before, and suddenly it takes up 20 clock hours, and 80% of your time is spent on that one query, and that one query was never there until the last deployment. Having the ability to tie that back against a particular deployment or a particular code change gives everyone the ability to start the process of understanding and resolving those problems way before they become problems. Staging environments would be a good example for that, right? You know, deploying things in stage and, you know, understanding the query behavior of a new deployment and catching those queries, or what else, you know, rogue queries that potentially, you know, were left in, or, you know, something along those lines. And having the ability to catch that stuff before it goes and gets deployed is a big aspect, right? And, you know, helps and makes along to have a better customer experience, better user experience for anyone who uses the services or products that we create. So overall, these are kind of like the three areas, and I'm trying to tie in the time here so I'm not running over by too much. But overall, those are the three areas that, when I'm looking at it from a application monitoring perspective, where does APM generally leaves off in terms of there is a problem with the database, and APMs have varying levels of insight into database. So I'm generalizing a lot here. But where is usually it leaves off in terms of there is a problem within the database aspect, how to tie that into what we really need in terms of full observability, right from the app stack down to the infrastructure, and that obviously includes databases, and not particularly from, you know, the infrastructure level into the database, or just from the application level, but really having a look at the overall holistic view on where do those things tie together, and how can I correlate the data to make sure that I understand where the root cause essentially is, and understand where do I need to focus my energy and time on in order to fix problems quicker, in order to have better performing applications, better performing services, and overall create a better experience for whoever our end consumers are, whether that's internally or externally. And that is pretty much the end of it. And we've got 3 minutes left for Q&A. So I hope I've gotten that into the time enough.
Yeah, I think we're pretty good. I haven't seen any questions pop up on the Slack channel, so I think we shall call it good.
I'm not sure whether that's a good sign or a bad sign, but I'll take it.
You can take it. You can take it one of two ways. I mean, the best way is that you got exactly what you wanted to say across, and it was quite eloquent, and everybody understood it, and it was a fantastic presentation. That's the way I like to look at it, at least.
You know what? I'll run with that. I'm okay with that.
Excellent.
All right. Really excited to be there. I hope you all guys have a great time, and thanks again, Matthew.
Yep, not a problem. For those of you who watched it, just I wanted to do one little recap. There was one question that came up, but it wasn't related to the presentation at hand. It was about the schedule that was going on. We do all, in fact, have one stream Right now, none of the tracks, we don't have separate tracks, and we're not running parallel streams. So just wanted to clarify that. With that, I think we're gonna get a quick little video just to fill in a little bit of time here before our next presenter. So I'm gonna let that go ahead and start flying away.
Well, I think our schedule is a bit off. We are going to do a power hour before we get the 411 on PMM, but I am really excited about that talk. What we're going to do over the next hour is we're actually going to have 3 different companies, Percona, Nutanix, and AWS, give their perspective on what it means to run databases at scale. What goes into that, the caveats, what we've seen, what our experiences are, really everything all encompassing about scaling databases. And we're really excited to have this new format where we've got 3 pretty big powerhouses in the industry talking about the same thing to give you a perspective that's fairly unique from each. And then maybe we'll see some similarities in all 3 as well. I think Peter is going to be kicking us off for the second time today. Peter, I have the pleasure of introducing you. Let's see if we can't get you control of the presentation.
Well, yes, as soon as somebody else's screen is unshared, my screen gets shared. And
bango.
voila, we are ready to go.
All right, take it away, Peter.
Okay, well, yes. Let's talk about managing databases at scale. First, I want to highlight what exactly scale is. As I talk to different people, they really look about that from a little bit different standpoint. For some people, scale means large number of databases and database deployments, and that is important scale. In many enterprises, you find hundreds or even like thousands of small to medium size databases, which is their large scale. You can also look at the scale in terms of a number of development projects, teams, people, and of course, most kind of technical, most of us geek would be thinking about is large database instances or database instances which are serving large traffic. Now, at scale, we have a whole bunch of problems. Like, for example, if not technology, even if you'd imagine technology is perfect, scaling people are hard. Well, people are in generally complicated. We also have downtime, performance problems, security incidents. All of those get more expensive if your environment is large. And also what that means, what efficiency makes a lot more, right? Like if you're running single database instance, maybe, spending time to optimize it to squeeze additional 10% doesn't make sense. But at, Facebook scale, 10% is quite a lot of change, and that's maybe worth investing in optimization a lot. Another thing which I think is interesting at the scale is, are you choosing the database or databases? In our experience, we see what many people are choosing to use multiple databases, which improves their efficiency in terms of building better apps faster, because developers can use technology which is better suited for building what they're about to build. But it also can increased complexity, especially if it's run unchecked and you end up using tens of different database technologies, many of them may be very similar to each other, right? And with that, our best practice would be to use controlled number of databases where you can use sort of a best of breed databases for different tasks, but really control the sprawl. We also believe that at scale, it is a fantastic practice to embrace open source because software lock-in is much more painful at scale, both in terms of additional cost it tends to bring, as well as in terms of if you want to avoid that software vendor lock-in, to really decouple that at large scale is complicated. At the same time, when you're looking at scale, you need to be thinking about the unification, because if you have all your environments are very different, that will be very hard to manage, right? If you have unification, you will reduce your staff learning costs, right? As you onboarding the staff, operational cost, also reduce people mistakes, which can be extremely costly in scale, both in terms of downtime, security incidents, and so on. You name it. The automation is another thing which we see is being very important at the large scale, and in generally high scale requires high level of automation. What you would see for folks which have DBAs, for example, if you are a relatively small organization, right, maybe have 10 database instances and 1 DBA, and if you then look at how many DBAs some company has which runs 10,000 of database instances, we're not going to have thousands or times more DBAs. It doesn't make sense, right? In those cases, you would expect what a single person will be responsible for much larger number of instances, environments, and so on and so forth. And that requires high level of automation to reduce toil. We are also looking at things like actionable alerting, help to really understand the root cause of the issues, such as automatic correlation. And in the best cases, the self-healing. So systems can recover automatically from at least some part of failures. That is never complete, but at least some basic things like server goes down, or IO disk volume dies, right? System should be able to handle that automatically. From Percona standpoint, we've been working in this space by building a number of software solutions. Our Percona monitoring management helps with monitoring, not quite yet with management, but we're getting there. And our operators on Kubernetes can really help with a lot of automation work and reducing toil, which I mentioned. The next thing which I would encourage you to consider is to focus not on production alone. In many cases, as we spoke to our customers, we're very much focused about this, how to run databases well in production. And I think even database, similar to their bug fixing, it is similar to bugs, which this graph above corresponds to. It's much easier to prevent the database issues, security, scaling, performance, and so on and so forth with a proper design than trying to resolve that in production after everything was already shipped and written, and so on and so forth. Teamwork is also absolutely essential in this regard. In many organizations, we see there is some sort of conflict, and in a bad way, between operational team and development team, right? Or even kind of developers and DBAs, right? We can say, well, you know what, we now shipped our problem, right? And now it is the database is your concern. You have to figure out how to make it run, make it say scale. But guess what? if a system was not designed appropriately, if you have a horrendous schema, very bad bad queries, and so on and so forth, there is no database or no DBA which will be able just to magically fix that for you, right? Instead of throwing that toxic database waste around over the fence, you really need to work together as a team on the problem. The next advice I would have for developers: don't be like those developers which we talk on the picture about. Make sure you understand the database basics, because really, if you want to build a great database power application and at scale, you can't really do it well when you have no idea how database work. You may be able to write some code, ship some code, and then rely on somebody to mop in all those things for you, but that is super inefficient. What things should you learn? Well, at very least those things, right? You should understand the schema design, the data consistency models, especially in the modern world where a lot of cloud databases may have a different and sometimes exotic data consistency models. You want to know that. Really understand the power of database query language, because that often can increase both productivity of developer and performance by many times. You want to figure out indexes, and at least at a high level, understand how database execute queries. Also, if you look at the database standpoint, the queries is very important part, right? Well, frankly, that is essentially the only way how the application interacts with a database, right? If a database stores application queries very well, then developers are happy. If not, they are not. But guess what? If you have a bad queries, then no database will be able to serve them well. And you really want to ensure you squash them or eliminate them in any other way you are capable of doing that. Some tools which exist in the database for that would be something like explain. Right, here is example of visual explain in MySQL from MySQL Workbench, which can be fantastic way to understand how query is executed. And here's example from Postgres with tool called Piv, which you can visualize PostgreSQL plans with. Learn those tools or large number of other tools which exist for similar purpose, but make sure you can understand what is a bad queries and good queries in your environment. From Percona side, we've built PMM, which is very helpful in all that process to understand which queries are causing the load on the database. Also, you can understand why those queries are causing the load, like to understand how much of that load comes from a lock-in or disk IO or just executing the query itself. And then potentially you can figure out what to do about them. We bring in the most important data about queries, such as tables, the outage, the explain plan, additional example of a query, right, which is running, which should give developer or DBA all the information one need to fix that query on the single page. The next high-level best practice is you do not want to run with defaults. This example I taken from recent benchmarks done by our friends at EDB, comparing PostgreSQL 13 tuned versus running that with defaults. And you can see what at scale the performance difference is tremendous, right? And so many people are running MySQL and Postgres with default settings. MongoDB behaves better. Actually, at least by default, it scales its configuration to the server scale. But even with MongoDB, if you really want to get a best configuration, you may want to tune that for your workload. The next thing you need to mind is your approach to scaling. Vertical scaling and horizontal scaling, both of them make sense for different for a different application, and I think that's very good, important to make the right choices, because if you don't, you may either run into a wall with scaling when you rely on vertical scaling, but actually your application is too large for that, or to have more complexity, which often comes with horizontal scaling. Speaking about horizontal scaling, that's typically done through sharding in all the technologies we talk about. And situation in this case is interesting. Therefore, MySQL and Postgres, there are some third-party solutions which exist and kind of get a good traction on the market, such as Citus for PostgreSQL or Vitess for MySQL, right? Folks from Vitess spoke earlier today. For MongoDB, sharding is built in and frankly, much easier. That was one of the reasons why many companies have been choosing MongoDB to begin with. The next thing you may want to understand at scale is memory and how to use memory properly, because memory is much faster than even the fastest storage available. And having a right memory fit, where you have your working set fitting in memory, can be the difference between the database which barely moves and database which is really flies working very well for you. Again, that becomes more important at scaling, where you don't, where any bad choice becomes increasingly more expensive. Now, memory alone is not going to solve all your problem. Some I/O, especially writes, are unavoidable. They have to hit the storage, and in this case, using the proper storage is important. One thing what we see a lot at scale, especially, is there latency outliers, right? When you would have, sometimes 1 in a million of IOPS, you have a stall for 1 second. Well, for many applications, that may not be a problem, but for a database, if that's happened to be your transaction log, right, you'll have all your database stall for a second, and that can really have a lot of cascading effect out there, right? So you really want to make sure you have a storage which is robust when it comes to storage in terms of an outlier. The next thing, which we see a lot, people run into a problem with, is understanding speed of light limitations. While I think there are some teams working on it, I am not aware of anybody beating speed of light yet. And so if you really want the synchronous replication between US and China, for example, it is not going to be achieved with sub-millisecond latency, just because of a speed of light limitation, right? And that often conflicts with those kind of nirvana ideas about what developers may want to see, right? Which can say, hey, wouldn't it be wonderful if I have this cluster where I can write to it from anywhere and it's geographically distributed across the whole planet, right? Which will be very reliable, and also will mean I can serve my reads locally. Finally, I think one of the great practices at scale is do not fail alone. We see so many problems at scale which are entirely preventable with working with experts, and wherever you choose to build that experience in-house or work with some the external partners, well, do that, because databases are complicated, and it is not a great practice to just try to win them, especially at scale. That's all I have. And we are ready to transition to the next speaker, right? If you're more excited.
Thank you so much, Peter, for your input there and showing how we help our customers at scale. And we've seen quite a few different examples, and I think you highlighted some of those things, especially having the developers and the DBA team not being at odds with each other. That helps quite a bit at scale. Developers educating themselves or having some type of embedded expertise, observability. A lot of the common themes that we've seen today really played into your presentation already. And I'm really excited to hear what we've got from the folks over at Nutanix. Bala, I wanted to hand over the reins to you and learn us on some databases at scale.
Thank you. Thank you, Peter. Thank you, the audience here. Let me share the screen. Good morning, good evening, good afternoon, wherever you are. Let's see, my slides are visible, right? Properly? Can someone acknowledge it? Good. Okay. Thank you for the opportunity, Peter and team here. My name is Bala. I represent Nutanix. We have something cool to offer to the audience here. Let me talk about it. We all talk about database services, right? So let's just look at the world where it is heading. We have hugely successful hyperscalers providing managed database services, probably getting the revenues of billions of dollars a year. But we do know that a very minor fraction of the databases actually run today in the hyperscalers cloud. A lot of databases that we all talk about, whether it is MySQL, Postgres, or any other enterprise vendor databases, they tend to run on the enterprises, what we call them a private cloud, or to a certain extent towards the hybrid cloud. So the question here is, can we get the cloud-like experience for people who are actually supposed to manage databases on premises, right? And if we can do so, how do we go about doing that? What are the challenges? What are the things that we need to kind of cover that? And most of the enterprises, they do bring the governance. They do bring the enterprise governance structure. So they want to give that powerful utility-like experience the way the cloud developers enjoy in the public cloud. But at the same time, when you talk about enterprise, there is a lot of governance, there's structure, there's control, there's compliance, all of those things will come into the picture. How do you blend this control and convenience and provide the cloud experience? And that's what we call at Nutanix, a platform called Nutanix Era for databases, right? So let's try to go through what it means is help create database as service at customer terms, at your terms. That's what I call, rather than one size fits all. Now, before we go down what exactly we are trying to do with this whole thing, maybe we'll just do a quick primer on some of the challenges. When you talk about legacy infrastructure, when you talk about enterprise databases, the infrastructure is very siloed. There are multiple teams. There is a compute team, there is a storage team, there is a networking team, and then there is DB ops team. The ticket passes from one team to the other to create a database at the end of the day for the developers. The process is difficult. It is highly manual, lengthy upgrades and too much downtime, and people. At the end of the day, there's a lot of people, a lot of interacting in teams and interactions. So this slows down this agility, essentially. That's one of the fundamental reasons why everyone is flocking to the managed services cloud or cloud, where they would like to enjoy databases as the utility. They are like electricity, they consume and they pay the bills, and then they just focus on the business logic, right? Now, if you look at just databases itself, the landscape, if we get an opportunity to rewrite and everything being done in managed services, it's great, right? We do see such implementations, but the world is highly segmented in that there is a huge number of databases which are pretty much late 80s, early 90s technology. The databases got evolved. It's basically a vendor product kind of stuff. In a way, you can also see Postgres, though it's open source, at the end of the day, it's a product. It's not a service. And same thing with MySQL too, but people have to manage. And some of these databases technologies, they are pretty much late 90s, they don't assume any infrastructure goodness, and they tend to do things in more higher level. So when you're talking about backups, sometimes they go in number of hours, like 6, 7 hours, 8 hours, or even 12 hours I have seen. And when you try to clone, when you talk about 40 terabyte database being cloned, it's a full copy all the time. So what we have seen with our customers is there's a dev team, there's a QA team, there is analytics, reporting team. Everyone needs a copy of this database. The database fraud becomes so intense, big problem that the database itself is 100 terabytes, but the secondary environment is almost close to petabyte. That's the kind of problems that we see in a typical enterprise world. So everything slows down after that. And this is one of the products that we are talking about. So we have two kinds of infrastructure itself is fragile. On top of it, database products itself has their own set of challenges. Now, how do we get the database cloud experience with given all these challenges? That's what we call a Nutanix era, a database cloud at scale at your terms, and we will talk about it. So we launched this product on Nutanix platform. For the audience who are new to Nutanix, Nutanix, you can think this as like a public cloud kind of infrastructure using the bare metal, using the commodity hardware, but giving the cloud-like experience for customers at the infrastructure level. So we are talking about storage simplicity, storage virtualization, compute virtualization, network virtualization, so that all smashed into it, and then you can do compute storage on top of Nutanix platform, like a cloud. My org looked at the opportunity and said that, man, there's so much goodness that is happening on the public cloud where people can enjoy managed database services. Why not recreate that kind of magic for customers on-prem on this beautiful infrastructure that we have at Nutanix? So that's what is Era. It's one-click database service, whether it's Oracle, Postgres, MySQL, MariaDB, SQL Server. We actually simplify provisioning aspect. We can cut down. We have seen it from multiple weeks and 2 weeks in some of these big banks to matter of minutes. We can provision complex databases, which are Postgres clusters, including Postgres clusters or Oracle clusters or SQL always on availability groups. We have a highly sophisticated feature called Time Machine, leverages the underlying infrastructure where customers can go to any point in time, literally to any second, and then recreate the database as of that time. And that database is extremely efficient in its storage capacity. That means that you can almost pack 7 to 8 databases with the storage of one database copy, but keeping the same quality of service as the production database. So it's best of both worlds. It's just a highly efficient copy data management, but at the same time, the quality of these clones is as good as source. We take care of patching. We talk about database protection. So this is what bringing the database cloud experience onto the enterprise cloud. Now, we talked about Time Machine. I'll skip this slide. Very sophisticated Time Machine. You can go back to any point in time, including your Postgres databases, MySQL or Oracle. Doesn't matter what the database is. You'll be able to do your clone management and refresh all one-click way. Now, what we are seeing because of these efficiencies that are gained on the platform, as well as the cloud-like experience, our customers enjoy a huge ROI for the database management. Their TCO, total cost of operations, come down. Essentially, they're enjoying the cloud. Essentially, they're recreating the public cloud experience and the on-prem. Now, did we stop here or we are moving forward? As you see, the world is moving to a hybrid cloud. We started with on-prem, but we know that our customers want to do database management in the public cloud too. They do want to bring the goodness of what we do at Nutanix on-prem to the public cloud. So we extended our feature set to work across clouds, what we call cross-cloud, cross-AZ ability through Era, a single control plane that manages your database assets, whether they are on the on-prem or in the cloud. Now, and we also have a very sophisticated layer called data access management. This is like a dam for a raging river where you construct a dam and channelize the energy and then irrigate your feeds and electricity kind of stuff. It's important to have a one-click access, but at the same time, a control for your data in the company. So we have a feature called data access management. That means that QA teams will be able to see only sanitized copies of production copy. The HIPAA compliance, PCI compliance, all those things can be met with different data access management policies. At the same time, one-click way, so that the QA developer doesn't need to wait for 2 weeks to get their database or database copy kind of stuff. We are enhancing our engines further. These are the 5-6 engines that we have. But we are also going to the NoSQL aspect of it and looking at other cloud native technologies or the open source technologies like Cassandra and other stuff. We have a highly sophisticated integration touch points. Everything that we do is API. That's what I keep talking about cloud, so that you can integrate with your own self-service control planes wherever you need to do it. And the last thing, we have ventured ourselves into a fully supported system for Postgres, meaning if the customers actually deploy databases through Nutanix Era platform, we'll provide them 24/7, 365 support. We are learning a lot from partners like Percona and other vendors that they manage these database technologies. But it's a very delightful experience to help the customers in single end-to-end single stack way, the platform, the engine, as well as the service. Now, if you see, the roadmap is moving to hybrid cloud databases service, so the customers can have databases across these clusters that can spread across clouds. We have a GA product in the AWS, Nutanix clusters. Our database technology or the Era works on that. And we did an announcement with Azure, and soon we will pretty much go live on that with some customers waiting for us to get there. And as you can see, some of the use cases, people can run production databases on-prem if they have a data sovereignty issues and they want to really control the data, but they can do their dev test cases, bursting use cases into the cloud with this technology. Or sometimes they do really want to see the cloud data centers or bare metal Nutanix clusters as the extension of availability centers where they can extend the database, meaning Postgres. We're talking about a Postgres primary and production primary copy running on-prem, but its replica is running into a cluster that is there in the AWS. That kind of sophistication is possible. And then a lot of times people do ask the question, Bala, this is all good, but what about performance? Database is all about mission critical in nature. Transaction throughput is very critical. We work with all these software vendors, and we bring the latest and greatest technologies. And if you can bring those things in the commodity servers, our performance benchmarks are pretty close to, they're very similar to what you can get from purpose-built database appliances, right? So you will be able to see that the kind of stuff, the scale that we are talking about. We have customers that run around 200 terabyte databases on these systems. We have customers who are actually building an entire Postgres service onto this system with thousands and thousands of databases. So we feel the design principles that went in API first architecture, the scale out architecture of the platform, and then the resiliency HADR capabilities that we built into this whole Era database service, we let the DBAs operate the cloud. We let them create the cloud. That's our motto. Rather than having one single dedicated place to go and enjoy the experience, we let DBAs create and operate the cloud for themselves. As you have seen, some questions might arise. Is this all like, is this a walled garden that you have to enjoy within the boundaries of Nutanix? No. We know that we cannot control the world. So obviously there are things that we think that with our platform, customers can enjoy. But when they're operating in the public cloud, there's so many good services, so many good other complementary services that they can enjoy from the public cloud vendors. More than happy. That's a seamless management, integration, mobility we promise for our customers in this extended hybrid cloud platform. Lastly, I do want to touch upon one important thing, Postgres. We launched in 24/7 mission critical support for the Postgres SQL. If they are managed, if they are provisioned by Era, we take care of it all the way from storage to the service, like the way the public clouds do. We allow customers to customize their OS versions and PG versions. Obviously, we kind of certify them, but it's the image is coming from the customers. It means if they have a tightened, hardened image, it's basically purpose built for their customer, their needs. We will let them operate their images on our service platform, basically end state driven management. That's what we call. We provide Postgres extension support if the customers have certain extensions to manage their database systems. And some of the early results, I'm super excited to inform that we compare very close to what public cloud vendors managed services provide. Very high degree of availability, where the customers can stretch Postgres on different availability zones. And our backup is highly differentiated and probably better than most of the other vendors in the public cloud, because it's all application consistent snapshot. It's a matter of seconds. Recovery times are RTOS times are very small. We guarantee no matter what the size of the database is, can happen around 30 minutes, because the way that we do the snapshots and then we take the transaction logs to operate with it. And we do have a highly sophisticated Percona-based replication redundancy built into both at the databases at different layers. So we think that we are ready for prime time, ready for enterprise grade Postgres solutions for our customers. In fact, I'm super excited to inform that there are a lot of interesting customers actually use our product for Postgres as well as for other database technologies. So let me pause here. So we are a young new entrant to the database market. I'm hoping that you guys embrace us, and looking forward to work with all of you guys and then learn from all of you and then take it from here. Thank you.
Thank you. So I did have one question that I wanted to follow up with and just get your take on, because you do have the unique perspective of attacking the problem from the hardware side first, and then examining how you can approach a software problem with your really wonderful technology solutions that you provide in your hardware. What was the single most difficult thing about building the Era platform to have a scalable solution that both maximized performance with some of your vendor relationships and ease of use for the end user? Can you go into some of that and what some of those challenges were?
Yeah. So that's a great question. Thank you. So the ease of use is pretty much high. The bar is set, very high bar is set by the public cloud vendors. You got to behave like public cloud experience for all the developers. Think of any big company. The motivation for them to choose us versus public cloud is convenience has to be exactly same or better, right? The developers, otherwise they'll flock to public cloud. The aspect that makes us very differentiated is the control. All these big companies have DB ops teams, and they want to bring that enterprise governance structure on top of this convenience kind of stuff. So that's where we think that we call that end state driven management that we bring it to. But to your point, but how do I manage the performance aspects of it? Because when you talk about service, it's all about SLA, right? We're talking about the SLA contracts clearly mentioned. So we curate the platforms that we kind of work with. So we are not hardware vendor. We take any commodity or any kind of vendor hardware, whether it is HP, whether it's Dell, whether it is Micron, doesn't matter. We give the choice to the customers. You pick your hardware as long as it's kind of benchmarked with our software against this. Like you cannot run database services on random boxes and expect the consistent throughput and SLAs that you see it. So we benchmark ourselves, and then we give the performance benchmarks for this kind of configuration. We size them, what we call them sizer, and we kind of tell the customer, if you have a purpose-built database appliance from a vendor, there are a lot of technologies like that. We say that if you want to get that kind of throughput, here is the configuration that you might want to embark on. So you go and shop your commodity or any other vendor hardware, you get the hardware, then we can deploy our software because we have tested it in our labs that it scales, it performs both scale up and scale out. Scale out is something is very imbibed into our DNA. If you look at Nutanix architecture, it's all based on the Google-like file system that we scale out is something close. That's what we are patented and that's what we are famous for. But the performance characteristics scale up in the local rights, the way that we do it. So we work with these vendors, we do benchmarking, we publish those results, and we talk to the customers. If you want this kind of throughput, please go and get this kind of hardware. If you want us to give us, and we are more than happy that we have strong relationship with vendors, and we can even give the hardware to you.
Yeah, and I think that's an excellent point that you make, that a lot of the legwork at scale for these databases is knowing the different performance characteristics for specific vendors or combinations of vendors, and having a leg up with Nutanix, being able to provide that, I think, is something that's valuable in this database space, especially
And
the open source.
Predictability is very keen for customers. So we try to simplify it. The whole thing is, as I explained, there are 10 layers to get to the final value. We try to simplify it and then provide that value, and then bring the cloud experience to the on-premises to start with, but give the bridge of hybrid cloud to go to public cloud through our software.
Great. Well, thank you so much for your time. And speaking of hyperscale providers, we're going to transition to the granddaddy of them all in AWS. So we have Suresh from AWS to take us through the final portion of our Power Hour. And so I'm going to go ahead and pass over the baton to you. And the bar's been set pretty high from the software world, the hardware and software world, and now we want to hear from the hyperscale provider. You muted yourself.
Perfect. Am I live now?
Yes, you're live now.
And can you see my screen?
Absolutely. Cheers.
Well, that was easier than I thought. So hey everyone, my name is Suresh. I run Amazon RDS open source engines, which includes Postgres, MySQL, and MariaDB. And I'm joined by my colleague Yoav Eilert, who's part of our product management team. So first up, huge thanks to Percona for hosting this wonderful event and giving us an opportunity to share our insights on a topic that most of our customers are run into at some point, which is how do you scale and manage your databases at scale? Now, most of you, or several of you, run your databases in the cloud. So Percona invited AWS to share the cloud point of view on this topic. I'm going to telegraph the answer a little bit, or at least our point of view, but I'll assume that if you're running a large number of databases in the cloud, then you're likely already using or considering using a managed database service to reduce the administrative burden, what we would call the undifferentiated heavy lifting. For the purposes of this next 20 minutes, we'll use Amazon Relational Database Service, or Amazon RDS, as the example of the managed database service. But really the learnings should extend to other public cloud vendors and any other managed services that you use. So what is RDS? It's a managed service that makes it easy to create, set up, and operate your relational databases in the cloud. We have hundreds of thousands of customers using it across any of the 7 database engines that we support. These 7 engines include the 3 open source engines, Postgres, MySQL, and MariaDB. Also, Amazon's own MySQL and Postgres compatible cloud native database, which we call Aurora, and third-party commercial databases. And these customers run these databases both in a public cloud and in a hybrid cloud environment. You have different deployment models you can choose from. So what the scale and diversity of usage really gives us is a vast number of data points where we get really good insight into how customers operate their databases in the cloud, what are the issues that they run into, and how do they overcome them. Now, one other important point about sort of the source of data, right, the source of insights for us, our customers, is that our customers range all the way from individual developers who may have one free tier instance, in AWS speak, that'd be a T2 micro instance, for example, all the way to the other end of the spectrum where you could be a large enterprise running thousands of databases, right? And several of these at internet scale. So if you look at Amazon.com as an example, they are one of our customers, and they use the inventory management system. They use Aurora for it. And over the 11 years that we've been running RDS, we've seen customers move from the left end of the spectrum all the way to the right. And what this really gives us is an insight of how they were able to do it. And those are the best practices that I'll be sharing in a moment. So what are these challenges that customers run into, right? When they start scaling their fleet, when they're not talking about ones and twos, but they're talking about tens, hundreds, and thousands of databases in the cloud. We'd argue that the most important thing that you should be doing if you're responsible for database infrastructure, regardless of what scale you're running at, the most differentiated activity, so to speak, is to be partnering with your application developer partners on making sure that they're getting the most out of the underlying database infrastructure. What does this really mean? You need to be partnering with them on application design, query design, and schema design and tuning. And this is, it's hard work. It requires a lot of thinking. So it takes time and it takes focus. What we find, however, when we talk to our customers who are self-managing databases, as opposed to using a managed service, the ones who self-manage databases spend the vast majority of their time and attention on what we would consider basic tasks, right? Basic tasks like provisioning accounts, users, databases, configuring your databases, setting up your replication topology for high availability or read scaling, monitoring your databases, reacting when issues go wrong or when issues occur, setting up your backups, right, and monitoring the backups, making sure they happen, they're valid, setting up your DR setup, disaster recovery, and also your cost management. This is a big part of running things in the cloud, is that you want to make sure that you're right-sized at all times. And not just this, anytime you have to do a change, it's OS patching, database upgrades, or you have a new vendor, new generation of hardware come out, you want to upgrade to it so you get the latest benefits of performance and availability. And all of this stuff, the work that self-managed databases require you to do, it's hard work, right? It's important stuff, and it's really hard, and it gets harder still once you scale your fleet, right? It's hard enough with one database. Imagine doing this with thousands of databases. But here's the crucial thing. None of this is differentiated, right? Different does not mean differentiating. And so if you're doing any of these activities in a unique way, I would exhort you to think and ask yourself, why are you doing it differently? It's not different really from any of your competitors, or shouldn't be, because this is not where your secret sauce is. So when you're running databases at scale in the cloud, what's the trick? In a nutshell, our point of view would be that you got to offload all of this undifferentiated heavy lifting to a managed service like RDS, and then you use established best practices for scaling your fleet. Now I'm going to share a bunch of tips, right? These learnings come, like I said, from our customers, and these tips likely apply to whichever cloud you use. But we're most familiar with AWS. So as we go through these tips, we'll call out AWS specific services and features that'll help you implement these tips. So let's get right to it. This is it, 6 tips in all, and we've organized them in the order in which you're likely to encounter them, depending on when you enter the cloud, you start using the public cloud, and when you start using managed databases. Tip number 1. You're beginning to scale, or you're already scaling, right? And one of the most important things about scaling, especially if you're in hypergrowth, and we've seen several of our customers experience that, is you actually don't know what the future is going to bring. And so one of the most important things that you can do in the state is to give yourself flexibility, right? Create as much flexibility as you can for yourself. And a key way to do that is to organize your resources at a very fine grain so that you don't have to come back later and break up the monolith. Right? You don't have to go back and break things out, tease things apart. That's a lot of work you have to do after the fact, and it's hard when you're already operating at scale. So start with fine-grained resources. What does this mean? Use separate accounts for different major workloads or different parts of your organization. Use separate dev test from prod. Seems basic, but important. And once you have these different accounts, users at a fine grain, make sure that you're setting up your permissions as well at a fine grain, right? So what we would call the principle of the least need privilege. Now you set up your accounts, you set up your permissions, and they're at fine grain. Now you got to make sure that you're not drowning in fine grain, right? So you got to have some way of creating structure while staying flexible. And this is where tagging is an extremely powerful tool. It gives you a very lightweight way to create multiple flexible hierarchies that you can put on top of these accounts and databases and various permissions. And it's not just about structure, it's also, a handy way, for example, to track your costs and do chargebacks and things like that. So tagging, super important. And then the last thing I'd say with this tip is you want to make sure that there's not a hidden cost, right? Now you're talking about multiple accounts. You got a dev test account, you got a prod account. Now, does that create hidden work for you? So we'd say, make sure you understand your managed services or the capabilities of your public cloud vendor well, and see what they give you and take advantage of it, right? So cross-account operations, make sure you understand them, make sure you use them. In the context of AWS, you could use something like IAM to manage your users and permissions. You could use AWS resource groups for tagging. And then in a managed service like RDS, you could use, for example, cross-account snapshot restore, where let's say that you have a production database, it's running in your prod account, you take a snapshot, you restore it into your dev test account, where you could do things like change the schema, fine-tune your parameters. Maybe you're trying something out before you bring it back to production. But that would be an example of an operation that it's just inbuilt, it's a managed feature for you. Tip number 2, you got a lot of resources. Seems kind of obvious. If you have a lot of users, a lot of passwords, lots of everything, it's great if you have a centralized system to govern all of this. It's especially critical when you're talking about authorization, authentication, but also is very useful when it comes to budget management. So we'd say in the context of AWS, use something like AWS Organizations, which is a service that integrates with other AWS services and gives you kind of a central cockpit to manage your environment centrally as it grows and scales. We already talked about IAM. You could use something like Secrets Manager to manage your credentials. And then on the cost side, we offer tools like AWS Budgets or AWS Cost Explorer, where you can track and manage your spend. So, so far, tips number 1 and 2, I'd actually argue they're not specific to databases, right? Anytime you're scaling your environment in the cloud, any service you're using, these seem like generally good ideas, you should be using them. So let's get a little bit more specific about the database part of the story. So tip number 3, this is productionize your database configuration. Now, whether you're using 10 databases or you're using 10,000 databases, one of the most important things, one of the things that drives complexity with managing databases is that databases offer you a huge surface area. And I'm not just talking about the SQL interface that it provides applications, I'm talking about all the knobs that you can use to configure and tune your database performance, and trade off availability, performance, all the stuff that makes databases powerful. A core thesis we have is that regardless of your scale, whether you're running, like I said, 10 or 1,000, it should be possible for you to establish a few archetypes that you can then use across your fleet. These archetypes can be based on instance size. It could be based on the type of workload. You may even have a different set of archetypes for things where you have sensitive data, for example. But you have to think through what these archetypes are for your organization. And like I said, typically there's a handful. And then make sure that as you stamp out new production databases, they fall into one of these archetypes. The fewer the exceptions, ideally no exceptions to these archetypes, the easier it is for you to manage. And that's on the configuration of your databases. The deployment itself, we'd say that treat it like a factory, treat infrastructure as code, and use one of the standard tools that you'd use when you think of infrastructure as a code. In RDS, for example, we offer something called database parameter groups. There's also a variant called cluster parameter groups when you have a clustered database like Aurora. And by default, we offer a parameter group for each database engine, each of the 7 that I talked about, and also each major version within those engines. So something like RDS MySQL 5.7 would have a different custom default parameter group than RDS for MySQL 8.0. But you can take these and you can customize it for your needs, and you can make how many ever I'd say. But like I said, keep a small handful, right, of your archetypes to customize for your needs, and then use these across all of your production databases. And then on the infrastructure as a code, there's many tools that you can use. AWS CloudFormation is one of them. Tip number 4, sizing databases is one of the hard things about managing databases at scale, because you're continuously trying to find the right balance between not provisioning too much that you're unnecessarily wasting capacity and spend, and not provisioning too tightly so that when you have a spike in your workload, your customers have a bad experience, right? And it's not just about production workloads that are spiky or unpredictable. We sometimes see customers who are not very careful about managing their dev test instances, and you can quite easily pile up the number of dev test instances that are not actually being actively used. And so the question to ask yourself here is, does your public cloud vendor, does your managed database service offer you tools to automatically scale capacity as needed, automatically shut down usage when not being used, and then take advantage of this, right? The obvious gain is you're going to save cost. But the other hidden thing is it's going to save you a bunch of complexity in terms of management burden, right? And really free your time up to do the stuff that's truly differentiated for you. One thing to think about when you're using a cloud native database like Aurora, you get to auto scale each of the different parts of the stack, writes, reads, storage, and IO separately, right? So like I just said, Aurora has different capabilities that come out of the box that let you auto scale. So with writes, you got serverless. With reads, you got auto-scaled read replicas. The storage is dynamically done. You don't even have to do anything for it. You can both scale up and scale down. And IOs you use on demand, depending on what your workload needs and what your instance sizes are. If you look at the non-Aurora RDS engines, we offer something called auto-scale storage. You can also mimic the auto-scaling for these other dimensions using a combination of RDS monitoring, which then used to trigger a AWS Lambda function, which then calls the right RDS API to maybe scale up, scale down, do the things that you want. Tip number 5, probably the biggest one, and goes back to what I said at the beginning, which is that when you have a lot of databases and you're already operating at scale, the most important thing we think you can do is use the capabilities that your public cloud vendor is already giving you. Whether this is to set up your HA configuration, read scaling, logging, monitoring, backup, DR, patching, if it's coming for free, use it, right? Because then that frees you up to do the things that are special for your company and for your customers. With RDS, for example, we offer multi-AZ deployments, which means that you can have a single database that has a primary and a secondary, which are located across 2 different isolation zones, two zones with different fault tolerance characteristics, but in the same region. And you get automated managed failover from one to the other. So use that. You can also use managed in-region replicas. With RDS, you get up to 5. With Aurora, you get up to 15. You can enable database logs. It's just kind of a checkbox if you're using the console, or you can use the API as well. And you can upload these logs automatically to AWS CloudWatch logs. Same with monitoring. You can set up monitoring fairly easily, and you can upload all these metrics to AWS CloudWatch monitoring, CloudWatch metrics. RDS offers automated backups, manual snapshots. If you want to set up a DR, disaster recovery, we offer a cross-region read replica, which is automated and managed. With Aurora, it's got something called global databases, which offers superior RPO and RTO, so recovery point objective and recovery time objective. From a patching perspective, we'd recommend turning on auto-minor version upgrades. So this is a facility where you automatically get patched up to the latest, what we call preferred version, something that we've tested and we've made generally available. And it happens within your maintenance window. So you don't really have to think about it. It's something that you get free. And again, you get the security fixes and all the other fixes that you want for your database. The last tip I'd say is databases don't live in isolation. As I mentioned, they have huge surface area, right, for the applications above them. And it's critical that you understand the interplay between the app, proxy, and the database layer. Simple examples, make sure that your timeouts cascade the right way between statement timeouts, connection timeouts, application level timeouts. If you have a database restart, make sure that you don't restart all your connections at the same time, because that could cause a connection storm, right? From a monitoring standpoint, don't just look at system metrics, right? Like CPU usage, that's important, but also look at performance on a query level. so that if something goes wrong, you can be fairly surgical about identifying where the issue is and go fix it. And then if your public cloud vendor offers you a choice of cross-stack operations, use them. So again, in the AWS context, a service like RDS Proxy will help you with connection management, amongst other things. You could use the performance insights feature. It comes with RDS, you just turn it on to get performance at each SQL statement level. And you could use a tool like AWS Backups that operate across your stack to take a backup of your entire stack. So that was a lot of ground to cover, whirlwind. So I'll just leave you with one closing thought, which is databases are complex pieces of software. They have a wide surface area, both in terms of SQL and in terms of the configuration and tuning. And they can interact with your application in a myriad of ways. When you're running a database in the cloud, at any scale, but particularly at large scale, take advantage of the public cloud capabilities and offload all the undifferentiated heavy lifting to the public cloud vendor so that you can focus on the secret sauce that makes your company great. Thank you.
Great. And thank you for that presentation. I've got a few questions, just like I've had for everyone else. We heard a lot about how the cloud can really help offload some of the tasks that we see most traditional DBAs or smaller applications teams. They can leverage a lot more with not just AWS and RDS, but any cloud provider. Allows them to free up their cycles and focus on the things that are above board. Do you have any advice, or do you have any stories that you can tell from customers that you've been associated with that have had, those cycles freed up from having to manage their databases, where they've seen, great success that they wouldn't have otherwise seen if they didn't have something that, like a database as a service like RDS provides? Do you have any insight into that, so that maybe some of our viewers who are considering that move can make a well-educated decision?
Absolutely. So one of the, I won't refer to any particular example here, but I'll share sort of a general theme I've seen across a number of customers who move from self-managed databases to managed databases, whether it's any of the RDS engines or Aurora, is that oftentimes some customers are already operating at scale when they're self-managed, maybe it's in their data center, and they have some of this tooling already built up with backups and things like that. And when they move to RDS, a couple of things happen. They realize that, yes, some of the tooling was already there, but a managed service gives you a fundamentally different level of automation and just ease, right? You have this entire company that's focused on just making your databases work and operating it at scale. They have more than a decade of experience, and they're able to help you on a lot of these things. And as as your needs grow, right? Maybe you start off just operating in one region, and now you suddenly have a global business. You get things like DR for free, right? You get to be able to spin up in other places for free. And so we've seen customers commonly come, use managed services, take advantage of managed services, and then operate at a phenomenal scale, hundreds of databases per DBA, and then really shift their attention to the application developers. I can't tell you the number of times I've had spoken with a DBA where they really want to be talking to their constituents and not just managing the guts of the system. So that's a fairly common story.
Great. Yeah. And so I think one common theme that was really interwoven throughout all three of the presentations was this whole idea of automation, right? Automation, 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 whether that means write your own type of automation, where we had the services driven approach where you're not relying on any vendor, or whether that's using some platform like Nutanix that's trying to obfuscate automation across any infrastructure in kind of the Nutanix flavor. And then, we have the cloud provider who's saying, that there's tons of domain expertise within the cloud provider that is just automation specifically for databases. And so in all three different talks, we hear automation, automation, automation. And I think that's a really key point across the board whenever you're talking about managing databases at scale. Fun fact, I used to run the managed services practice at Percona, and one of the biggest and core focus that we had to be able to scale not only our customer base, but our business was in automation. And I think that really is the key to unlocking databases at scale, is that first piece of the puzzle really has to be automation. And then I think from there, you start layering in expertise and some of the fundamentals that we heard in some of the various talks today. I want to thank all three of our speakers and invite any of them to have any final words that they wanted to say before they departed. But I think that was a really useful session to get three kind of unique perspectives in the market and have some of those common themes throughout. Okay, well,
thank you for having us.
Yeah, great. We're going to pass over to Michael Coburn to continue the high velocity 28 hours of conference talks. Michael Coburn, take it away.
Thanks, Rick. This is Michael. Hi, everybody. You might remember me from the last few online sessions. I'm on the consulting team here at Percona. But in a past life, I'm quite pleased that we're going to segue into the first talk here. We're going to be talking about PMM. And for 3 years, I was a product manager. But it's with my great pleasure, I'll be introducing to you the new product manager for PMM, Brandon Fleischer. He's our senior outbound product manager for PMM. And also he'll be accompanied with Steve Hoffman, who's our VP of platform engineering. Now, before we jump into it, I just wanted to make one quick comment. For those of you around Percona, you know that both Brandon, Steve, and I like to play hockey. And we've had quite a running question over who's the best skater. And I wonder if maybe, Steve, you have an opinion on that.
That's unfair to put me on the spot. You know I'm the best hockey player in the company.
Okay, okay. Brandon, what do you got to say?
Well, as the goalie in the bunch here, there's no doubt who's the best skater. That would be me.
Right on, right on. Okay, guys. Well, I'll turn it over to you. Looking forward to the 411 on
Hey,
PMM.
can you hear me?
Take it away.
Great.
Okay, let me just turn off the Zoom so that they don't hear.
Well, the answer is we could hear him. Michael, I'm just surprised that you did not play your Canadian card as the de facto best hockey player in the company. I think it is, you were born with skates on, as I understand it, or is that just legend or lore?
No, fortunately, I came out feet first, and hockey's been part of my life forever and ever. We just haven't had a chance for the three of us to skate together yet.
Yeah,
It's
coming soon. All right. Do you think we're on? We good?
All yours.
All right.
Let's do it.
Hi, I'm Brendan, and today, as Michael said, we're going to talk about the 411 on PMM, Percona Monitoring and Management, and I just wanted to take a second and talk about that title. Urban Dictionary uses the definition of the relevant information or truth when you talk about 411, and this is the source of 411 actually goes back pretty far. So I'm going to give a little lesson here to some millennials out there. The source is that back in the day, using a telephone and actually a landline telephone number, you dial 411 in order to reach out to a live operator who would provide you with directory assistance. And what that means is that operator would give you information about somebody else's phone number. So that's the source of 411. And today, what we hope to be able to do is give you the truth and the realistic, relevant information you need as both an existing customer and for those that aren't yet on Percona Monitoring and Management, the future users of the product. So we'll go in from there. So I'll take a first stab at quick introduction as Mike, just to follow up on Michael. As Michael said, I'm relatively new to Percona, and I'm the senior product manager for both our Percona Monitoring and Management tool set, as well as some of the things that Peter spoke about in his keynote today, the enterprise platform. And so, those are my two areas of responsibility. Steve?
Thanks, Brandon. I just introduce myself, Steve Hoffman. I lead the platform engineering team, which PMM rolls up underneath. And just sort of a personal aside, I do remember dialing 411 pretty religiously the day we got to get rid of our phone book, and we could just dial a number and someone would give us the number, until we got our first phone bill and realized it was like 75 cents per use. And I don't know, my mother chased us around the house. We spent so much money dialing information. So,
well, that's,
but excited to be here. Happy to talk about PMM and the 411.
It's a good thing that Percona is an open source software, because we don't charge for our directory assistance here. So, all right. From an agenda standpoint, we wanted to hit on a few different things. I'm going to start here in slides, and I'll cover this PMM framework, which is a new visual representation of the key jobs to be done. If anyone is familiar with that, approach or methodology, that jobs to be done within a tool like PMM. And we'll then dive into some of the new feature functionality that we've added to the product since the last Percona Live back in May, and hit on some of the key highlights there. I'll then turn over to Steve, and he'll go into the application itself and demonstrate some of those same what's new features. And he'll then finish by turning it back over to me, and I'll pick back up in slides around the what's next, hit some of the roadmap items over the next 6, 12, 18 months. So we'll go from there. All right, from a PMM framework perspective, and I was listening a little bit earlier, about an hour or so ago, Marcus from SolarWinds had a presentation on monitoring and management capabilities, and it was interesting to kind of tie this into some of the elements of this diagram as well. One of the key things about this diagram is that PMM is actually one of these products that's hard for a product manager to say this, but I don't want users to spend all day in this particular product. And that's because PMM is a set and forget type of application. And that's highlighted by the monitoring and alerting. This quadrant in this life cycle here is all about being able to identify what metrics and key performance indicators that you want to be focusing on, and then creating business rules or alerts so that the system itself can be looking for issues or potential issues around those key performance indicators, and then communicating to you, basically tapping you on the shoulder wherever you want to get that tap, to say, you know what, I think it's time for you to come back into the interface because there's a potential issue arising and you need to look into that. And so what this lifecycle is all about are those issues within your database environment. And it starts with the monitoring and alerting and setting those up so that the system can do the work for you. And as you kind of go into monitoring alert, you need to hit the configure module. That's where you're basically telling the application, these are the databases and the clusters, the environments that we want you to pay attention to. And you'll initially set those up, but obviously need to make changes to that configuration over time as new databases get added to the overall environment, subtracted, and edits to those specific databases. One other thing to mention on monitoring alerting is that historically PMM focused on database performance monitoring, and that's really our roots with the product. Back in the May timeframe at the last Percona Live, we introduced what we call security threat tool, and that kind of forked off not just monitoring database performance, but also monitoring database security. And so now when we talk about monitoring and alerting, it's both performance and security based. All right, so if monitoring and alerting, is trying to help you identify the issues, from there, you move on into diagnose and troubleshoot. And that's all about taking that issue and getting to its root cause. And we provide a rich set of tools highlighted by our tool that we call Quan, which stands for Query Analytics, that allows you to go deep inside of that specific issue to get to its root cause. And the reason you get to the root cause is really twofold. One, it's to be able to, as quickly as possible, eradicate that specific issue from the environment right now and fix it so that the environment can get back to a steady state. And then second, and that's what optimize is all about. And then secondarily, it's about making tweaks to the environment so that hopefully that root cause issue never materializes again. And that's what manage is about, being able to make those database command changes for the long term. And once you've gone through those two cycles as well, you're right back to now kind of a neutral environment and allowing PMM to do its monitoring job again to detect any new issues coming in. And so that's really what this new framework is about. And we hope to get your feedback and hope to see a lot of this materialize through the application as time goes on. I will say that that framework is a visionary concept behind PMM. Not all of that is in the product today. And when we get to the what's next, we'll highlight some of those key elements that are coming soon. All right, so as far as what's new now, there are 5 key elements that we want to focus on. You might know that Percona's roots are in MySQL. Thanks, Vadim and Peter, for all of your efforts there and your background in history. And so, you know, our core strength at the outset with PMM was also in MySQL. But we have an objective within PMM is to be able to monitor and manage all leading open source database technologies. And these first 2 items that are on this list fall directly into that objective. The release today of PG Stat Monitor, that was released in a tech preview. We expect general availability to happen either later this year or very early next. That piece is being able to take the PG Stat Monitor that's in the Postgres distribution and integrate that within PMM so that we're now providing a much richer, robust set of database metrics that can be visualized and help you with both that monitoring and troubleshooting process for the root cause that we just talked about in that last diagram. And then from a MongoDB exporter standpoint was another key release recently, which was on the MongoDB side in order to, again, expose a very deep set of exported data for quick issue resolution. I talked about that security threat tool that we came out with in May, and between May and now we've really spent some additional time around enhancements of security threat tool. One of the key elements of that is being able to click a single button on that interface to on demand launch those checks in the environment to check on security related issues, as well as being able to silence alerts when, for example, you're in a maintenance mode and you don't necessarily want to get alerts around checks at that point in time. So a lot of good work that went into a security threat tool. Steve's going to highlight annotations in his demonstration. And one of the key pieces there is being able to correlate on the visual representation when you're seeing a spike to see trend lines that show you exactly what happened at that point in time. Maybe there was an upgrade in the environment. Maybe there was other factors that went in, and you can quickly be able to determine what those notations are all about and why you're seeing some of those spikes. And then probably lastly, and most importantly, is an entire rewrite of that robust tool that we call Quan. And we rewrote that in React. We're now supporting from a MongoDB side, the explain piece to be able to see the detail behind the queries there, more graphs that we are exposing, and an overall simplification of the user interface as a whole. So with that, I'll turn over to Steve to run the demo.
All right, bear with me as I attempt to switch my screen over. And the danger of a live demo here. Let's make sure, okie dokie, and resume. Brandon, just kind of give me the nod if I'm showing my demo environment.
Yep, we got it.
Awesome. I will move it over to this screen, so I'm kind of, nope, can't do that. So I'm not going to be looking at you while I'm talking through this. So first and foremost, I'm not going to go through the list the same order that Brandon kind of highlighted them, just because, well, it makes it a little clunky to demo it that way. So I'm only going to talk about the MongoDB exporter. I'm not really going to show anything. The key highlight there for the MongoDB exporter is it's dynamic. We don't have to release a new version as new metrics become available in future releases of Mongo. We've built it so that as it scrapes and it finds something new, it will pull it in. You'll automatically start benefiting from it. You can start creating your graphs should you get a hold of that data before we can release updated graphs to take advantage of it. So there are new metrics available in the new Mongo exporter, but I think that's the big highlight is as they come out, you're just going to be able to take advantage of them. So some of the places I want to really highlight, though, is we'll start with Security Threat Tool, just as a follow-on from our last Percona Live, where we unveiled the Security Threat Tool. And one of the things that we've introduced, and this is based on feedback, was being able to do a real-time run of checks and then being able to silence alerts. Those were two of the core or key asks from our user base of, look, I know this is broken and I'm going to fix it, but not now. I want to eliminate the noise. So let me silence that for some period. We default it to 24 hours. But it's just a quick demo of that. I'm looking at my security alerts. You can see I've got 3 core alerts, and then one of them is I've got a user with a blank password in here. I can go ahead and disable that user or get that account fixed. But really what I want to do is just silence it so that it no longer appears for me. And what'll happen is that alert will silence itself for a period of 24 hours, and then it will come back up if I've yet to take action on it. I did just see the APIs demoed for me today, so I know this is on the forefront to coming out. I know I'm probably not supposed to be talking about the future, but what is about to come out is the list and then disable and enable checks. So in addition to this, right now we're running checks. You don't actually know which ones are running. You'll be able to pull up a complete list of all the checks you've pulled down from the Percona cloud, and you'll be able to see what's running, and then you can choose to disable the ones that you don't want to run, or if you decide later on you want to enable it, you'll have that capability. So I've seen the APIs, they do exist, and then we'll be building the user interface to that forthcoming. The next place I'm going to jump into, and I'm going to get a little bit of load going on this system so that it makes our demo that much more purposeful. We're going to come in and take a look at our Postgres instance summary with a really cool tool that, as a former systems administrator, man, this is the thing that I got bugged with all the time. I loved graphs. I would always put these up on the board so that people can kind of see what the state of things are in the business. Let's get our resolution up a little bit so you can see some activity here. And so, we would run these demos in the building, and someone would come up and inevitably ask me, what is going on? So I'm just gonna, hey, I got a call. We want to do a quick load test. And so I'm gonna grab a snippet here, and we're gonna paste this in. And so while that's running, what you're going to notice is, one of the commands that I passed in to begin with was a PMM admin annotate command. This is something you can incorporate in with your CI/CD environment as part of your build scripts, as part of your normal course of business. And what's going to allow you to do is create some clear markers in the application that something happened. And so when people would walk by our desk and say, oh my gosh, what's that spike on the graph? We would all look at it and, of course, distracted, panic, and not know what it is. We can hover over it now, and you can see benchmark started, 2 clients, 10,000 transactions attached to that service. There are all kinds of permutations and combinations that you can put annotations with. You can do it per service, per node. You can do a combination of service and node. You can do your entire fleet of systems. You can do only particular labels. Annotations is incredibly powerful. And you can see with my little script, I had it both at the start and at the end. So I'm able to see when the benchmark started, when the benchmark ended, and you can see my load pretty much corresponds to it, save for a little bit of trailing load. Now, with that, I want to jump over to our query analytics tool. Query analytics, as Brandon mentioned earlier, really got its core in MySQL. Obviously, that's where the core expertise came from, but that's not who Percona is exclusively anymore. We continue to iterate on making MongoDB and Postgres equally as robust in terms of information. It was funny, one of the previous talks, one of the last slides, point number 6 said, talking about query level performance, right? That's one of the things you need to pay attention to, not just the overall system profile, but information at the query level. That's really been our focus. And so with both a combination of query analytics and the tech preview of PG Stat Monitor, you're going to see that we've gone even deeper into that. So, my little dummy system, my little test system that I've got there, I've set up some transactions on here. And what you can see now is query level detail, both at the system CPU time and user CPU time. And that's going to help you make determinations on, are these things running at the Postgres level, or are they based on your query? That is powerful. The other big thing to call out is we've added this through PG Stat Monitor, the ability to filter based on IP. I've only got one client running, so you're only getting one IP return. But if you had a fleet of application servers throwing load at your system and one of them runs away, you can filter exclusively by that. Whole bunch of other features going into PG Stat Monitor. I'm not going to spoil it now. There's a much more in-depth talk. I believe it's 11 o'clock Eastern tonight, and that's being done by a combination of the engineer who built the PG Stat Monitor tool, as well as the engineer on my team who built our integration with it. So I'm not going to steal his thunder. You'll just have to stay tuned. And the last thing I want to take a quick tour around is the query analytics. Brandon mentioned we rewrote it. This was no small feat. We did so because we didn't like the old interface. We were restricted in the Angular world. It did not allow us to create the features that people were requesting just because of the limitations that come to us from Grafana, which is the core interface we use for graphing. But now we've gotten rid of some of those constraints. And what you're seeing is, our all new query analytics. Number one, I'm going to point out the spark lines. And you can see when I highlight, I get indication on all the graphs exactly what we're looking at. So I can do line by line comparison because, the thing that's spiked isn't always the root cause. And so I can see what else is going on at the same time. Another highlight here, and I love this one, is the search by. So if I want to find any queries that have executed with the word orders in it, well, that's a bad word. Let's try something more generic like select. So I can get out all my select queries. If I want to be, more granular and I want to see my wheres, again, I can get all the queries that have where clauses to them. So, this is just helping you find the information that matters a little bit faster. Another piece, and I think the last piece I'll talk about before I get yanked off stage, something that we've been asked for is, I see this information. I want to see what's happening on the node. So we've given this new little graph icon, which allows you to either click on for service name or node name, and it'll actually take you directly to the node stats so that you can zoom in. And notice we open in a new window. So whatever filters, whatever date range or time ranges you have set, you don't lose any of that information. And again, that's based on feedback from users. There are so many more features. I know Brandon's got a list at the end. I love to talk about it, but I'm going to stop myself here because I could go on for the rest of Percona Live and then Bronwyn would chase me down. So with that, I am going to pause, get us back on our main presentation.
Yeah, so where I wanted
Brandon.
to pick up, thanks, Steve, appreciate it. Where I wanted to pick up is now talking about what's next. Learned a little bit more about what's new recently. What you're going to see from a functionality standpoint around what's next falls in the areas that we want to put forward in order to complete this life cycle and make sure that we have a full visioned tool through this overall life cycle. Historically, our strengths have been in monitor and in diagnose and troubleshoot. Those are the two areas that, from the outset of PMM, that's where our focus was. That left gaps around alerting, optimize, and manage. Today in the platform, you have that ability to do alerting through third-party integration with both Grafana and Alert Manager. Coming out later this quarter, in Q4, you're going to see a functionality that we're calling integrated alerting, which is building in alerting capabilities directly within PMM itself, so that you don't have to go out to a third party and then bring that in. So that's one of the key first elements. And then optimize and manage are those two other areas that we feel are going to help close the gap and get to completeness. So yeah, that's okay. Steve, you can move on to the next. Sorry. So those are the main pieces from a functionality standpoint, and I'll drill inside of that optimize and manage here in just a little bit further. But before I go there, I also wanted to talk about architectural gaps or infrastructure. And there's three main areas that we intend to fill within the next number of quarters as well. First, that starts around Kubernetes. I think you've seen through a number of sessions that have already happened today, the drive toward Kubernetes, and certainly from a Percona standpoint, we think highly from that standpoint as well. And so being able to run PMM inside of a Kubernetes cluster, key architectural component there. And then a second is around kind of the infrastructure of high availability or HA, as well as disaster recovery. And so those are the three areas when we're talking architecturally where we'll bring the product over the next number of quarters. And then from a functionality standpoint, I mentioned top level, these three areas of alert, optimize, and manage. Breaking that down a little bit, I want to put some meat on the bones behind that. We're looking first at an initial focus must-haves of these 5 elements. And by the middle of next year, middle of 2021, we expect to have a nice set of functionality around these 5 elements, from alerting to inventory management and configuration management, backup and restore, and maintenance. And so those capabilities there that allow you to both find the issue on a more appropriate basis, but then also remedy both the issue in the short term so that you get the environment back to that steady state, but also try to take those commands to be able to get the issue out of the environment for the long term. And then as we move beyond kind of the middle of next year, where we're heading is also closing gaps around these other management and optimized capabilities, from database creation through indexing and logging as well. And so this is the key focus for our team. The last thing I'll just end with, and Steve mentioned this in his introduction, is that the platform team is comprised of PMM functionality, but also this new software platform that we're coming out with that we're calling Enterprise Platform. And so you've seen, go ahead, Steve, you've seen this diagram from the very first keynote this morning. Our team is going to be focusing around building out the functionality of the deploy and operate from a DBaaS perspective, and embedding that within what we're calling Customer Portal to be able to deliver all of the information needed from both from access to this functionality to all information about your support tickets and trainings and subscription information. We have just a plethora of exciting functionality that's coming out through that enterprise platform. So that's where our PMM and platform team is aiming to focus. And we look forward to getting your feedback from here, just any questions that we might be able to address. And then also, as Bronwyn had recommended before, please go visit the feedback page to be able to rate our session and give us, what you want to see in the future. Michael, did any questions come through?
We had a couple come through. One of them was asking about alerting. I wondered if maybe you could talk a little bit about that and how it can be integrated with some different alerting platforms, such as PagerDuty or some others.
Absolutely, Steve. I can take a first stab at it. You know what, we're definitely looking from a communication channel to be able to deliver those alerts to all of the leading channels that you'd expect: PagerDuty, Slack, and then obviously the email and SMS and phone tree type of pieces there as well. You know, any communication channel that you're utilizing today with a tool like Alert Manager, you'd expect to bring those in over the longer term with alerting internal to PMM as well.
Okay, thank you, Brandon.
Sure.
Okay, we're just a couple of minutes over the end of this talk, so I want to say first thanks to both Brandon and Steve. And absolutely. I wanted to say thanks for the demo, Steve. I know those can be a little stressful in the heat of the moment. I'm glad your hockey playing is better than your demoing. I'm just kidding. I'm just kidding. Yeah. Okay. Thanks, guys, for your time.
Cheers.
Thanks, everybody. Bye.
And joining us now from Alibaba, I'm going to try my best. I've been practicing all day on how to pronounce this Norwegian name. Øystein Gravlen, welcome
very good.
to Percona Live.
Thank you.
Please take it away.
Okay, so let's see, I will share my screen first. So you see it?
Yes.
Okay. Okay, yeah, so my name is Øystein Gravlen, and I work on Alibaba's PolarDB, which is based on MySQL. I used to work in the MySQL optimizer team for 10 years. So my talk today is about analytical queries in MySQL. I will present some results from comparing MySQL with MariaDB and Postgres, discuss some special issues with disk-bound queries, and show some ways you can improve the execution of complex queries in MySQL. I will also discuss a hash join, which is a recent feature of MySQL, and then I will conclude with a discussion on how MySQL could be improved to support analytical queries. There's a lot of material in this presentation for 30 minutes, so I will not be able to go into all the details on the slides. So feel free to contact me in the Slack channel afterwards if you have questions. So MySQL's sweet spot had traditionally been online transaction processing, and it became popular because it could support a very high transaction throughput for web application. But if you want to do serious analytical processing, you will often export the data from your OLTP system to another data store that is specialized for this purpose. And many of those systems today, like for example, Snowflake, is based on a column store technology. However, there are quite a few users who want to avoid dealing with another system and rather run a few analytical queries on their OLTP system. And this presentation is for those users. In later years, people have started to talk about a hybrid system categorized as HTAP, where a row store and a column store are tightly integrated into the same systems. For example, MariaDB column store or MySQL analytics service. But I will not discuss those in this presentation. To evaluate the performance of analytical queries, the TPC organization has specified two benchmarks with decision support queries. In this presentation, we will focus on the TPC-H, which has 22 complex queries for a pretty simple schema with uniform data distribution. There is also a newer benchmark, TPC-DS, which have many more queries and a more complex schema. But the TPC-H has more than enough issues for us to discuss in this presentation. dbt3 is an open source implementation of TPC-H. It implements the three tests specified by TPC-H, but in this presentation, we will only look at the execution time for individual queries. Unfortunately, the implementation does not always follow the TPC specification. For example, the specification only allows indexes on form keys and date columns, while the Postgres implementation adds a lot of special specialized indexes that are targeted towards specific queries. Adding that many indexes to an OLTP system is not a very good idea, since it will reduce the performance of insert, update, and delete operations. I've also seen comparisons with MySQL from vendors of column store systems that compare MySQL with the MySQL where no indexes are created at all. And I don't think that is very useful either. So here we take the middle way and we use the TPC specification with respect to indexes. So here's an overview of the TPCH schema. It is a database for ordering in parts. There are suppliers that supply parts and customers that may order multiple parts in each order. And the scale factor determines the database size. And for scale factor 1, there's 1 gigabyte of raw data. So here are the results from running 22 TPCH queries with scale factor 10 databases for MySQL 5.7, MySQL 8, MariaDB 10.5, and Postgres version 13. So to be able to present it all in one diagram, I have scaled the results so that the execution time for MySQL 5.7 is always set to 1. We do not have time to go into all the details here, but you see that MariaDB is significantly slower for 5 queries. And the common reason seems to be that less efficient join orders are used for those queries. At the same time, we see that MariaDB is faster than MySQL for 12 of the 22 queries. If you zoom in a bit, we clearly see that Postgres is the overall winner here. It is fastest for 15 queries and often more than 50% faster than the others. And I do not claim to be a Postgres expert, so there's probably ways to improve the performance even further. So note also that for MariaDB, I did not turn on optimizer features that are not on by default, so there might be room for improvements there too. So some details of the configuration. We used a 32 gigabyte buffer pool, and then indexes and everything, the database size for MySQL and MariaDB is around 20 gigabyte. So all the data fit in memory. We also bound the server processes to one specific socket, so we should not get any NUMA effects here. And I tried to make the working memory for each query about the same in all systems. So for MySQL and MariaDB, we turned off the adaptive hash index, since it often gives unstable performance. And also to have any effect, we would have to run the same data pages has to be accessed many times. That is not necessarily common for the types of query we are running here. We have also turned off parallel execution in Postgres. And for more details, you can see the link here, which will show the test script used, the config files, and the results from the tests. If you compare 5.7 and 8.0 MySQL, we see that there's a few queries where 8.0 is slower, but also several where it's faster. And we will take a closer look at these queries. Starting with the good news first. So query 21, it's improved by 89% since the optimizer now uses information from InnoDB about whether the data is in memory or on disk to pick a better join order. And this query also benefits from the newly added transformation from exists to in, which means that semi-join may be used. So the total improvement is 90%. Semi-join will also be used for query 4 for the same reason. For query 15, I've rewritten the query to use a common table expression instead of a view. This is an approved variant by TPCC, and the execution time is cut in half since the materialization of the CTE can be reused. So we will no longer do 2 materialization of the same query. There are 2 queries, 10 and 11, that benefits from using the new temp table engine. This engine is not necessarily faster, but all queries share a 1 gigabyte memory buffer, while for the old memory engine, by default, only used 16 megabyte per temporary table before it moved the data to disk. And for query 18, we haven't really found out why it's better. Maybe it has benefited from the new iterator-based execution framework in MySQL 8. For the slower queries, query 6 and query 20 have query plans that are not as good as in 5.7. And we will look closer at these queries in just a moment. Query 19 does a lot of string comparisons. So the switch from Latin 1 in 5.7 to UTF-8 hurts this query. But if you change to use Latin 1 in 8, the performance is comparable to 5.7. And if you use UTF-8 in both, MySQL 8 should be faster, since its new UTF-8 MB4 collations are much more efficient than the old collations. Query 16 has a new query plan that uses anti-join, but that is not the reason for its slowdown, since the old plan is even slower in 8. Okay, so far we shown results from running with all data in memory, and we will discuss issues related to disk-bound queries now. So we are using a pretty fast SSD disk with an NVMe interface. And we use a buffer pool of only 1 GB so that most data will have to be fetched from disk. It is important to use ODirect in this case, otherwise the data will be cached in the file system buffer. My machine has 256 GB of memory, so I would have to have several terabytes of data to simulate a disk-bound system without using ODirect. And the results will probably not be finished for this presentation. So Postgres does not support ODirect, so this experiment does not really make sense for Postgres. I have seen many presentations where they use the first query after startport to represent the disk-bound load. That is not very useful because, as we will see, one of the main characteristics of a disk-bound query is that the same page may have to be read from disk multiple times. So since it may have been evicted from the buffer pool between the accesses. I set the InnoDB all blocks time to 0 since the default setting have shown to give large variations in the execution times. Also for the disk-bound load, we should turn on batch key access for BKA. And since the cost function for BKA is not working very well, we will turn it off and always use BKA for disk-bound load. And BKA will use the join buffer, and we have set that to 64 megabyte. BKA is used for index nested loop joins. We fill up our join buffer with the keys from the first table. Then these keys will be used for lookup in the index of the next table. And the primary keys of the matching rows are stored in a new join buffer, which are then sorted in primary key order before accessing the second table. This way, we will read all the rows from the same page at once, and we do not risk that the page is ejected from the buffer pool between accesses. If the join buffer cannot hold all the keys, we will have to repeat the process, fill up the join buffer again, sort the keys, do another scan, and so on until we have processed all the rows. We will look at the effects of BKA if you have for TPCH query 13. If you turn on the BKA by setting the optimizer switch, as we mentioned on the previous slide, we see that explain indicates that BKA will be used. To investigate the effects of BKA, we use the file summary by event name table in performance schema and look at statistics for accesses to the InnoDB tables. We see that without BKA, we read more than 10 times as many pages as with BKA. Also, the average I/O read latency is much lower with BKA. I think part of the reason is probably that InnoDB will do pre-fetching of pages when it detects that the pages are read in sequence. So there are 10 TPCH queries which will use BKA, and for 3 of them, including query 13, the query response time is reduced by over 90%. 3 more queries are reduced by 50 to 85%, while the shortest running queries see no significant improvement. how big a benefit we will get from BKA will depend on the size of the joint buffer. For query 13, we see that you will get most of the improvement if you have a joint buffer of only 8 megabytes, but you can still cut the execution time by almost a half by going from 8 to 64 megabytes. And note also that if the joint buffer is very small, the BKA can have a negative effect on the response time. Okay, so now we will look at how you can improve performance of some of these complex queries. One way to improve the performance is to use optimizer hints to make the optimizer pick a big different query plan, and we will show some examples of that. And they've already seen examples of how we can set parameters like the buffer pool size and the joint buffer pool size to improve the query performance. And we can improve the statistics so that the optimizer makes better decisions. Sometimes we can rewrite the queries so they will be executed more efficiently. And we can create, of course, new indexes that can speed up queries. However, in order to use hash join currently in MySQL, you may actually need to hide indexes, and we will get back to that. So remember that we had some queries that were slower in 8 than in 5.7. One of them was query 6. And the reason it's slower is because it's using our index range scan instead of a full table scan. As we see from the graph, index range scan is faster than the table scan if the range is small. In this case, the tipping point is when the date range is larger than 7 months, which is around 8% of the total table size. However, we see that the optimizer prefers index range scans up to just about 12 months. And since the range for query 6 is 1 year, we see that a very little change in the estimates could cause the query to run 40% faster or slower. But by adding an index hint to tell the optimizer to ignore the index for this query, we see that we can actually get query 6 to perform better in 8.0 than it did in 5.7. For query 20, which was almost 3 times slower in 8 than in 5.7, the problem is that the optimizer picks an inefficient join order. The root cause of the problem is that we do not have any good estimates of the filtering facts of the predicate on P name, since the histogram implementation does not support estimates for like prefixes. And what makes that even worse is that the cost of subqueries are not considered. So the cost of picking a join order where the subquery is executed before the filtering of parts is greatly underestimated by the query optimizer. If you look at the query plans, we see that in 5.7, parts comes before parts up, while in MySQL 8, the order is reversed. And we also see that the filtering estimate for part is 11%, while in real life it's close to 1%. So we can fix the performance on query 20 by adding a join order hint that tells the optimizer that parts should come before parts up. And we see that the result is an execution time that is slow. It's lower than for 5.7. Another way to improve query performance is to ensure that the statistics used by the optimizer is accurate. And InnoDB maintains statistics on the number of distinct values for indexed columns. However, the default sampling rate is very low and can be significantly increased without much effects on performance. For my test, I actually set it higher than the number of pages in the largest table, which was a bit more than 500,000. So that analyzed table will read all pages. And it still took less than 5 minutes to do all the tables. However, if you set it this high, you may consider to turn off the automatic recalculation and schedule your analyzed table manually so you do not get surprises to concurrent load when the automatic recalculations are performed. Note also that much of this index statistics change pretty slowly. statistics like number of orders per day and items per order are pretty stable. So you don't really need to run analyze table that often. For MySQL 8, I recommend adding histograms on all columns that are used in conditions, especially if you're not the first column of an index. Since the data distribution for TPCH is mostly uniform, I did not change the default settings, but for non-uniform data, one may consider increasing the amount of memory used when creating histograms to get increased sample rate. Some histograms may need frequent updates to be accurate. For example, if you do not update histograms on a date column daily, the estimates for a number of recent events may be far off. Other columns, like for example order status, will probably not have probably be pretty stable, so you will not need that frequent updates. A few words on the statistics for MariaDB and Postgres. For MariaDB, the index statistics is similar to MySQL. While the histograms are on by default and are automatically generated when you run analyze table. For Postgres, I use the default settings. I experimented with increasing the default statistics target, and I got a lot of new query plans, but they did not, on average, improve anything. And there's also more advanced statistics that are in Postgres that I did not enable. You can also get better performance by rewriting your queries. In recent version, MySQL has added some rewrites automatically. And MySQL 8 has introduced several new variants of automatic transformation that you may do manually if you don't use older versions of MySQL. And I have earlier blogged about a few ways to rewrite your queries. So today I will focus on how window functions can be used to improve performance. A few queries in the TPCH use a pattern like what we see here for TPCH query 17. We used a non-correlated subquery to compute some results, and then the main query will compare with this result. For query 17, we will compute the average quantity ordered for some type of parts, and then we will find the orders with less than 20% of the average quantity. This way, the query will have to read the line item table twice. But if we use window functions, we can both compute the average and find the price for relevant parts in the same scan. So we are using a CTE for this here, but you could, of course, use a derived table instead. So here we say the results for the TPCH queries that may be rewritten to use a window function. So you see the mileage does vary here. For query 17, the execution time is reduced by 80% from 6.5 to 1.3 seconds. And the savings will depend on how large part of the total work is saved by avoiding the extra tables. So for query 15, there is no savings since, as we already discussed, we have avoided the double table access by using a CTE instead of a view. So the next topic is hash join, which has been introduced in MySQL 8. But unfortunately, hash join will never be used if it's possible to use an index for nested loops join. So in order to use hash join, we will have to hide the index from the optimizer. And for that, we can use an index hint, like in this example for query 13. So if we compare the result of hash join with the results from using BK that we presented earlier, we see that the execution time is reduced by almost 2/3 in the disk-bound case. Notice also that the in-memory is not much faster than disk-bound. And this shows that the disk-based table scan is really fast, and it is the join processing that actually is the limiting factor in this case. So when should we use hash join? So this shows one example where we are running a simple two-table join where we vary the selectivity of the first table. The curves are very similar to the ones I showed earlier for index versus table scan. and for low selectivity factors, nested loop join is best. While for high selectivity factors, one should use hash join. And note that the performance of hash join depends on the size of the join buffer. And in this result, we use the join buffer of 2 GB so that the entire hash table fits in the join buffer. Also, the crossing point here between when to use hash join or not will depend significantly depending on the type of tables involved. So it could be at 10% or always be better to use hash join and so on. But if we use lower buffer sizes, we see that the performance varies. If the join buffer is almost large enough, like the 512 megabyte case, the performance is a bit unstable. According to the response I got on a bug I filed, this will be fixed in 8.0.23. We see that we can still get pretty good performance with a join buffer of 64 megabyte. However, if the join buffer is too small, like 4 megabyte, we hit the limit on the number of files that hash join may use. And then each chunk file will be too big for the join buffer, and it will have to be partitioned. And this means that each chunk file for the probe input will have to be processed multiple times. In order to know how much memory is needed, we can check the memory summary table in the performance schema for the hash join event. If the total number of allocation is greater than the high water mark for unfreed allocation, we know that the hybrid hash join has been used. If the numbers are equal, in-memory hash join was used. And we can also see the total amount of memory used and the maximum size used for the join buffer. Okay, so to conclude my presentation, I will talk a little bit about what feature could be implemented to better support analytical queries. One great thing would be support for parallel queries. And in Alibaba, we actually have implemented parallel query for our MySQL-based PolarDB. The query operations can be partitioned across many workers, and the gather operator will combine the results before sending it to the client. This shows how much we are able to reduce the execution time for TPCH queries when running on a machine with 32 physical cores. For most of the query, we see more than a 16 times improvement. There are a few queries that does not scale that well, and these queries requires multiple gather operators to be efficient, and we are working on supporting that. So there are two main reasons why Postgres is faster than MySQL. One is that hash join is used, and the other one is that nested loop joins are more efficient than using heap-based tables. So it would be good to have support for heap-based tables in InnoDB too. And for hash join, in PolarDB, we have modified the MySQL optimizer to take hash join into account. Or at least it would be good to have an optimizer hint that we could use to force hash join without having to hide the indexes. So that was my talk. Thank you for listening. And now it's time to contact me in the Slack channel if you have questions about the talk.
Thank you very much for that presentation. I enjoyed it very much, and I wanted to just maybe bring up one question. A couple times you had mentioned derived tables during the talk. I wondered if you could just maybe clarify for the audience what is meant by derived table.
Yeah, so derived table, that's a subquery in the from clause. So that query represents a temporary table in the query, you can say.
Okay, thank you very much. Well, thanks again for the talk today, and we'll be handing it over to our next presenter, host, and his name is Tim Sharp. Tim, are you with us?
Thank you, Michael, and welcome everybody. Welcome from sunny British Columbia, Canada. My name is Tim Sharp, and I'm a product manager at Percona for Global Services. Our next speaker is Sveta Smirnova. Sveta is a principal support escalation specialist at Percona and has over 10 years experience in the industry. Her passions include problem solving and teaches others how to effectively deal with MySQL issues, bugs, and gotchas. She's also the author of MySQL Troubleshooting, What to Do When Queries Don't Work, which is part of the O'Reilly Technical Publications. Saveta's talk today is how to avoid pitfalls and schema upgrades with Percona XtraDB cluster. So let me pass this on to Saveta. Saveta, are you available?
Yes, thank you, Tim. Hi, everyone. Let me check. It should be recording in case if my connection would not work.
Yes, we have a recording set up.
Okay, thank you, Bronwyn. And I am here available. I am available on Percona Live ONLINE Slack channel for any questions which you have. And I hope we will have time for me to answer questions in voice.
Okay, Sveta, just bear with us for a minute. It's just we'll have to pull up your recording.
And Bronwyn, when you are searching for recording, I assume that question should be at the MySQL chat. Is this correct?
Yeah, or in the general chat is fine too. Yeah.
Yeah. Okay. Thank you.
Okay, I'll go ahead and share this now.
Hi everyone, welcome to Percona Live ONLINE, and today we are going to talk about Percona XtraDB cluster and challenges which you can meet when you decide to change schema definitions or update schema definitions while running this cluster setup. Let me start screen share and show you my slides. We will talk about how to avoid pitfalls in schema upgrade when using Percona XtraDB cluster. Idea of this topic started when I worked on a real support user case, and practically, actually, then once I found created some content like this, I found I reuse it quite often because users often has some surprises when are doing schema upgrades. It means like kind of alter table or kind of table definitions while using Percona XtraDB cluster. And who am I? I'm a MySQL support engineer with more than 10 years of experience. I'm author of book MySQL Troubleshooting. I have a few hobby projects on GitHub. I'm a frequent speaker at various conferences. And again, as I told you, like this idea of this talk was something which raised by my customers, users of Percona software. And Percona XtraDB cluster, as well as other Galera clusters, support two methods of making schema upgrades. It's TOI, which can be decrypted as total order of isolation, and also RSU is rolling schema upgrade, which allows you to upgrade each of nodes one by one. They have own advantages and disadvantages, and also they have own surprises. And there is a tool from Percona Toolkit called PT Online Schema Change, which can help you to perform schema upgrade, but again, this is not a silver bullet, and we will discuss why. First, let me remind you how Galera replication library works. It's by default, MySQL provides asynchronous replication. That means when you have updates on the source server and replicate it to another one, this source server doesn't know if replica applied any updates, And you may end up with a situation that you have updates only data only on one server, and all replicas have outdated information. That's why there is a need for having synchronous replication for MySQL. That means when you can be sure that all of nodes in the cluster have the same data. For this purpose, exist Galera clusters, and that means clusters which use Galera library. This include Percona product. It's Percona ExtraDB cluster, which is Percona server plus Galera library plus Percona improvements. This is MariaDB Galera cluster, which is MariaDB server plus Galera library plus MariaDB improvements. And Galera cluster for MySQL. This is Galera cluster, and which is uses MySQL server as its companion and counterpart. On the left, you may see there are QR code. There are working QR code. After the conference, slides will be available online, and you may, it's actually, there are active links, and you can click on them and go to the documentation. But if you want to check documentation now, you can just use QR codes and access to these additional details without waiting. So how Galera library works? It's like, assume we have like kind of standard setup of having a cluster with 3 nodes. And when data modification happens on a node, there happens optimistic locking control, which doesn't mean. It means that while a transaction is in progress, its all writes are applied locally. It's exactly the same as on for standalone server. So it's like Galera library works with InnoDB. It's exactly the same as you are performing InnoDB transaction or a standalone local server. But at the commit time, that's not which actually executed all local transaction changes. It waits, and it broadcasts write set for the rest of the cluster, and it waits confirmation on successful updates from all nodes. And once it receives a confirmation, it commits transactions locally, and if not, it rolls back transaction. So that means so data updates are absolutely safe. They are committed on all of the nodes, or they are not committed at all. But DDL introduces challenges. So why they do introduce challenges? DDL is like MySQL is layered architecture, and all changes of table definitions, they are independent from storage engine. They are executed by different part of code, and they are replicated independently from the storage engine. That also means that changes may affect query results, like, for example, when you add or remove unique keys or columns or change column definitions, you may probably run same query, and this query will return different results, or maybe error out, or maybe insert some data differently. Modification since replication of changes to table definitions, it happens independently from InnoDB. This modification can happen on any node, and if data modification statement like update or delete comes in, schema must be upgraded before that change came in. And also, that's what's the challenges. There is no way to roll back schema upgrade. Like if you did a mistake, you cannot just roll back, or if there is error, you will have not an inconsistent state. Like on standalone server, there are metadata logs which prevent the first alter table to run while some table accesses happen. And at the second, they prevent to access the table in case if it's altered. But this metadata log can set only on one node. They cannot be distributed across the cluster, and they cannot be set for the whole cluster. So that's for Galera library, it's additional control is required. And to solve these challenges, there are two methods to perform schema upgrades. In one, and first one is default. It's called total order is isolation. It's the safest method for do it. So what is the total order of isolation? At first, it's DDL changes are replicated in the same order regarding other transactions, and all nodes are in absolutely same state at any point of time. It's less illustrated on for 3 nodes cluster. We have node A, B, and C, and they have initial state. I put here its numbers. Its numbers, let's consider here it's when these statements came in first. So first one came select statement on node C. Second statement want update on node B. Then node A received a third update and finally alter. And then some statements received node C and node B. So in the initial situation, when we received all these queries, what's happening? We have on node A, we are executing insert and update, and else has to wait. On node B, we are executing update and insert, but delete, which came after alter, it's wait, since then happens for update. On node C, we are executing select, which is with ID 100. Insert and update are waiting because they arrive it after alter. But select with ID 113 may be running or may wait. It's actually dependent from option and depending from load on node C. So by default, alter doesn't prevent select from running. In case if alter is in progress, you see like that's statements which were executing on the previous slide, they were gone. And now alter is running. On node B, all statements are waiting. On node C, all update statements are waiting. And select statement is maybe running or maybe waiting. It's dependent on load and options. And once alter is finished, all statements which are waiting there are started to execute. Let's see, it's like how it could be illustrated on process list. For this process list example, I had 3 nodes. One is data modification node, DML node, which executes only update statements like update, delete, and sort. Another one is select node, read node, which executes select statements. And third node is DDL node, which executes the schema modification. So for DML node, before alter is running, we are seeing like all updates are executing, and time is pretty small, is equal 1 or 0. That's mean a job is running on the server. Select is also executing on select node, and you see it's again time is 0 and something is running. Then on data definition change node, we are using to change definition of the table SB test. We are adding a key. This operation takes almost 4 minutes. And you are seeing what is the DDL, data modification changes while alter is running. We have to wait. You are seeing like altering table waits for 38 seconds, and all incoming data modification changes were still waiting. Select is can be executed, so that's running fine on select node. And once alter is finishes, it's also data modification can also finish. So what is advantages of total order of isolation? First is data is always consistent. It's dictionary modification applies to all nodes at the same time, so there is no failure can happen due to schema inconsistency, having you have same table definition in the beginning. But at the same time, that means the full cluster is blocked for the duration of the entire alter operation. So that means while you're running alter, you cannot modify any data on any node. And also one more disadvantage is that schema upgrades are replicated as a statement. So that means there is no guarantee that alter succeed. So that only means that each of the nodes receives the same alter statement. And if for some reason alter fails on one of nodes, like maybe due to out of space or for some other error, that means that you still have a chance to have clustering inconsistency. How to perform upgrade with total order of isolations? So first, schedule a maintenance window because it blocks all updates. Then run dictionary change operation. Cluster won't be accessible until it ends, until only for selects can continue. But if you are having option WSREP sync wait equals 1, selects also will wait. So when to use total order of isolation? First, it's for quick DDL operations like create database, create table, create some new objects, or maybe online operations which modify metadata only, such as rename index, rename table, drop index, and you will find full list on the link. Rolling schema upgrade was designed for a situation when total order of isolation can happen. What this means is like its name says, it's you can upgrade one node by one, while all rest of the cluster is still accessible and still can perform write operations. This method is controlled by variable WSREP OSU method. You can put it either to RSU or to TOI, which is TOI is default. In case if you are using it set to RSU, it puts in node into desynchronous state for the duration of DDL. It pauses Galera provider. So schema actually can get out of sync because you change table definition only on one node, and on other node table definition stays same. And also, like since Galera, Galera provider. To have quite big G cache. Otherwise, after alter table finishes, its SST may happen and you will lose all your changes. Also, your responsibility is to run alter on each node of the cluster. And if you forget it, some of nodes will have different table definition than the rest of the cluster. You need to block read-write access. That depends on the alter, because if it's if you don't block it, and if this update, this read-write access will be incompatible with new schema, you will have errors, and sometimes you may have even cluster errors. Which can lead to situation when node or maybe a full cluster will be put offline. You need to make sure that no write is performed to the table until upgrade finishes on all nodes. And if you fail to do something properly, your cluster may be unrecoverable and you will have to bootstrap it from scratch. So how rolling schema upgrade works? So first, user has to put session WS method to RSU. At the same time, node does nothing. It's just information. If DDL is coming, it's node checks if this variable set to RSU, and if it's set to RSU, it performs DDL. In case of any other statements, it behaves as usual. So how node internally executes schema change in RSU mode? First, it checks it does not have transaction is commit node. That means transactions which are finished all updates on this node and are committed changes to the rest of the cluster. And if yes, it waits for 5 milliseconds until you are using Percona XtraDB cluster. And for Percona XtraDB cluster, it conveys actually value of WSREP RSU commit timeout, which can be set to different value than 5 milliseconds. After that wait time, it's still some transaction in the commit mode exists. This cluster aborts DDL. And this is actually was my main trigger why I decided to make this talk, because one of disaster which I worked for as support engineer, it was a shop that's users just could not perform schema change because all their tries to alter a table failed with this timeout because they did not stop transactions which was completely unrelated to the table we wanted to change definition for. Okay, so once cluster finds that the node doesn't have transaction in commit mode, it puts node into desynchronous state, so it removes it from the cluster. Then it spouses this write set application, executes schema change, then brings node back to the cluster and synchronizes everything. So what you need to know about RSU, that's locking is not available. It updates to all objects on the node in RSU mode must finish before the operation. That means like if you are updating a table like kind of Percona Live ONLINE, that means even if you write to a completely unrelated table like past Percona Live or some like users table, it still affects and still cluster would not be able to run update until all this modification finish. And if it's could not finish in reasonable times, it just aborts this alter table command. So advantages of running schema aborts is cluster still remains functional. And you can schedule long-running alter in the best time possible, and you can just like do it, for example, like for one node and 1 a.m. and for second nodes and 2 a.m. and for first nodes at 3 a.m. and you can schedule it maybe it's day 1, day 2, day 3, and you can just you are very flexible with scheduling. But this has its price. Its main issue is that it doesn't check for data and schema consistency, and this is your responsibility. So like if you change something on one node and when you write on another node, when you access data on another node, and if it's write, for example, replicates to the change node, you may end up in situation when cluster will stop and one of nodes will be removed from the cluster, or maybe full cluster will be unfunctional. All writes must be stopped on the node which is running DDL operation on RSU, at least before it starts. It's actually like all writes which is coming before alter operation, they have to be stopped before alter operation starts. And once alter operation starts, you just cannot cannot write, you can again restart your application, but write just will wait until it finishes. Gcache must be big enough to hold changes while all the schema change is running, because if it is not big enough, it will cause SST and all schema changes will be lost. And any error which you are doing can make cluster dysfunctional, and you will have to bootstrap it. Affected table must be offline unless its schema compatible changes are adding secondary indexes, which is not unique. Otherwise, you may end up in situation when then update will update something which is not on the all nodes, and while it's updated, it's replicating, and its cluster will fail, and one or all nodes will be put offline. How to use RSU? So first, make sure that Gcache is big enough so it holds all updates while schema changes in progress. Then block all writes to the table schema on all the cluster nodes which you are going to change. Then choose upgrading node. Block all writes requests to this node. Set session method WSRep OSU method to RSU. Perform schema modification in the same session. Then set session method back to total order of isolation or just disconnect. And finally, re-enable writes. And once you're done, it means you upgraded one of nodes, and then you are ready to repeat for other nodes. So you see like two standard methods of changing schema. They have all advantages and disadvantages. Like maybe we would recommend use total order of isolation all the time, but since it's blocking, it's not always possible. And for the RISCO comes Percona Toolkit and its tool called PT Online Schema Change, which is a tool which performs non-blocking upgrades with total order of isolation. And how it works? It creates a copy of a table with altered definition, then creates triggers which will copy modified rows by changes in progress. Then it starts copying data in chunks, and you can control everything like size of chunks, which it can be paused or stopped. Like for cluster, there is a very useful option called max flow control, but there are few more, and you are very flexible when the tool can pause. And newly modified rows are copied using triggers, and so you would not lose all updates while the tool is running. And once the copy is completed, it drops the table and renames the copy into the original table name. So what is the advantages? So DDL is safe and not blocking. And also that's because actually it's DDL, it only happens in the end, then it drops all the table and renames a new table to the old table name. So this is very fast operation, and it can be safely used with total order of isolation. But disadvantages of the tool is that it works only with InnoDB tables. Since it's just copy the table, it increases I/O load, and if with alter you may run some operation in place without copying the table. With PT Online Schema Change, you cannot do it. If you have already existing triggers on tables, it may not work unless you are using Percona XtraDB cluster greater than version 5.7. Foreign keys updates are not effectively safe. PT Online Schema Change has a few open bug reports and few limitations, which just do not work with foreign key updates. So if you are using foreign keys updates, it's probably not the option not the option. It's not always the option. It's not for all the situation. It's the option for you to use. How to use PT Online Schema Change? So first, it studies its options, especially options which tells it when pause and stop copying operation. particularly for Galera clusters, use option max flow control. Set appropriate limits for your hardware. Make sure that WSREP OSU method is total order of isolation, because otherwise there is maybe it doesn't have all the advantages of this tool. And run PT online schema change. So to summarize this, which method to use and which method to use when you because all three methods have its own advantages and disadvantages. First, check if schema change will be fast. It's create database, create table, drop index, or any alter on small tables which just finish, if table has 10 rows or 100 rows, alter will finish very fast, and you should not care about the situation if you need to use rolling schema updates or PT online schema change. If yes, it's just use total order of isolation and just use alter command, because that would not affect your cluster operation. If no, evaluate if you can use PT online schema change, if it's in a DB table, if it's you are running Percona ExtraDB cluster 5.7, or table has no triggers. Table is not referenced by foreign key and doesn't have foreign keys. And if you can tolerate situation when table will be copied and you will have increased I/O activity. If yes, use PT online schema change. If not, if it's not possible, if above option is not possible, use rolling schema upgrade, but use it wisely, use it with knowledge, and prepare safety, make safe. It's stop all write traffic on the node which will run schema change. Stop all of the write traffic to the table you are going to modify on all the cluster, and make sure you upgrade on all the nodes. So conclusion is use total order of isolation whenever possible. If not possible, use PT online schema change, and last resort, use rolling schema upgrade. Here I put more information about links to the user manuals to tools we just discussed. And thank you. Slides will.
Thank you, Savannah. That was a great talk. Since we're running a little bit over time, we'll just do the question and answer period on Slack online. So hello from sunny British Columbia. If you've just joined us, my name is Tim Sharp, and I'm the product manager at Percona for Global Services. Our next speaker is Philip Kren. Over the past 10 years, Philip has worked as a web infrastructure and database engineer. However, his title is now developer advocate and community team lead at Elastic. Elastic is the company behind Elastic Stack, which consists of Elasticsearch, Kibana, Beats, and Logstash. Philip's talk will be from containers to Kubernetes operators. So let me pass it on to you, Philip.
Hi, thanks, Tim. So let me share my screen and let's get started. So let me just move this out of the way and we're ready to go. So, hi. Yeah, I'm based in Vienna. It's slightly past midnight, so I hope I have all the energy we need, but let's see. It's a great topic, so it should be good. From containers to Kubernetes operators, I'll skip over my further introduction because, well, I've already been introduced very well. I normally just say I'm a developer advocate, so I speak about the good stuff that we do at Elastic. So if you've never seen our stack, this is what it looks like. And while my examples will be about our stack, because that's the operator that I know best, it will generally apply to what lots of operators do in data stores, because I want to focus on what is important if you want to run a data store first on Docker and then potentially on Kubernetes as well. What are the different pieces that come into play and what is important there? So I will totally focus on Elasticsearch because that's where the state is, and state is always what makes your life much trickier than just the stateless components. So Normally, if I would do that in an in-person audience, I would just ask who is using containers, and I assume pretty much everybody would raise their hand. If you then ask like who is using containers in production, it's probably like half of those using containers in general. And then there's always the tricky question, who is actually using containers for stateful stuff like any data store, relational, non-relational, it doesn't really matter. As long as it keeps your data and you want to keep that data, they're all the same. And that's then even a smaller subset. And then the question is always why and how can we improve that, or is that okay anyway? If anybody is using our containers, let me know if you have any feedback or want to discuss any specifics afterwards. We're always happy, or I'm always happy to see people using our containers, but what I will tell you is pretty broadly applicable anyway. So what I generally want to cover is, we talk a bit about Docker images and why they're the foundation and why we built them in a specific way and how that influences like the rest of everything. We will more or less gloss over Docker Compose because I think it's mostly for demo setups nowadays, and we have mostly given up on providing any official solution around that. And then I will dive into Helm charts versus operators. Everything running on Kubernetes nowadays, those are probably the two most widely used approaches to actually run your workloads. So let's dive into that. So Docker, or actually, I think this would be the right image or logo for Docker in any case. And this is, by the way, also the size of your average Docker container nowadays. And ours are certainly no exception. So I think like the current Elasticsearch containers are somewhere around 750 megabytes or so, if I'm not mistaken, which is not exactly tiny. So yes, that is what you get as the Docker container. We have this internal saying from a colleague, it is from 2 years ago or so, that Docker is the world's most heavily funded college project, and stuff has improved since then. But this shows that stuff was not always as easy or smooth as you would want it. Like Docker was known to break APIs or break your stuff in various unexpected ways, or that the abstraction was not as strong and stuff would behave differently on Mac than it would on Linux, which people would not really expect probably. So that's where this came from, and that's maybe there's still some frustration left in that. But there's no way around containers. So we always refer to containers or Docker images as the new zip format. So when you were downloading software in the past, zip was kind of the ubiquitous way to get any piece of data or software. Nowadays, the most common approach for many people is to use a container. So obviously there is no way around it. As a company, do we have a strong preference for containers? Not really. It's just one of many ways. So if you prefer to have RPMs or depths or plain old TarGZ, or you're on Windows and want to use an MSI, or you want to use some automation with Ansible Chef or Puppet, those are all valid ways, and we don't really care. We try not to be super opinionated like how you should install and run our software, because you probably have a much bigger picture and it should just fit in with the rest. But we are definitely not trying to stand in your way. So if you say like, well, Docker or Kubernetes is the way we want to run stuff, then we will try to support that to the best that we can. So, but it's not without issues, especially around Docker. There are these things that people do wrong, and I sometimes call them fallacies that you run into again and again, and you need to kind of like reinforce the points to not do bad stuff. So root and don't care or not caring about permissions is one thing that we keep seeing every now and then, or basically Adam and Eve, like you could replace the snake with a whale, and this is what Docker has been doing the past few years. Maybe it's just run everything as root, don't care about permissions, and people were like, yes, we don't care anymore. If you've ever run Elasticsearch, maybe you know you cannot run Elasticsearch as root, just because we think that's a really bad practice for any server process. So if you would try to run Elasticsearch as root on Linux, the process would just system exit, and there is no way around that. There is no setting for that. The only way you could change that would be to fork the source code and comment out that system exit that we actually called there. But otherwise, there is no way around it. Though people have been requesting, let us run everything as root in Docker times and times again, though for us, that is not really an option. The other thing that we are also pretty picky about is like you should have the right users and groups to run everything, and not just change mod 777 over everything and not caring about how permissions are set up. So we expect a specific user and group ID that our data is being written, which then creates these lovely issues every now and then, and you don't need to read it all. The relevant section here is when people say like, I prefer simple fire and forget Docker containers, which I always picture something like this that you want to do with your data. It's pretty much this approach, where you really don't care what happens to your data. And we strongly disagree with that, because the images that we build are made for production, and production is the main use case. Of course, you will use them for testing, but like most of the decisions should be influenced by production. So avoid stupid stuff so you don't suffer in production later on, or maybe make it slightly harder upfront so you don't have the problems later on that you don't want to have. So that is where we are coming from. That production is kind of like the main focus, and this YOLO fire and forget approach is definitely not in like the intention of how we're building images. Also, something that we see every now and then there is, if you do not understand Unix, like permissions, for example, you're kind of like condemned to reinvent that approach poorly or fight them forever. So that's something we see. People say like, oh, just use Docker. You don't need to know anything about Linux or file permissions anymore, which is not really true, unfortunately. Another fallacy that we see quite frequently is latest. And that is unfortunately kind of like heavily reinforced by Docker Hub itself. So for example, if you go to the official Elasticsearch image on Docker Hub, also official is always kind of tricky, because initially it was actually provided by Docker Inc. and not by Elastic, the makers of the software. So official was always kind of tricky, but you can take ownership over those official images. So for example, if you do Docker pull Elasticsearch, you will get the image from us, except that this command here that is being referenced does not work, because we don't have latest. Because we think that latest is a really bad idea for any external dependency, and especially a data store. Let's assume you set up an Elasticsearch cluster with 3 nodes today, and that works. And then in a year or so, you need to scale it up, and you need to add 2 more nodes. And again, you add 2 more nodes, and you're using latest, just with the cluster that you have set up like a year before. And then the major version might be a different one. And then that might just break your cluster in production. And then people will come to us to complain heavily. And that's why we don't support this. And unfortunately, Docker Hub always shows this implicit latest here by not having a version number. We would love to have the latest version number here, so anybody who copies this command will just get the latest image. But you'd actually need to copy this, and then you need to look up which tags do we provide, because we don't have latest, because we think it's a really bad idea. So there's no way around that, unfortunately. Sometimes people say, okay, we get the major version. What if you pin the image that you get to the major version? Like currently we're at 7 or 7.9. Why can't you not say, I just want the latest version within 7? Should be the same major version number, so it shouldn't break anything. Unfortunately, it's not that easy the way that data is written. If you write data on one Elasticsearch node and it might have a newer version than another one, the data might not want to migrate to that older version. And then you might create imbalanced clusters, and it might just fall over unexpectedly again. So neither one of these approaches is supported. You will really need to pick the minor and patch level version for all your images. It's a bit more pain or work up front, but it will make your life much easier later on if all the nodes are running the exact same version, and then you can just move all of them to the whatever other version you want to run. So we are strictly enforcing that versioning. Another thing we see every now and then is runtime mutation, that people just want to update stuff as they go along. Sometimes like you provide a shell script and it will automatically be run when you do that. Or you just provide an environment variable with, I don't know, additional packages to install or whatever. For whatever reason, people want that. But there are feature requests for that. We also don't support that because obviously the right approach for Docker should be that images are immutable. So obviously what you would want to do is you have a custom Docker file, you take whatever base image that you have, and then you install a plugin. And we don't want to run that ad hoc on different nodes. And then, I don't know, on one, the internet connection fails, or it just gets an error when it tries to fetch a dependency. And then you might run different versions of the base image. You want to have exactly the same image everywhere. So they're the same and you don't break your data in any unexpected way. And this is also the right way how Docker would run that. And for example, the only thing that you don't want to have baked into those images are anything around certificates and secrets. So dependencies and versions should all be baked into the image and final and never change. Other stuff that has a different lifecycle, you want to keep separate. So for example, if my TLS certificate expires, I don't want to necessarily rotate my image. I just want to replace the TLS certificate. If I need to rotate a password in a key store, I just want to rotate that key store and not the entire image. So for that, this example here just shows how you would generate a new Elasticsearch key store, and then afterwards you could mount that, for example, in Docker Compose here, but Kubernetes can do that as well. So here we would just mount that secret, so your version is totally independent from the secrets that you have, because they just have different life cycles and you don't necessarily want to rotate them at the same time. Another thing that we see every now and then is that people have very strong opinions about base images. We started off for Elasticsearch with Alpine, but ran into various bugs. Admittedly, it was like 3 to 4 years ago, and probably Alpine has progressed further since then. And MuCL is much nicer probably than glibc, but in our experience, glibc is just extremely battle tested. So we ran into various weird situations, like some bug that was only triggered if you had 4 layers or more and was only happening on Windows or so. Things that you really did not want to debug. We ran into those with Alpine a couple of times, and that's why we standardized on having CentOS images for everything. Because CentOS supports everything that we need in our stack, like we have Node and JRuby and Java, and we have a C++ piece for machine learning in there. And all of those were already built to run well on CentOS, and it's also kind of like the most widely used standard in operating systems that we encounter as a company. So that's why we standardized on CentOS by now 7 for all our images. It's nice because all our images use the same base and they just share the same base layer, even though it's not exactly small. CentOS 7 is pretty widely used, so probably you already have it and you don't need to fetch it every single time you need to fetch one of our dependencies. Also, the JVM is pretty large, and for Elasticsearch, we want to have the JVM. So if you have a very small base image or not, doesn't really make much difference, because the JVM plus our software on top will create a rather large image anyway. And like I said, glibc is just pretty well battle tested. The main downside is size. However, in our opinion, especially for production again, if you have 100 gigs of data in Elasticsearch on a node, you don't really care if you save 100 megabytes of base image or not. It doesn't really matter. Also, you're not going to deploy that base image 20 times a day. Like if you have a stateless application and you just redeploy it all the time, probably image sizes make a difference. But data stores, you won't deploy that frequently because they're not moving around that quickly, and there are no new versions released that quickly. Like we will only release a new version every couple of weeks. So even if you upgrade to every single patch level release that we have, you will only need to do that every couple of weeks for the few data stores or Elasticsearch clusters that you will have. So the base image size is not really the issue. What we actually found out what was the bigger issue is that automated scanners and false positives are a major pain in the butt. Because there are so many false positives, and we have people who are almost full-time working on just filing reports of why some security issue is not actually exploitable in our images. And that's why one of our colleagues just recently started an effort, and it will come out in one of the upcoming images that we have, that we will still base everything on CentOS, but we will strip out any packages that we don't need. So I think by default, CentOS 7 brings around like 170 or so packages in the image, and we use very few of those. So we actually kick out most of them by now, and it also reduces, I think, the size of the image by 150 megs or so. So from 750 or so to 600-ish or so, I think. So it does reduce the size, but for us, the size is not the main goal. but really having false positives from security scanners is a major thing that we want to avoid. Like I said, image size probably doesn't matter that much for a stateful image because you have so much data on it anyway, and you're not deploying it that frequently. Whereas if you have something that is stateless and you deploy it X times a day, then you might care about that much more. Also because you might just provision new servers and you cannot reuse any shared base layers there. So there the image size might make a much bigger difference. Another thing that we are about to release soon are Red Hat Universal Base Images, or UBI. They are important in mostly the US federal space and to be certified on Operator Hub by Red Hat. Those were, I think, the main drivers why we're about to release UBI images for everything that we do. And those are also a bit smaller than the full CentOS images because we are using the UBI minimal ones. So these will, I think in the next minor release, we will have those out for all our products as well. So you will have more choices. We support ARM64 as well nowadays. So there are already multiple base layers that you can pick from. One thing that comes up every now and then is that people ask for Windows images. Not sure if anybody here wants those. We try to avoid it because very few people on our team actually know Windows that well. Like I haven't touched Windows in quite a few years. It does make sense because you don't need that small VM layer on your Windows versions. So you can run those natively then without the VM layer. We still don't really have any plans, at least for now, to release Windows-based images just because it's not really our ecosystem for most of us. Okay, so that was it for the Docker side. Like, this was just like, how do you build the right images and how do you make sure they are ready for production for the next step? Next up, Docker Compose. Probably not that many of you are using Docker Compose, especially not in production, maybe for local development or demos. I do that because it's quick and easy to run. So for example, this one would be the minimal example of running one single Elasticsearch node in whatever version with small heap and 1 gig of memory for the entire image, Kibana linked to it, and then we have a persistent volume to keep the data. So that would be probably the minimal example of what you could use to run Elasticsearch plus Kibana on Docker Compose. Simple enough, doesn't have many dependencies. So that will work and that works for demos, but it's not really much more. We used to have like a demo project, which we called Stack Docker, which had everything there, but we deprecated it because it was just not really worth the effort in our opinion anymore, because we want to focus more on that production experience. So I assume if you use any orchestration, most or all of you will be using Kubernetes. Normally with the show of hands, lots of people probably raise their hand for Kubernetes. Sometimes to that degree that it's not really the question is like, Kubernetes is not the question anymore. Doesn't really matter what the question is, Kubernetes is the answer. And that's always what you will be getting. When I ask like Swarm, sometimes people still have that, but it's oftentimes more on the way out and people try to migrate off of it. Nomad is also not very common in my experience. Mesosphere is pretty dead by now too, so probably nobody here. So we are stuck with Kubernetes. And I assume most of you or all of you are aware of how Kubernetes works. I'm not going to bore you with the Kubernetes introduction here. It's a static configuration to deploy your resources to Kubernetes. And this is the graphics that you all know. So you have your master node with the API server that you interact with. And then the main discussion point is always like, how do you pronounce this one here? I'll stick to kubectl for today. I always tend to pick a different one every day to keep it interesting. And then you have like the kubelets where you actually run your workloads. You have your data store that keeps the state of your API server, your scheduler, and then the controller manager that manages what is up and running here. So that's the base architecture that you have in Kubernetes. What you get lots of with this is YAML for better or worse. Yeah, lots of YAML. Some of us are probably already writing in their resume that they're YAML engineers nowadays because all they do all day long is write YAML. YAML is surprisingly tricky. It's a much bigger spec than you would expect, and it can bite you in the most unexpected ways. So for example, if you run this piece of code here through a YAML linter, does anybody know what happens here? And this is actually an example from the Docker documentation, because this is kind of infamous. So what we're trying to do is we're trying to map port 80 to 80 from container to host and 20 to 20. So this is what we're trying to do here. When you run that through a YAML linter, you will actually map port 80 to port 80, but port 20 to port 20 doesn't work at all, because it gets down to this weird number. Because anything with colon smaller than 60, YAML assumes that this is base. So rather than having port 20 to port 20, you have something base 20. And that's how you get to this nice number here. Just because that's in a YAML spec. And well, Docker actually warns you against doing that, and you should always quote those mappings. If you don't, you're in for a surprise if you're using any low port numbers. The other thing, or other bigger problem we had that with Kubernetes, was that it did not allow dots in environment variables until 1.8, which admittedly was a long time ago. Since then, you can generally use Elasticsearch on Kubernetes, because we configure lots of stuff through environment variables which contain dots, which is generally perfectly legal. Just Kubernetes didn't support that for quite a while. But once that was fixed, since then we have been all good. So how do you run all of this on Kubernetes if you don't want to write all of that YAML by hand yourself and do stupid stuff like, if you have a list of countries and then you have DE and US, whatever, until you get to Norway, which is NO, which would be evaluated like as a falsy value in YAML. Because it's, I think, one of 13 ways or so to write truthy or falsy values in YAML. Just one of the many aspects where it might surprise you if you write too much YAML by hand. So Helm charts, or Helm, is a package manager. So it is like package manager in like a regular package manager. You have a template, and you can just create the basic Kubernetes resources that you already know and have, and you just can template them to move them to a state that you want to have. So you have your stateful sets, your services, your deployments, all the concepts that you already know and have. You can just reuse them, so it's not adding any weird complexity on top of that. We have official Helm charts, which are GA by now, so production ready and supported for Elasticsearch, Kibana, Filebit, MetricBeat, APM server, and Logstash, so you can just use them. What do they use? Generally, like most other stores, data stores, they use stateful sets in the background. So you have a stateful set that you get some volume, or you can attach a persistent volume to that. And then you can just do stuff like a rolling upgrade, or when a pod dies and you need to reattach that volume, you don't have to re-replicate the data all over your nodes. You can just reattach a volume. So that is very helpful. For example, if you do an upgrade of your cluster, you can just do a rolling upgrade. You replace one node after the other. You reattach all the data, so you don't have to re-replicate 100 gigs or whatever you have in data. Wait until the cluster is all green and okay again, and then you replace the next node. So that's how you could do a rolling upgrade based on stateful sets. And this is what most data stores actually do. Our Helm charts are only tested on Google Cloud for now, using the default PD SSD storage, which is network attached, but you can also use local volumes. So that is kind of the generally tested setup there. What is kind of important to remember around the Helm charts is that they are unopinionated. So you have environment variables, and you can mount secrets, and there are multiple upgrade strategies. So all of that is pretty much what you have just from the plain Docker images. It's just wrapped in a template. But you will, for example, if you want to set TLS encryption between your nodes or for communication outside of your cluster, you will need to generate the certificates, and then you will need to mount them. Or if you create any passwords, you will also need to generate them in a key store and then mount them so your cluster can use them. So it builds heavily on the concepts that you already know from plain Docker. And you can configure lots of stuff through environment variables. which can look something like this. So for example, I'm picking that Minikube example. I'm not running it live here because with Zoom, this would probably take a full hour until everything is up and running because it eats all my CPU. So what you would do is you could add the Helm repository that we have, and then you install it, providing whatever image name you just want to run today. With Minikube, you might have to add some storage providers, and then you can just run this. And you can see the people who have been building this are using Make because they're kind of like the old school infrastructure folks at our company who are very much into like the tried and tested tooling. So that's why they are big on Make, for example, and why we're using this here. So what a very small example could look like is we have a container with half a gig of memory and a bit of CPU. We give it very little heat, and we also create a volume claim with 100 megabytes, which is also tiny, but for a hello world should be enough. The one thing that is sticking out here probably is, and that only makes sense for Minikube, is we have Affinity Soft, which basically means if you want to run multiple Elasticsearch nodes, this would allow it to do that on the same physical machine, which generally you would want to avoid. So you don't want to have the affinity to run multiple machines on the same underlying hardware, because if that crashes, it takes down all the nodes there. You would want to spread it out. With Minikube, there's no spreading out. So that's why we keep that affinity to soft and run everything on one or the same host. And that's pretty much it for Helm charts. So Helm charts are like a package manager. You say like install this version or bring me up 3 nodes of Elasticsearch. And it does that. And once it's done, it's done. Now let's move on to the operator. Operators are interesting because they kind of like move you one level higher on the abstraction. So it basically extends the Kubernetes interface and allows you to customize resources. So rather than thinking in pods and services and deployments, you think in elastic terms. So you can think in, I want an Elasticsearch service, and I want a Kibana service, and I want an APM service, and they have their own namespaces. For those, we have the so-called custom resource definitions, CRDs, and they provide these higher level abstractions rather than relying just on the known Kubernetes concepts. By the way, one thing where I'm also sometimes not very exact is you have the custom resource, which is basically the running living thing that you actually use. And the CRD, the custom resource definition, is like the class. So if you're coming from the object-oriented world, that's the class, and the actual thing, the object, is the custom resource. The CRD is really the definition of what is possible and what you can run. And the custom resource is what you're actually running then in practice. And to bring those custom resource definitions to life, you have a so-called custom controller. So that's some code that we have written for you, written in Go, which is the most common, but there are also ways to write that in other programming languages, and that will manage everything for you. And this custom code will run in an infinite loop, the so-called reconciliation loop, which will continuously check in what state is your cluster right now, what is configured, if the two are different, how do I move your cluster into that state that you want it to be? And that is the main difference to Helm charts. Helm charts are like, do X, and then it moves, I don't know, it scales up your cluster, or it moves it to that new version. Whereas the custom controller continuously runs and will also pick up like, oh, a node died, so I need to replace that. Or whatever else is configured in your cluster, it will continuously make sure not just moving it from state A to B, but always continuously checking, is it in the desired state, yes or no? And it will also manage a lot of things for you. So it will create secrets, it will create TLS certificates all automatically for you. There used to be an operator from the community, but the author or creator and maintainer was not able to run that anymore. So we provide our own, which has this fancy, colorful logo. I'm not going to dive into the logo too much. And that gives the operator. Don't be confused. Internally, we call it Cloud on Kubernetes just because it should give you like a cloud-like experience on Kubernetes. If you're searching for operator, you might not find that immediately. So don't be confused. There is an operator. It's just called Cloud on Kubernetes rather than Elastic Operator, which I think would have been the easier name and what is used by most others, but that's the naming that we're using. It can use Elasticsearch, Kibana, the Beats, and APM server. All of those can be managed by the operator. It's built in Golang, KubeBuilder. So that's the SDK to talk to the Kubernetes API server with the custom resource definitions. If you're using a very old Kubernetes version, we might patch that up with Customize to actually support or build around missing features. So that will just patch things together the right way to make them still work. So how does that generally look like? You, as the operator, you install the Elastic Operator, which continuously runs. So this has these custom resource definitions. This is the piece of Go code that continuously runs. And then you provide the configuration of what you want to have. And then that operator checks, okay, this is what you want to have. This is what is currently running. If those two are not the same, it will check like, how can I move the actually running cluster into the state that you want to have? So if you say like here, there should be 3 Elasticsearch nodes and 1 Kibana node, and then one of the Elasticsearch nodes one of the Elasticsearch nodes dies, then it would add another 3rd node again and bring the cluster back into that state. So this is what it would do. It continuously checks, this is what you have configured, this is the state you want to have. If you make any update to this, the operator would automatically pick it up and then move your cluster into the state that is configured here. So that's the general idea. And the operator is opinionated, and depending on how you see that, that might be good or bad. So it is opinionated because it encodes best practices. So for example, security is always enabled. It will always generate TLS certificates for you. It knows how to run an upgrade process and does specific operations for you. And the operator will talk to both like Kubernetes as a concept and Elasticsearch. So for example, if you have like 5 Elasticsearch nodes today, and you say, I only need 3 anymore, I want to scale that down to 3, it will not only talk to Kubernetes and actually kill 2 of the pods that you're running, but it will actually first talk to Elasticsearch and figure out, okay, these are the 5 nodes that I have. I will move all the data off 2 of these nodes and drain them. Only once they are drained, then I will run the Kubernetes commands to actually remove the underlying pod. So it does talk both to Elasticsearch and to Kubernetes. So that's what the operator does. And it encodes those best practices into all of those operations. So like I said, if you scale down, it will drain nodes first. If you upgrade it, it will set some configurations to actually make a smooth upgrade experience so that the cluster doesn't go crazy and say like, oh, a node dies, I need to replace that node. Rather, it will make the right configuration so it says like, okay, I know that I'm being upgraded, so I will not try to replace that node because I know it will come back in a newer version in a moment and join the cluster again. Stuff like that is built in. But it is not guaranteed to be foolproof. So for example, if you have a single copy of your data, you do a rolling upgrade, every single node needs to go down and come up again. If your single copy of data is on the current node that is being replaced, your data or that data will not be available for a short amount of time. There's no way around that. There's no magic. So this is just the way the operator is built. It will try to protect you from stupid stuff, but if you have a single copy of data and you currently upgrade that node or the node dies, well, then that data will not be available until the node comes back up again. To run that on Minikube, locally, if you want to test that, I'm normally using K3S because it's much more lightweight and totally does the job. We don't officially test on K3S, but when I use it, it works. So especially for demos or hello worlds, K3S will be fine. Probably I haven't tested the Kubernetes in Docker yet, but I assume that it also works, which also should give you a much smaller or smoother experience than Minikube, which can be quite heavy, or it's pretty heavy for my laptop at least. So you assign some resources, you start it, and then you install the operator. So you can download it. Currently, it's 1.2.1. 1.3 is coming out soon. We have the all-in-one operator, which covers all the pieces of software that we have here. You can actually watch the operator come up. So there is one part that is the operator that is running that Go code that runs that reconciliation loop. And then it will bring up all the other pieces that it needs to run. So it will create the TLS certificates and the secrets. And then it will bring the Elasticsearch nodes and Kibana and APM and beats and whatever else you have. The next 3 slides will show the configuration, APM, Elasticsearch, and Kibana. We'll start with Elasticsearch because that's what everything else is building on top of. So what I'm doing here is, and this, by the way, is where that concept of thinking in terms of elastic concepts and not anymore in Kubernetes concepts comes in. Because here in API version, I have Elasticsearch Kubernetes version 1. So this is an Elasticsearch resource. It's not a Kubernetes resource anymore, it's an Elasticsearch resource. And the name is Elasticsearch sample. This is also the metadata name that we will reference when Kibana needs to connect to Elasticsearch. And then you just say, okay, I want to have this version with a single node, these specifications, it's a data node, and this is like what I give it in storage. This is pretty minimal, and you can make this much more complex. You could split up nodes or node types, like we have dedicated master nodes and data nodes and maybe ingest nodes. You could split all of those up. You would get a lot bigger or a lot more YAML for that and a much larger YAML template to fill. But it is very finely configurable or tunable to your needs. This is just a very simple example here. Then I'm also adding APM for tracing and Kibana. So this does pretty much the same thing as before. You can see again, we are in an APM namespace and not in a Kubernetes namespace anymore. And it references the Elasticsearch sample from before and just brings up one stateless APM server. And pretty much exactly the same thing for Kibana. Again, its own namespace, same version, a single node, and references those Elasticsearch nodes that are running. And then you could, for example, check them out. There's nothing special here. You could expose the default port of Kibana so you can connect to that. And then you could extract that secret, which is always a joy to type unless you can copy it. But this is how you would get the password to actually connect to that Elasticsearch or to log into Kibana. So here you expose Kibana, the UI tool basically. The default user is Elastic. And then you need to extract the password because we will randomly generate the password for you. And that is stored in the secrets in Elasticsearch sample. So this was the metadata that we gave to that cluster. And then it's the Elastic user that we want to get from Elasticsearch. And then it's in JSON structure, data Elastic. And then it's base64 encoded. So this is how you would retrieve the final password to log into Kibana actually. But the TLS certificate is being generated and the password is being generated for you. The TLS certificates, by the way, are of course self-signed because, well, we cannot set up properly. We don't even know what external DNS name you would use. That's why we only provide self-signed certificates. If you know the DNS entries, how you will access your clusters, you can, of course, provide your own certificates and replace the ones that we would generate. So you have valid certificates. That's also totally possible there. And then if you change anything, you upgrade the version, you increase or decrease the number of nodes. Anything you do, you just change the configuration, kubectl apply. The operator will pick that up. And then in the reconciliation loop, apply those changes and bring up the cluster in whatever state you want to have. And this is pretty widely tested. So we support that on Google, on Azure, on AWS, on OpenShift. Those are all tested nightly. The tests fail every now and then because I see it in the Slack channel, but we are pretty quick at fixing those, especially around releases then. And again, the concept behind that is a stateful set. So when you do a rolling upgrade, it will just reattach the volumes. So you have a stateful set per node role. So you have one stateful set for the master nodes and one for the data nodes if they're split up. And then there is a persistent volume for each pod that is running, so you can just reattach that when a pod dies or you replace it because of an upgrade. So that's what you can do there. Storage-wise, we support persistent volumes, either local or whatever your cloud provider you provides, like AWS uses EBS or whatever they provide. You could also use mtdr or host path, which is not durable. So if the pod restarts, the data is gone, and it might be evicted because of the way quotas are enforced. So that is only really useful for ephemeral data. So if you use it more like a cache or something like that, which is very uncommon. Like persistent volumes are in 90% of the cases or so what you will want. In the future, we might officially support other storage backends. There is a Kubernetes specification for CSI, Container Storage Interface. We might dive more into that. So far, we haven't really, because there was not so much demand for that. Deployment-wise, you need to have admin level privileges to install a custom resource definition. So unfortunately, not unfortunately, of course, we need that as well. The one thing that we do right now is the operator sets max map count so that we get enough resources for our Elasticsearch instances. If we should do that, or if we should make you do that manually, is still a bit up for discussion. So to run the operator, there are two ways basically that we or any other operator that supports that can run. So you can have a global namespace for the operator. So we have the Elastic System namespace just for the operator, and nothing else is running in that one except for the operator. And then it manages all the other namespaces and checks, do you have that Elastic namespace anywhere? So do you have any Elasticsearch, Kibana, or APM servers running in any of those? And then it will pick that up and make sure you have configured X and running is Y. Are X and Y the same? If not, I will move them to that state. Otherwise, I will just leave it alone. And so multiple teams can run their Elastic resources in their namespaces, and a single operator will take care of that. Obviously, that operator then needs a lot of privileges across all the other namespaces, which you might not want or might want. It has the advantage that you cannot accidentally delete the operator. Whatever you delete on the non-operator side, basically, the operator would automatically recreate or replace them. So if you delete any pod accidentally, for example, the operator would figure that out and replace or stand up a new pod for you and take over. That is the Helm chart, in contrast, of course, doesn't do that. It just moves you from one state to the next. But the operator would figure out, okay, you accidentally you deleted one pod here, and it would automatically replace the pod. And running the operator in its own namespace is kind of like isolated from accidents against that. The other approach would be to run an operator per namespace. So then this operator here just takes care of these resources. This operator here takes care of these resources. Has the downside that you will need to run multiple operators, which will take up some or a few resources. It's not too much, but a little. On the other hand, you have a much nicer isolation between the namespaces, and there is no resource that is cross-cutting all of the namespaces. So that's another way to run that. Also, if you have like hundreds of clusters running, which some customers do, you will need to give more resources to that operator, or might want to split it up some other way. Because that might be a very heavily loaded operator otherwise. Running it in individual namespaces might be a solution for that, but has some downsides as well. Also, you could, if you're just operating your dev team namespace and somebody accidentally deletes the operator, it's pretty much game over for the operator. So you don't want to have that. And there are lots of other operators, like Operator Hub from Red Hat. Actually shows you a wide variety of available operators that are listed there. So to wrap up, and I think, how are we doing timing wise? Yeah, we have like 10 minutes or so. Containers are disrupting the industry is some statement that we hear every now and then. And I'm never sure if people mean that in a good or a bad way, because sometimes containers are being used wrongly or abused, and then they cause downtime, and that might also be that kind of disruption that people mean. The question that I hear quite frequently is, can I run Elasticsearch on Docker or Kubernetes? And the answer is yes. But the question that you should be asking instead is, should I do that? what did I say earlier? We don't have really strong opinions. If you run everything on Docker or Kubernetes within your company, probably go for it. And we try to support you as good as we can. If you're just starting out with containers, probably don't start with your data stores because they are normally more tricky because, for example, an upgrade strategy is much more tricky, or you need to think about backups. Stateless applications are probably the better place to start with that, actually. And then finally, something that we kind of like noticed after some time, after having that operator, or first not having an operator and then adding an operator, was the Kubernetes paradox. So people would always ask, like, do you have an operator? And when in the past we said, no, we don't have an operator yet, they would say like, oh, this is a blocker, we cannot use your software. And then it turns out when you actually ask, like, so you run the majority of workloads on Kubernetes, they're like, no, we're just actually starting. So we only have 2% of our workload on Kubernetes running, but we still expect everybody to support Kubernetes. Otherwise, we cannot use their software anymore, which was kind of like a bit of a paradox. Like, it was a must to have an operator to have a good strategy there, but it doesn't mean that everybody will jump on the operator right away. So while we have some large customers on the operator already, it's not that everybody would be running Elasticsearch or probably any other data stores just in Kubernetes. It's just not what is happening. Helm charts versus operators. I hope I'm kind of made the difference clear. Maybe it's a good way to think about it that Helm chart is like running stack on Kubernetes. And then the operator, that's also where the name comes from, is more like the cloud-like experience. It's like more operational best practices and automation built in. You just flip the version in the YAML file, and then it will do the rest for you, hopefully. Helm charts are not really opinionated, so you can run them multiple ways, whereas the operator is very opinionated and has all of that, like a streamlined approach. If you run lots of services and you want to kind of like run them your way, maybe you will have an easier time with the Helm charts. Whereas the operator just runs the stuff the Elastic way, which might be different than other operators. And maybe that is freaking your ops team out. Final point, what is the most tricky part about especially data stores on Kubernetes are like the day two operations. So it's like scaling up and down, upgrading versions, applying some configuration changes. That standing up something initially is not really the tricky part. But those day two operations, like keeping your cluster healthy and up and running and up to speed for whatever you need, that is the tricky part. And that is where the operator mostly comes in to try to help you and help with that operational best practices that is encoded in all the Go code that we are writing and maintaining, so you don't have to. So that's kind of like the idea here. That's it. I think we have like 5 minutes or so for questions and discussions. If you want to get the slides, that's the right QR code, or I can just share the QR code on Twitter afterwards. I guess it's time that I stop sharing and we jump to the questions.
Sure. Thanks a lot, Philip. That was a great talk. One question I have coming in is, what will the future hold for Docker base images?
Well, so like I said, right now, as of today, it's CentOS 7. As of the next minor version, it will be UBI minimal, so smaller base images, and we'll have like, it's still based on CentOS, but it removes all the dependencies that we don't need. So a lot of the craft that is also coming around. I'm not sure which version right now, because that was just merged like this or last week. Probably last week it was merged. So smaller images are on the way. I would just be curious why, or where the question, or what is the target of the question? Is it the size or something else? Like for us, the size was, like I said, not so much the issue because you have lots of data on Elasticsearch anyway, so you don't care so much about it. For us, it was mostly the false positive of security scanners. So if you want to dive deeper into that, ping me here or on Twitter. I would be curious why people care so much about the base image.
They're not following up, but another question is coming in is, what are the biggest pain points when running an operator?
Well, so one of the pain points is normally, especially when people are not so used to Docker and Kubernetes, is getting everything right in YAML. Like you miss some indentation and then something does not work the way you want it to. And especially if you have more complex configurations and your YAML is not correct, you might get weird errors, and it might just not behave the way you expect it to, and that can be a lot of fun to debug. If you have like 150 lines of configuration in YAML and some indentation is wrong, you might not have fun afternoon. I think that's one of the main pain points. We try to alleviate it with more templating and like more concise configs, but once it gets more complex, it's still a pain point there.
Very good. Okay, I don't see any others, so I guess I'll pass the baton on to our next host. And I believe that is Mike Grayson. Is Mike available?
Yeah, that's correct. Yes, Mike is available.
Mike.
Thanks, Tim. All right. So, hi, everybody. My name is Mike Grayson. I'm a MongoDB DBA here at Percona. On the managed services team, working in the global services part of Percona. I'm excited to be your host for about the next hour. We have two really cool talks that I'm excited for, even as a MongoDB DBA. I'm really excited for these two talks. So without further ado, let me introduce the first talk here we have from Krunal Bhaskar from Huawei. So his talk is the MySQL ecosystem on ARM. Krunal's been actively working in the MySQL space for more than a decade now. He's currently driving the adoption of the ARM ecosystem for MySQL, MariaDB, and Percona Server through his hashtag MySQL on ARM initiative. He's worked on multiple MySQL products, including Percona XtraDB cluster, undo log truncate, atomic truncate, temp table work. He's previously worked at MySQL and Oracle and as Percona. Without further ado, I'll hand it over to Krunal.
Hey, Mike, can you hear me?
Sure can, yep.
Okay, perfect. And thanks for that intro. Do we want to start? As in, like, we still have 1 minute left. Should we get started?
Yep, let's go ahead.
Okay, perfect. Okay, thank you, Mike, for that introduction. Welcome all. Today, we are going to talk about something cool, something new, and I believe this is going to be the game changer for MySQL, and that's about MySQL ecosystem on ARM. So let's get started. My name is Krunal, and I've been driving this MySQL on ARM initiative. That's quick intro about me. Most of that has been covered, but I have been working in space for quite some time now. Worked with Percona, Oracle, Yahoo Labs, a startup which is now part of Teradata, where also again we developed a world fastest storage engine. Currently, I'm working with Huawei as part of the open source DB group, and I've been driving this MySQL on ARM initiative. So when I say MySQL, I mean it from a generic sense. So it includes MySQL, MariaDB, and Percona, and of course the ecosystem tools that are with it. So that's our agenda for today. We will talk about the growing ARM ecosystem. Then we will see the state of different flavors of MySQL on ARM. We will see why one should run databases on ARM. And then we will talk about the state of the ecosystem. We will end it out with some quick notes about what's coming or what probably the community is moving towards. Okay, so let's talk about the ARM ecosystem. I'm sure by now everyone knows what is ARM. But I think the main point when we think of ARM is from cell phone or network equipment perspective. If you stretch it further, you would discover that a lot of ARM processors are also used in our day-to-day housing appliances and in IoT devices. Especially, in fact, Alexa and all these things already have an ARM processor. If you further stretch it, you would discover that ARM is also used in automobiles, especially with self-driving cars gaining pace and a lot of other electronics coming in the cars and automobile things. It's been fueled by ARM. Space and defense also use ARM. So what's new, or basically something which has started picking up pace lately, is use of ARM in high performance computing. So when we say high performance computing, it typically means software which needs in good number of CPU power to perform databases or big data applications. So let's understand what has been fueling this HPC growth. Of course, ARM is known for its lower ownership cost because it consumes less power, and in terms, it improves the cost performance. And it also do support the Go Green initiative. Also, there is an increasing ecosystem. Like lately, ARM ecosystem has been growing almost on all front. You would say a software is or a variant of it is available in ARM. There is a growing user base and developer base. I think that is a key. A lot of new generation which is entering or joining the community as in general have been using ARM processors or ARM kits during their grads or undergrad days. So they already are used to something to do with ARM. So we are getting a rich user and developer base. Majority of data generating devices are already on ARM. So having even the data processing devices, which are in form of databases or big data things, would make the circuit complete. But I think what is a game changer is a few years back, if you want to boot a pretty powerful ARM instance, there was no alternative available. Fortunately, in last couple of years, a lot of alternatives have come in. So Huawei Cloud offer ARM instance through its Kunpeng 920. AWS offer ARM Cloud through Graviton 2, and you might have seen Oracle Cloud is also planning to offer ARM instance through Ampere Ultra, and Packet.com already offer it through Ampere Ultra. So I think that is the game changer, because now everyone can boot instance quickly and run things on ARM. Beyond that, even you look at majority of the OS providers have ported their OS for ARM, and the ARM port is available. So that also is helping. And applications, whether it's big data, databases, now in fact MySQL, MariaDB, and Postgres also from open source community have already available on ARM. Application servers are load balancers. So a lot of these high HPC applications are either being ported or already have a package available on ARM. So ARM is estimated to provide roughly a 30% cost saving compared to the same flavor of x86. So that has been the key driving motivation why user have been thinking towards ARM. And it is estimated by 2030, ARM would be the most booted instances for running HPC applications. So with that quick intro about ARM, let's talk about the state of our databases on ARM. So MySQL. So you may be aware that MySQL already support ARM. There are official packages from MySQL for ARM starting 8.x. Of course, we haven't seen a major or dedicated optimization yet for ARM, but yeah, MySQL has been actively fixing bugs that are being filed or discovered on ARM. But we also know that a lot of optimization work that MySQL has done lately, they have been considering that the number of cores in the next generation CPUs is going to be higher and higher. So they have been using sharded counters and all these designs so that it's scalable with increasing number of cores. There is a very active community contribution for ARM. More than 30 plus patches has been contributed. Most of them are performance related. And fortunately, in past couple of months we saw some good traction from MySQL side. A few community patches got accepted. Beyond that, I think they are also trying to work it out internally to further improve the ARM in general, or perform MySQL optimized on ARM. So that is good thing. Hope the same traction will continue even further. Now, MySQL beyond server also offer other supporting tools. So, for example, MySQL router, which is from load balancer category, or shell, which is from smart shell category, MySQL connectors from connector category, and of course, group replication, which is from HA category, but it is inherent to server. So there's no separate package as such. But MySQL also offer some things beyond the server. So that shows that MySQL is pretty serious in these things, because they have also considered other ecosystem tools. These are some major contributions. Typical related to optimizations of MySQL on ARM that community has contributed. Checksums, which is from hardware category. Memory barriers, ARM being weaker memory model, you need to ensure that a proper memory barrier is used. NUMA aware construct, using sharded counters and making sure the connections are scalable. 64-bit optimizations, cache lines are different in ARM, so making sure that the things are tuned. Switching to optimal use of C++, atomics, which is now possible easily with C++11, and spin loop optimizations, and much more. I've just covered some representative things, but yes, as I said, there are 30 plus contributions there. Percona server. So, Percona server doesn't have official packages for ARM yet, but we know it compiles, and we have, ourselves compiled it and run it successfully on ARM, except TokuDB and Myrox. Percona server being fully upstream compatible, we can expect all the optimizations and fixes done for ARM by upstreams will be inherited by Percona server too. The good thing about Percona server is it enjoy a very good community support. Even before other vendors started coming up with their packages for ARM, a lot of users out of curiosity started trying databases or MySQL on ARM, and they opted to try Percona server on ARM. So they tried it on varied architecture. So that is very good thing about it. MariaDB. So MariaDB also has official packages on ARM. In fact, on wider distro, they have packages on CentOS, REHL, and Ubuntu. In fact, they are also working on more distro. They were first to optimize and support things on ARM. So they are very active. They are also accepting patches for ARM, whether it's correctness or performance. And they are also evaluating their new features or any small thing which they make change and which has potential to make a performance impact. They not only evaluate on x86 these days, but they also try to see if they could evaluate on ARM. And as a community, we do support that, and we help them evaluate some of those things too. But what lacks on the MariaDB front is ecosystem support. For example, their connectors and the max scale, which is their load balancer thing, we don't have yet packages on ARM. So maybe if community start pushing, they will surely get those packages on ARM too. Again, optimization. So most of the optimizations have been folded by MariaDB, and they are on the same line which we talked about for MySQL. So a lot of good optimizations has already been folded and made optimal to suit MariaDB things. So with that state of databases, now let's see why someone should run database on ARM. Now, before we get into, we are going to look at some benchmarking number. But before we look at the benchmarking numbers, I think it's we need to understand this CPM model. We are going to have a quick intro, because of course you can read the detail on the blog. But the idea is this: ARM is all about lower cost and with more computing power. So maybe the core is not that powerful compared to x86, but you will have n number of cores for the same cost. So the idea to exploit this particular fact, we need a model which will help us be fair and help baseline it with the x86. So we developed this CPM, or cost performance model, and which can help us exploit this fact. So let's understand it quickly. So the idea, if you try to boot a instance of a same flavor instance on ARM and x86, as you could see from the chart, that almost on all cloud provider, ARM instance will be cheaper. The range is between 20 to 50, but we can safely assume that on an average 30% cost saving could be achieved by booting a same flavor instance on ARM. So that makes it easier. We can run MySQL on ARM on x86 on same flavor, and we can say that, okay, well, if MySQL on ARM performs on par with x86, we have achieved a 30% saving. But there are challenges. That's a typical way how traditionally we have been doing things. But there are challenges with this because the architecture is different. So there are CPU frequency differences. Intel has turbo mode for lower frequencies. There are CPU generation difference. Getting the same kind of CPU is difficult. x86 has hyper-threaded cores. ARM doesn't have that kind of thing. Their NUMA arrangements are different. With increasing core, the NUMA arrangement could be different. Memory differences are there, and even scheduler. So what I've heard is starting 5.x onwards, Linux has improved support for or basically more NUMA nodes, or so hopefully that will improve how the things are getting scheduled with more number of cores. So with these challenges, we just looked out at the problem in a different way. What if we keep the cost constant and we try to analyze the throughput? And if the throughput for ARM is more, we can see that TPS per USD from ARM is more. If I state it other way, if I have X USD to be spent, I can get M ARM resources and N x86 resources. So can these extra resources from ARM help improve performance? More formally, given the on-par cost of both the resources, can we exploit ARM variant to its fullest benefit and get better performance when compared to x86? Okay, so let's understand this, what we meant from that data point, right? So if I have 3500 USD to be spent, and on Huawei Cloud I could get 12 vCPU, 48 GB of x86 VM, and for the same cost or roughly same cost, I could get an ARM instance which will have 24 vCPUs. So double the number of vCPUs and the memory remain the same. So you could now make it out that for same cost you are getting almost double the computing power in terms of computing power, since the frequency difference is there. But yes, you are getting double the number of cores and almost double the computing power. So that is a 2x difference. That 2x more computing power could be obtained for same cost when you compare x86 to ARM. Now, of course, the difference we talked about is VM, and if you go to bare metal, where normally MySQL and all these setups are run, the difference is even higher. The infrastructure I have access to, we have seen a difference in range of 2.5 to 5x. That's pretty huge difference, and that is a computing power difference. So with that CPM thing in place, let's see if we could benchmark and what numbers we could get. So we have used Sysbench. We will try or kind of do experiment with CPU and IO bound workloads. We have used latest GA releases. Now, of course, MySQL release 8.0.22 just a couple of days back, but we have used 8.0.21. And Percona server, we have used the release branch 8.0.21, which is still in progress, but we just used it and we build it because there are no official packages. We consider test scenarios for all front, as in the read only and the read write and the update use cases, and machine configuration. So when I said this is bare metal, so for a same cost, I have kept the memory same. You could see the storage is also same for both the things. So keeping everything same, I allowed to change the computing powers. And what I got is for the same cost, I could get 28 HT core, that is hyper-threaded core of x86, and I could get 64 cores of ARM. That is more than like 2.25x difference between the two. So that is the magnitude of difference that we could see when switching to things to ARM. Now let's see this extra computing power. If MySQL, Percona, and MariaDB could use it, we can say that ARM has performed better. So this is the results for MySQL CPU bound uniform. So we will see uniform and Ziphian. Uniform touches all the keys in the database. So it represents lesser contention, but more amount of IO. And will Ziphian will only touch part of the keys. So it represents more contention. So as you could see here, on all front, the blue line represent ARM and the red line represent x86. And you could see that on all front, ARM start to scale better and have been performing better than x86. For lower scalability, ARM may lag or may, there could be a small gap with x86, but once it crossed that scalability point, ARM just scores better. And in fact, for read-write use cases, ARM start to scale better even with lower scalabilities. So I think that is the key, right? With increasing extra computing power that have been given to ARM for the same cost, ARM has able to show up the better performance. And so, sorry, and that is the I think that is the key with respect to the computing things. Now let's talk about IO bound workload. We saw CPU bound. IO bound means not complete data fits into the memory. So here too, as you could see, ARM has been performing way better. It has been scaling even for read-write workload for lower scalability. And once it crossed the scalability point, you could see there is a significant difference with respect to ARM. CPU bound Ziphian. So Ziphian, as I said, represent a contention case. So we thought we will also put that, and we'll also test it. So as again, you could see that ARM has been performing better even with CPU bound Ziphian case, and that is IO bound Ziphian. So same thing, ARM continue to perform. And if you say that, oh well, my workload is more like TPCC kind of workload, as you could see here too, it continued to perform. In fact, once the scalability point is crossed, ARM, the difference significantly grows, and with higher scalability, the difference is almost 2x compared to x86. So this is what Sakila has to say. I can sail faster with ARM. Now let's talk about Percona server. Now Percona server, of course, doesn't have its own optimized fixes, but since they have inherited the things from upstream, the pattern is almost the same. So you could see that CPU bound uniform, it is scaling. IO bound uniform, it is scaling. And CPU bound Ziphian to it is scaling. And IO bound Ziphian to it is scaling. So even Percona server continue to scale and run faster with ARM. So that's what Percona server has to say. I can run faster with ARM. Let's talk about MariaDB. So again, MariaDB CPU bound uniform. So as you could see, again, even with MariaDB, ARM continue to scale better and outperform x86. And that's CPU bound Ziphian. The same thing, you could see that ARM always continue to better than x86. We haven't considered the IO bound use cases because there have been some regression, generic regression, nothing to do with ARM, that they are fixing, and hopefully they're fixed in the upcoming release of MariaDB. And that's what CLAN has to say. I can swim faster with ARM. So isn't that good? All you pick any database of your choice, and you could get better performance just by switching to ARM for the same cost. But let's understand what it means from end user perspective, right? What does this increased performance means? So that's the thing, right? For the given cost, running an instance on ARM can give you more throughput. And if you put it in data points front, then let's assume that I've taken a sample data point from one of the results we just saw. And for 1024 scalability, we could see that the ARM TPS is higher than x86 TPS. And the magnitude is, and which in turns means the TPS per USD is higher for ARM. So for same cost, you are going to get more TPS from ARM, and the magnitude is 42%. In fact, this is with the range is even wider. I've just considered one such data point. So you get more TPS at same cost. Of course, user may think what it means to me, because if I'm going to invest same cost, how does it justify the saving? And let's look at from this perspective. I think this is a common question all the DBA face, and in fact, in current pandemic, I'm sure everyone wants to keep control on the cost, but still want to grow because everything is switching to online. So the question is, can I scale the database without migrating database and keeping the cost constant? So the traditional solution is go get new, MySQL servers, or basically a better hardware or larger hardware. But of course, it will cost you. You will have to pay good amount of extra cost. Or you can switch to ARM, same cost, same database, same environment, just more performance. So nothing changes. You just switch to ARM and you just scale your database better than before, and not even the cost change. And not only ARM is cost effective, it also support the Go Green initiative, because it's also the power efficient thing. And if you have something, and I think that's a typical setup most of the user has, you have a master slave or HA kind of setup, it's very much possible that with ARM, what since the throughput is higher from single server, to attend the same throughput, you would probably need lesser resources, as we show in the picture. And you may, in other terms, it means lesser instance, lesser cost, and same throughput. Okay, so for the same number of or lesser number of instances, you could get the same throughput. So this is the message. Any flavor, MySQL, Percona, MariaDB, any workload, whether it's a CPU bound or IO bound, any pattern, whether it's read only, read write, any configurations. We saw contention, non-contentions, any setup, single node, multi-node, ARM always score. So ARM is not meant to help with a particular use case. ARM thing is going to help you, or MySQL on ARM is going to help you on all front. Whatever is your setup, whatever is your way of working, load and everything, ARM is always going to help you. Now let's talk about the state of the ecosystem. So when a user adopt a server, a lot of other tools are needed. Now, especially important, but with respect to server, since MySQL and MariaDB officially support ARM, correctness issues will be taken care of with the same priority and seriousness like x86. In fact, we saw that in past. Database on ARM is generally is growing, and MySQL is not an exception. So MySQL on ARM community is also expanding. A lot of people are getting interested in moving, given the cost advantage and the performance advantage we saw. So, but let's put it in terms of more concrete things, in terms of tools. Now, some of these tools are already ported on ARM. We'll talk about them. Some of them is work in progress, and some of them are still, we hope to see them coming up in due course. So server, we talked about backup. Maria backup is already, part of this, their installation. Percona extra backup, if you're used to that, then we officially, of course, it is not, but we could compile it and successfully use it to take backup for Percona and MySQL servers. HA replication, binlog, InnoDB cluster, again inherent to MySQL. Galera cluster, we tried it with MariaDB and it worked. We haven't tried the vanilla flavor yet, or even the PXE flavor, but we think it will just work since it works. The baseline thing works. Tools, Percona toolkit being a Perl script, we were able to execute it easily on ARM. MySQL shell officially again supported on ARM. Load balancer, router, official packages on ARM. Proxy SQL, there is some work in progress about that. Max scale, as we just talked about, we need community support to make sure that packages are available. Connectors, MySQL have official packages for connectors. Monitoring tool, PMM, it again works with ARM. We have a blog about it, that how you can monitor MySQL on ARM using PMM. And then of course there are other tools. So ideally what what we want is, from every category we want at least one tool to make sure that the ecosystem or the stack is complete. And in fact, we are fortunate that we have at least not more than one tools available from each category. The green represent official packages, blue represent works, and red represent not yet available. So as you could see, you can at least click on one of the options, and almost on all category, one or two tools are available. And we eventually want to say everything turns green, but I think with community support, that is possible. So if community start asking, I'm sure vendors will start providing official packages for it. But even without that, things are working fine. A lot of like MySQL and MariaDB already have some packages available for ARM. What is the missing gap in the ecosystem though? We need more distro support. For example, MySQL currently only supports REHL 7 and 8, so they could expand it to Ubuntu and Debian and all. Fortunately, MariaDB is better on that front. Docker images, official Docker images would help, so that we can use it on Kubernetes and all. Sharding solutions, for example, we just talks about vtest and all. So these supporting tools, if they could also start supporting things on ARM, that would be easier. Migration tools, and there are a lot of other supporting tools. I've just considered the mainline tools. So eventually everything is going to, of course, get supported. So that's the push that probably community can help us with. So a quick thing about what's moving forward. So as a community, we are going to push for more performance improvement. As you already saw, there are a lot of performance improvement all contributed to, and we are going to look for the completion of ecosystem, more distro Docker images. We as a community, we already continue to try explore things, see if all the combinations are working fine or so, and if there are problems, then we report it back accordingly. So I think as a community, we are trying to see how we could quickly get the closure, or not closure, I would say the expansion of the ecosystem. And then it's a pretty good progressing, right? We already got most of the mainline tools covered from that perspective. Okay, so that's all I have to say. And of course, you can read more about it. I have an active blog, MySQL on ARM. You can also, by the way, there are Slack channels. If you're not aware, MySQL community Slack, there is a channel called MySQL on ARM, and MariaDB use Zulip chat. There is a dedicated channel, MariaDB on ARM, for the MariaDB, MySQL and Maria on ARM efforts. And of course, you can reach me on, that's my email IDs, and you can also follow me on the Twitter, so that you could get updates about what's happening in this ARM ecospace. And I think that's going to be the next biggest thing coming up in the MySQL space. So let's see, when are you guys going to move your databases on ARM? Thank you.
Thanks, Kunal. That was great. So now we're going to open up for some questions. I'll go ahead and hit up the first one here. Given that the ecosystem is still evolving, do you think it's the right time to try MySQL on ARM right now?
Good question. So I would answer it two way. One, of course, is well, the ecosystem is evolving, but there are official packages available for the servers, or even beyond server for other tools from respective vendors. And of course, for any production user to reach to that stage, a user is going to take some time evaluating the things. And with the serious players, like including Oracle Cloud is also now going to offer ARM instances. So I think there is already enough amount of confidence that is there in the community that this is going to be a long-term things and not going to die. Amazon, Huawei, Oracle, everyone have invested their time and money to get the ARM instances. So yes, so I think it is a good time. You can start trying, you can start evaluating, you can report the feedback if there are any, and it would take some time for you to get adjusted, understand the economics and all, and then over a period of time, by then a lot of other things will catch up, and then you can start moving on. Mike.
Cool, thanks. One more question we've got. Do you think we lose any functionality compared to like an x86 architecture if we switch to use MySQL on ARM?
Good question again. So I think that's a very good thing, right? So fortunately, we don't lose on anything. So we don't know of any feature either in MySQL or in MariaDB that has been marked that this doesn't work on ARM or this is beta on ARM. So everything has been GA'd on ARM. So anything which you have been using on x86 will be available on ARM as it is.
Awesome, thank you.
Thank you.
I believe that's all the questions we've got. So thank you again for that talk. It was really good.
And thanks all people for joining, and thanks Percona for organizing this conference.
Thank you. All right.
Stop sharing.
And with that, I think I will start introducing our host for our next talk, or sorry, our speaker for our next talk. So our next speaker is Jay Lee, who's a senior engineer at PingCap. Jay is a TI-KV maintainer, a distributed systems expert, and the author of open source projects, gRPC.rs and RaftRS, and some other open source projects as well. So he's going to talk to us about how does geo-replication work in TIDB. If you're not familiar with what TIDB is a distributed HTAP database that speaks MySQL protocols. So Jay is going to talk about georeplication for it. So I'll hand it over to Jay.
Okay. Thank you, Mike. And hello, everyone. I'm Jay. I'm glad to be here to share internal designs of TiDB on Percona Live. Today, I'm going to talk about how does geo-replication work in TiDB. First, let me introduce myself. I'm Jay from PinCap. I focus on distributed system, and I love open source. I am one of the TiKV maintainers. And TiKV is a Kiwi database and CSF graduated project. Also, I love Rust and wrote several libraries in Rust. I'm going to introduce the geo-replication by 3 steps. First is a higher architecture of TiDB, and then a dive into its replication mechanism. And finally, several deployment cases that explain how those designs work in practice. So what is TiDB? TiDB is an open source NewSQL database that supports hybrid transactional and analytical processing workloads, aka HTAP. It is MySQL compatible and features horizontal scalability, strong consistency, and high availability. Here listed some key features of TiDB. It supports elastic scaling out, which is transparent to applications. TiDB does the shardings for you automatically. It uses two-phase commit and rough algorithm to achieve high availability and strong consistency. It speaks MySQL dialect. This is the whole picture of TiDB. There are a lot of components here, but don't worry, today we focus on the central part. That is where the replication takes place. Here is a simplified architecture. The core components of TiDB are PD and TiDB servers and TiKV servers. TiKV is a Kiwi database, as I just mentioned, and stores all the data. It automatically splits the data into small shards and reports the metadata of the shards to PD. PD maintains the route table of each data shards and other necessary metadata. It also moves shards around to achieve load balance. TiDB servers are stateless. They pass queries from the client and transform it into Kiwi operations. They communicate with each other using gRPC. Before introducing the replication, let me explain how data is organized. TiDB assigns each table and each row an implicit number and combines the table number and the row number into a unique key. The row content is the value. So the data of a table is sorted in dictionary order, and each table doesn't overlap with each other. The Kiwi pairs are stored in local RocksDB instance of TiKV. TiKV will divide the whole key space into several continuous logical ranges. We call those ranges as regions. Region is a bunch of Kiwi pairs or split. Don't get confused with the other geo concepts. It's more similar with the region from HBase. The default size of a region is 96 megabytes. You can change it if necessary. We choose the small value to get more accurate balance. The start key and end key describes the range of a region. And all region doesn't overlap with each other. All regions within a TigerV are stored in the same ROSDB instance. A region is managed by a rough group. Region can have replicas. By default, there are 3 replicas for a region. Here is an example layout of how data are organized. Key space are divided into several regions, and replicas for a region are replicated to different nodes. Now we have an impression how data are organized, but how does the replication work? We just mentioned a region is managed by a rough group. So we also use rough algorithm to do replication. If you don't know the details of rough algorithm, it's okay. Rough is simple, and we don't need to know all the details to understand the replication in TidyB. I will introduce the key points of rough to you. In a region, all replicas can have different roles. Most of the time, possible roles are leader, follower, and learner. A follower receives the majority votes from other followers, becomes leader. A leader is responsible to handle replications and provide latest view of its data to the clients. It also reports to PD for the configuration of the region periodically. Leader will also send habits to followers to ensure its leadership. If a follower didn't receive habits in a given time, it will start campaign. So if a leader crashes, a new leader can be elected in time. When TidyB servers wants to write data to a region, it will query PD for the metadata of the region first. So it will know how many replicas are available in the region and who is the leader of the region. It then sends the request to the leader. Leader will serialize the request into logs and replicates the logs to followers. If leader knows majority replicas have persistent logs to the disk, it will apply the log and return successful response to TidyB servers. The leader also replicates logs to learners, but leader won't count learner into majority. So learner can have almost the same data as the followers at any time point, but it won't slow down the leader's replication. It makes them very quick to be promoted as a healthy follower. This is very important for supporting dynamic configuration changes. When TidyB wants to read some data from a region, it will also query PD for available replicas first. Although I don't draw the PD cluster here. All replicas can serve reads. If leader receives a read request, it will read immediately if it's still leader. As I mentioned in the last page, writes are always sent to leader first, so leader always have the latest data. Read immediately is safe. But if leader cannot ensure it's still leader, it will broadcast habits to followers until the majority follower responds to the habits. The read request will have to wait on leader. If follower receives the read request from TidyB, it will, because follower doesn't know what's the latest data, so they will ask leader what's the current log index first. And leader sends back the latest log index and follower or learner have applied to the given index, they will start serving the request. To achieve load balance, we also need to move replicas around. So we support dynamic configuration changes. There are two approaches to do configuration changes. The first one is simple change. In simple change, we can do one change at a time. Changes are served as a special write. So the changes need to be accepted by majority replicas. The right picture is an example to show how this works. PD finds that a follower in AC2 is overloaded. So it decides to move the follower from AC2 to AC3. It will first ask leader to add a learner in AC3 first. After leader has replicates enough loss to the learner, it will ask leader to promote it into follower. In this time, there are 4 replicas in the region. And finally, PD will ask the leader to remove the replica from AC2. In this step, the configuration is changed from AC0, AC1, AC2 to AC0, AC1, and AC3. The replica in AC2 is moved to AC3 successfully. Simple change is very easy to implement, and each step is executed very quickly. However, simple change can lead to unavailability. Let's consider this case. PD wants to move the replica from one HiKV instance to another HiKV instance, and both instances are in the same AC. Let's say it's AC2. As I described in the last page, when using simple change, there will be a state that there are 4 replicas in the region. 2 of them are in AC2. If AC2 is unavailable, then there are only two replicas alive in the region. Remember that a region requires majority to serve writes and reads, so the region will also become unavailable. To solve the problem, we need joint consensus. In joint consensus, the region will enter joint state first, and when trying to add configuration changes. In the joint state, the new configuration and the old configuration work. Take the same case as an example. The remove replica and the new added replica are in different configuration. So there are 3 replicas in both configurations in all time. Even AC2 is unavailable. The replica from AC0 and AC1 still alive. So in both configurations, the majority replicas are alive. Then the region can still serve requests. Joint consensus is complicated but safer. All I have introduced are provided directly by rough algorithm, but commit group is something beyond that. We have taught that rough ensures that writes are replicated to majority before they are considered committed. But sometimes majority is not enough. For example, if we have 2 ACs and 3 replicas, there will be an AC has at least 2 replicas. Let's consider it as AC0. The AC0 can form the majority by itself. So the other AC may not have the latest data. If AC0 crash, then the majority of the region is crashed. Then the latest data is lost forever. The commit group is designed to solve the problem. We consider each AC as a group and assign replicas to the groups. We add extra constraints on how logs are committed. The first one is the old rule that the logs should be considered committed only after they have been replicated to the majority replicas in the configuration. And the second is new. All the logs have to be replicated to at least 2 groups before they are committed. So even AC0 is failed, we can still ensure that there will be at least 1 replica in the other AZ contains the latest data. The number 2 here are hard-coded at the moment because we think true AZ failure hardly happen. Commit group has another usage that allows follower replication. We assign a follower in a group as a delegate. If you process the logs from the leader and send it to the followers in the same group, take 5 replicas as an example. Delegates can reduce the bandwidth between ACs by half because the leader doesn't have to replicate logs to the other followers when there is a delegate. We have mentioned a lot of how PD removes replicas around, but how does PD make decisions? PD schedule replicas using placement rules. The rules can constrain the number of replicas, and it also can constrain the rough rules, like which replica should become leader. And it will also control the geolocation, decides where to place the replicas. The rules take effect within ranges. The range can cover one or several regions. When PD wants to make a decisions to a region, it will query the rule database about what rules should be considered, and it will generate a decision that best matches all the rules. For example, as shown in the graph, we can configure a rule to allocate 5 replicas for the metadata, as those data is small but quite important for the cluster, and all the other tables remain free replicas. That's all for the details of replication implementations. And now I will introduce several deployment cases to explain how these implementations guarantee consistency and safety. First is the classical free AZs. In this case, all replicas and leaders are distributed among free AZs evenly. As we mentioned before, graph guarantees majority safety. So even there is a AC down, the other 2 ACs can still form the majority and provide service. No data is lost. The disadvantage is all the data has to be replicated to at least 2 ACs. This is the price of data safety. And rewrite performance can also suffer if the leader TidyB server requested is not in the same AC of the TidyB servers, because TidyB servers have to send the request across ACs. This can be optimized by add placement rules in PD. Placement rules can require PD to schedule replicas and leaders to the specified ACs and nodes. For example, if we know that a table or a part of a table is accessed more frequently in an AC, we can schedule the leader of those regions to the AC. In such a way, we can reduce the replication across ACs between TidyB and TiKB. If the table can be accessed in multiple ACs, the placement rules will not bring much improvements, but we can also optimize the read request by using follow reads. Although follower will still need to send an RTC to leader to ask for the index, but read index is much cheaper than read keys. Free ACs tolerate one down AC out of box. However, it's expensive because the AC is more expensive than replicas, especially for the private cloud. So another common deployment case is 2 ACs. When using 2 ACs and still want to prevent data loss when one AC fails, in the classical way, it's recommended to use even number of replicas, for example, 4 or 2. But when choosing 2, the region will become unavailable even one replica is unavailable. So we usually choose 4. When using 4 replicas, all the data majority replicas must exist in both ACs. So either AC down won't lose data. But when either AC is down, the majority is unavailable anymore. So the region is also unavailable. This approach is expensive because back in the free ACs deployment, we only need 3 replicas to tolerate one unavailable node. But in 2 ACs, we require 4. Can we achieve both data safety and high availability in 2 ACs case with lower cost? The answer is definitely yes. With group commit, we can achieve both. We can use 3 replicas and also enable group commit. As we have mentioned before, group commit ensures only data written into 2 ACs are considered committed. So either AC is destroyed, the other will still contain the latest data. Data safety is guaranteed. And we usually choose one AC to be a primary AC and the other one is secondary AC. Primary ACs has more replicas. And comparing to the even number of replicas, in this case, if secondary AC fail, the primary AC can still contain the majority of replicas. So we can still make the cluster recover by removing the group commit. After that, the second AC will not be guaranteed to have the latest data. Does it sound like asynchronous replication in the master-slave deployment in the traditional database? Indeed, we follow the concept implemented in our way. This is the graph to show the state transitions. The state is managed by PD. At first, the cluster is in sync state. In this state, group commit is enabled, and data safety is guaranteed from failure of either AC. If secondary AC fails, PD will wait for its recovery for a configured time. If timeouts, PD asks all regions to disable group commit. The state becomes asynchronous. In this state, data is guaranteed to only replicate to majority replicas. Because primary is still alive, it can serve requests again. After some time, the secondary AC is recovered, and PD will ask all regions to enable group commit again. PD can set the state back to sync immediately because we guarantee data safety in sync state, but secondary state may not have enough data yet. So the cluster state is in sync recover. When all the regions have replicated the latest data to the secondary, PD transits the state back to sync again. In this talk, I introduced the GEO replication mechanism in TiDB. It uses rough algorithm to ensure atomicity and consistency. We use placement rules to reduce latency and bandwidth in multiple AC situations. We also introduce group commit to ensure safety across even number of ACs. We also use follow read and follow replication to reduce cross AC bandwidth. And if you have any other questions, you can ask me here or in the Twitter pin cap, or just add me BCJ. That's all. Thank you.
Awesome. Thank you, Jay. We've got looks like a few minutes for questions. So I'll throw one out there right away for you. I think there is another role candidate in the Raft algorithm. Is it missed in your slides?
Yes, indeed. Generally, a follower will become candidate first to start campaign, but the candidate role is not very relevant to the replication. So I omit it on purpose so that we can focus on the general replication mechanism.
Cool, thank you. And then one more. Is it possible to achieve high availability for just some of the tables instead of the whole database?
Yes. As I just mentioned in the placement rules, it's totally possible to configure different placement rules for different tables. And the placement rules operates on ranges. And if you just want to like configure the table 0, want to have 2 runners, and the table 2 has another followers, they will not be conflict with each other. And they can both operate, and they can both take effects in the placement rules.
Awesome. Let me check. It does not look like we have any questions in Slack at this time. So with that, I'll say thank you, Jay, for that talk. That was really interesting. And
okay, thank you, Mike.
Thanks. All right. So next up, I'll be passing on the hosting duties to Travis, one of my colleagues here at Percona. I believe he's joined.
Hey, Mike, how's it going?
Good, how about you?
Good, thank you, Mike. Excuse me. All right. Hey, all. I am Travis Butis. I am Percona's in-house attorney and senior compliance manager here. So I deal with everything related to, security questionnaires, compliance documents, legal documents, legal requests. Just about all things legal at Percona. And actually, we'll be hosting a talk, or we'll be doing a talk tomorrow on PCI DSS compliance and using MongoDB in a PCI compliant state. That will be at 9 a.m. Eastern, 7 a.m. locally for me, if you want to catch that. But right now, I'm here to introduce Robert Hodges. Robert Hodges is CEO at Altinity. He has worked with databases for 35 plus years, I believe, Robert. 20 different DBMS types ranging from pre-relational systems like M204 to MySQL to analytical databases like ClickHouse. He will be talking today about using, I believe, ClickHouse and MySQL in SQL data warehouses. He'll be going through things like exploring key technical differences like row versus column storage, sharding and replication, transaction models, and then discuss how to handle use cases that require the capabilities of both. So please join in. Feel free to ask questions on our Slack channel, and we'll make sure we get those to Robert at the end. Take it away, Robert, unless I introduced you incorrectly, in which case let me know, and we'll do that over again.
Sorry, I was having a mute problem. Can you see my screen okay? Just if you could confirm that.
Yep, we can. Absolutely.
Wonderful. Yeah, thank you so much for the intro, Travis. Before I get into the talk, I'd just like to thank everybody at Percona for helping to put this this conference on. I've been doing MySQL and Percona Live conferences for well over a decade, so it's great to be here, and I thank you so much for enabling this. So with that introduction, I'm going to dive in, and specifically what I'm going to talk about is comparing a row store to data warehouse and answering the question, which is right for your application. So just to, I'll skip the intro for myself since you've already done it. I am CEO of Altinity. We style ourselves as the enterprise guide to ClickHouse. We basically make large companies and small companies successful using the ClickHouse data warehouse. So we're a major committer and as well as community sponsor in both the US and Western Europe. And we're big enthusiasts of data warehouses in general and ClickHouse in particular. And I hope this talk I'll be able to share some of my enthusiasm, but I also want to communicate that I'm pretty enthusiastic about MySQL as well. So I think you'll see strengths of both in this talk. With that, let's go ahead and dive in. So what I'm going to do is just begin by looking briefly at MySQL, because I'm sort of assuming that most people on this talk have used MySQL or are generally familiar what it is. So we're going to look at specifically what we mean by a row store, taking MySQL as an example. So here's MySQL. If you never heard of it before, here are 7 things that would be useful to know about it. It's a single C++ binary, so all you do is start it and you have a running database. It talks SQL, like most self-respecting databases. It uses row storage, which means that when you think about tabular data, which is what SQL deals with, anything that's a row in SQL is a row in storage. So, and generally it's rows of data and then accessed through indexes. We'll dig a little bit more deeply into that in a second. It's designed for very high concurrency. So it is possible to have thousands of clients happily using single MySQL instance at once. And in fact, by scaling out with replication, you can handle many, many thousands of clients at once. Query is generally single threaded. So when you connect and do something, it's just one thread on one CPU core that's doing most of the work. There's some cases where it's parallelized, but it's very rare. It's a single server in general. So you can, of course, build out larger systems using replication. But in general, when you want to update something, you go to a single data, you go to the primary and do it there. And then finally, it's open source using a GPL v2 license. So this is the basic features. What I'd like to do, because storage storage is so important, I'd like to sort of dig down to how things are actually implemented. But to do that, I want to illustrate this with one of our favorite applications, which is airline on-time data. So this is a data set that is published by the US Department of Transportation, and it's got a row for every single commercial flight that's happened in the last 30 years or so in the United States, since about 1987. And if you're designing this in MySQL and handling this data, you're probably going to break it up into a set of tables. You've all read about third normal form. So you'll have a central table, which is called on time, and that has a single row for every leg of every commercial flight. And then it refers to a number of other tables. So for example, airports have a code which identifies them. And then they have a bunch of extra information like latitude and longitude, and we'll separate this out to avoid duplicating data. We'll do the same with time as well as carriers, which are our airlines. So this is pretty standard database design. Those arrows show you your foreign keys, and we also are just using a synthetic key, which is typically an auto increment integer, to number the rows so that we can join them easily. So far so good. You've probably seen a bunch of schemas like this. Let's dig down and see what's going on under the covers, because that's where it gets really interesting. So when you actually store the data for that core on time table, what you'll find is if you dig down into InnoDB, it's basically going to be stored in rows. So that means that any data from a row is going to be stored close to all the other cells in the row in InnoDB. It's going to be referenced through what we call a clustered index. So it's a B-tree index. It uses the ID value that I just described. And actually, the way that a clustered index works is you have the B-tree nodes, and then at the leaves, you have not just the ID itself, but you also have the data. So what that means is the data is stored in rows and it's sorted by these ID values. And if these ID values are auto increment, that means the data is effectively sorted in the order that it arrived. You then have additional indexes, which we call secondary indexes, and they are necessary because this is a large table. If we want to find something, we're going to have to define indexes which allow us to find things like the carrier. So for example, all rows for Southwest Airlines, we have a carrier index which would find them for us. And in row stores, if there's no index, generally speaking, if the query doesn't have enough, is not sufficiently specific, you're going to read the entire table. And what that means, and this is really important, is if you just want to find out something about carriers and flight numbers, if you do a table scan, you will read every cell. You'll pull it all in, process it, and then basically throw away 95% of the data. So this is a fundamental, this is sort of a fundamental design principle of databases like MySQL. And it's done for very good reasons, because it makes what we call online transaction processing very fast. If we need to do a lookup on a row, going and getting the row is really simple because all the information is there. So we don't have to look across multiple files. It's just all in one place. So it minimizes the number of reads. So we can do lookups, what we call, for example, point queries very, very quickly. We can also do updates quickly because we can get to the row. We can, the storage is structured so that we can change them quickly. It also supports very high concurrency, as I already mentioned. So single-threaded model, relatively low resources per connection. So we can, if we have a powerful system, we can support lots of concurrent users. Moreover, it has a good transaction model, so ACID transactions, so that if you're doing an application where consistency is important, for example, an e-commerce site, MySQL is great for this. And in fact, MySQL servers, just to illustrate their performance, with even not very powerful equipment, it's pretty easy to set up a MySQL server and get 1 million queries per second. That's really fast. On the flip side, if you want to ask questions that involve very long tables, so in other words, tables with vast amounts of rows, where the tables have many columns, in other words, they're very wide, where you're asking open-ended questions where you may not have, where you probably don't have an index handy that allows you to find things. And if you're doing a lot of aggregation, this particular structure is not very efficient. So as a result, when you get to data sets that run into hundreds of millions of rows and you start to do these kinds of analytic queries, asking general questions or trying to compute aggregates very quickly, MySQL is generally speaking not the right choice. So with that, having set that up as sort of the default database, it's now interesting to look at what a data warehouse can do and how it works to solve this problem and deal with this other kind of query. So what I'm going to do now is just dive into ClickHouse and compare how ClickHouse is organized to what we just saw in those few slides, and then you get sort of a sense of how they work, what sort of problems they can solve. So ClickHouse, again, 7 things you'd want to know about it if you'd never heard of it before. It was originally developed by Yandex, now open sourced. It's a single, like MySQL, a single C++ binary. So you just start it and you have a data warehouse running. It'll run perfectly well on your laptop. Like MySQL, it speaks SQL. And then there's some big differences. So instead of rows, we use column storage. So every column is stored separately. You can think of it as a bunch of compressed arrays. And in fact, we have not only compression, but what are called codecs, which I'll explain in a minute, that allow you to make the data very, very small within these arrays. We have what's called vectorized query execution. So what that means is we can break these these arrays as we're processing up into pieces, farm them out to all the available cores that we have, and process them in parallel. Moreover, we have the ability to process in parallel across multiple nodes, so multiple servers running on different hosts, because there's built-in sharding and replication. And then finally, like MySQL, it's open source, only it has a different license. So it's Apache 2.0, a little bit more flexible. You can do whatever you want with it. So those are the basic features of ClickHouse. And to illustrate them, what I'd like to do is just show a table definition. So I kind of skipped that. I showed a picture of it, but here for MySQL, here for ClickHouse, here's the actual syntax. And it's interesting to look at because it's a little bit different from MySQL. One of the things I'd like to draw your attention to is this thing called an engine, which, like MySQL, ClickHouse has engines, only there are a lot of them. There's 40 or 50. The engine that we most commonly use is called merge tree. That's the standard column store. I won't go further into them, but it has a couple of properties that are really important. One is it has a partition key, which tells us how to break the table up into pieces so that they can, so that we have an organizing principle and don't have to read all the pieces all the time. And then within those pieces, we're going to have an ordering, which is, in this case, by the airline carrier and the departure time. So this is significant because of the way that it has some interesting effects on compression as well as performance. And then finally, speaking of compression, there's this keyword, which is non-standard, but called codec. And what that allows us to do is explicitly control the compression as well as transformations that are run on the data before they're compressed. So we'll talk about that in a minute. I just want to say that if you do nothing, if you don't include this keyword, all of your data is automatically compressed with LZ4. So you get out of the box compression that tends to be pretty good. We'll see examples of that in a second. So if we now dive down and look at what's going on under the covers with this table, there's one more thing that's interesting to note in this table definition, that not only we have this on-time table, but unlike the MySQL schema, we've actually added additional columns. We've denormalized it so that, in fact, this table is quite wide. It has 109 columns in this particular example. So we're already taking advantage of the fact that we have a column store, and as you'll see, the columns are less costly for queries. So here's the structure. As I said, columns, we've already discussed that. It has an index, but it's different from the type of index that you have in a database like InnoDB. It's what we call a sparse index. So it basically gives us a way of quickly finding particular rows in the sort order. So all the columns, and here's an example down below, there's an entry in this by default for about every 8,000 rows or so. It's called a sparse index. And the idea is if we're looking for a particular row, using looking it up by the columns in the order by, we can go down into this index, we can find a row or a group of rows, and what it'll do is we'll get a pointer which gets us within 8,000 rows, and then we'll go out and we'll read compressed blocks. So from each of the columns that are referenced in the query. So right away, we don't read single rows. We tend to read them in blocks of 8,000 or more, but we only read the actual columns. So that has an interesting impact. So let's look at that. What that means is there's effectively no longer a penalty for wide tables. And this graph right here just shows you the distribution of the data in this table. And the yellow bars, there's 109 columns here. The yellow bars are uncompressed. And what that means is that, for example, if you only refer to 2 columns, you on average will only touch about 2% of the data. The other 98% are just never looked at. So there's no penalty for your query speed. It gets even better though, because of compression, in fact, when we do go and touch a query or touch a column, there's a chance we're going to read far less data than we would in a row store. And the reason for that is that we can get very high rates of compression in each of these columns. So the actual amount of data that we have to read is shown by the blue columns, and it's around 20% or so of the total uncompressed size. So this is a big difference, and already means that we can now do table scans, in other words, scans without indexes very efficiently. What I want to do now is look a little bit in more detail about how compression works, because it's, as I said, it's on the columns. So there's kind of 3 steps that you can think about. There's the data type, which determines your size. There's the codec, which is an optional transformation. You can do 0 or more of them that will turn the data into something else before it gets turned over to the last part, which is compression. So for example, if we're storing things like airport names, of which there are about 7,000 or 8,000, we use a data type called low cardinality. It's low cardinality string specifically, which is a dictionary encoding. So instead of storing the airport code, we're actually just going to store an integer. And then in this particular example, we don't have a codec, so there's no further transformation, and then it's just handed over to LZ4. Another example, we have a uint32, and we apply double delta on it, and then we apply ZSDD compression to it. So double delta is a codec which says instead of storing the integers, store the slope of the integers. And if you have monotonically increasing integers, that means you might store 0 or just a couple bits for each in the place of each integer. And then you hand this over to ZSDD compression, which is a very efficient, a very powerful compression algorithm. You can now compress the data enormously. So here's some examples of what that actually does to your data. So for example, the carrier name, which is typically just a string, a short string, if you do nothing to it, and let it be compressed by LZ4, we can get it down to something like 5.6% of its size. If we assign low cardinality or use this dictionary encoding and LZ4, it gets way smaller. Similarly, for flight dates, we can go, compress it with LZ4. It compresses very well because it's following the sort order. So there's a lot of repetition, but we can also store it in double delta and apply a ZSDD, and it gets even smaller. So these are enormous compression rates. They're in the 4th example here, we're compressing the data by about 300 times, which is pretty good. Of course, nobody's perfect. The last one is an example of a column where we're just handing it over to LZ4. It is a string, has a lot of variation. So it is, and we haven't done any special codecs, so it's a bit bigger. We could fix that by tweaking the schema. So this really enormously reduces the data. On top of that, we can speed up the query thanks to the vectorized query execution. We can let ClickHouse decide how many CPUs to use or cores to use. It'll do it automatically. Or we can set them ourselves using this max threads parameter. And you can see, for example, as you jump from 2 to 4 threads on this 4-core CPU that I was running it on, you get a big boost in query performance. It drops off pretty fast after that, in part because there's some things that have to be done in a single thread, like ordering. And also, this is actually only a 4-core machine, so I think we're getting some contention among physical threads on the cores. Even more, and this is again, sort of focused on things that make these, make these queries, make ClickHouse particularly suitable. It's pretty common that you're actually computing aggregates, like how many flights per day, how many flights were late, how many flights were canceled, how much were they canceled by carrier, for example, or by destination or origin. If you know what the queries are in advance, you can compute what are called materialized views, where you basically do at least part of the aggregate in advance. And what this does is it can, again, further reduce the amount of data that you're dealing with. So for example, I can do a query which is trying to find the number of late flights, late or delayed flights. I pre-aggregate it, and the result is I get a table which has just this information. and it's really small. It's just a couple of megs. So that means instead of looking at a table which potentially could be up to 15 gigs, I'm looking at a table that's only about 2 megs. So and as I do queries on this, because I read less data, I get a 50 to 100x query speed up. And this is on top of the effects of compression and things like that. So what this means is this allows you then to get query results which are down to a few milliseconds in some cases, as long as you anticipate the query. If that's not enough, you can add more servers. So data warehouses in general are very good, sort of developed into distributed systems early on. And ClickHouse, MySQL has, of course, replication, as I think everybody on this talk knows. But ClickHouse has a replication that's built in and includes both replication as well as sharding, and the ability to have a table. You can create what's called a distributed table that will span local tables on multiple hosts. And so you can shard your data, you can have it automatically replicated. If you just put it in, you can write to any of the replicas. It will then be asynchronously replicated out to the others that don't have it yet. And so you can get more concurrency with your replicas as well as get HA, and then the shards increase your bandwidth for reading and writing. And when you do it properly, you basically get linear scaling across servers. This is a simple example of a kind of heavy query over 173 million rows, not very powerful machines. But you can see that in this graph, both in cold runs where nothing's in cache as well as hot runs where things are in cache, we essentially get linear scaling by spreading these queries out. So these are major features of ClickHouse. There are many more things, but I think it allows us to just circle back and do a quick contrast between ClickHouse and MySQL, but to view it in the lens of transaction processing versus online analytic processing or analytic queries. And what we see is that with this different structure, the strengths of ClickHouse are kind of the mirror image of the weaknesses of MySQL. So